Hello world! My name is Yanis.
My name is Pedro.
And we are delighted to welcome you to Espressif DevCon22.
This is the first Espressif conference made by developers for developers. We are broadcasting live from the lovely city of Brno in Czech Republic for this two-day online conference, which will bring to you content about products and solutions created by Espressif and its partners.
A nearly 6-month preparation is reaching its culmination with a truly rich program. We will present you more than 30 talks on such topics as Matter, RainMaker, ESP-IDF, Privilege Separation, Embedded Rust, Component Manager, Board Support Packages, third-party frameworks, and more. We have loads of Espressif engineers who will deliver their presentations over the next couple of days. But we're also delighted to be hosting guest speakers from Microsoft, Arduino, Adafruit, Golioth, Wokwi, and Toit.
Now, let me give you a brief idea of the conference structure. The daily schedule of the conference is divided into 4 sections lasting 2 hours each. Every presentation is allocated a 30-minute slot, which will comprise a talk and a 5-minute Q&A session at the end of it. A 15-minute break will follow each 2-hour section at the end of each day. We will have a 15-minute general Q&A session for questions from the audience.
So, ladies and gentlemen, girls and boys, without further ado, let Espressif DevCon22 begin. We will kick off our conference with none other than Espressif's founder and CEO, Swee, who is about to deliver his welcome speech from Espressif's headquarters in Shanghai. Swee needs no special introductions. He established Espressif in 2008, and his name has become synonymous with technological innovation ever since. It is always interesting to listen to what he has to say. So, Swee, over to you.
Everyone. I'm the CEO of Espressif Systems. My name is Swee. I warmly welcome all of you to Espressif's first Developers Conference. While this is our first Developers Conference, Espressif has had a very long and fruitful collaboration with the community all these years, starting all the way back from ESP-8066 since 2014. As AIoT encompasses so many different industries and domains, and is still rapidly evolving, innovation is of the highest priority. We believe in the developers and the community to drive this innovation forward with us. Our products and services reflect this philosophy through our easily available development boards, the documentation and specifications that you can obtain without signing an NDA, and open source software and tools. Espressif builds everything that is needed to create connected, intelligent devices, from the connectivity chips, the modules, the SDK, to the cloud and everything that's in between. With the ESP32 series chipset, we provide microcontrollers with Wi-Fi and Bluetooth connectivity and computational capabilities to address both edge AI and IoT applications. We have recently announced ESP32C6, ESP32H2, and ESP32C5 chipsets. They provide 802.15.4 radio for Thread and Zigbee, Wi-Fi 6, and dual-band Wi-Fi 6 support to provide more connectivity options. We also strongly believe that all connected devices out there need to have sufficient security. And we have certainly learned a lot from the community about this. You can use any of the ESP32 series chipset to build devices that users can trust. We are driving quite some innovation in affordable security of connected devices. Power consumption is also very important. We are continuously working to improve it to help you build devices that have a smaller carbon footprint and work towards creating a greener future. That you are attending this developers conference means that you probably are an IoT systems developer, not only using our chipset or hardware module, but also working with our open source operating system and software that we have built collaboratively. ESP-IDF is our open source operating system that powers all our ESP32 series chipsets. It currently runs on about 500 million devices out there. We have built multiple SDKs and frameworks that help with specific applications. For instance, you may have used ESP-IDF for audio applications development, ESP Jumpstart to learn step-by-step product development, ESP-80 or ESP hosted to use Espressif chips as a communication processor, and ESP-Box to try some of our other frameworks. We also have ESP RainMaker, which helps you create your own IoT cloud platform, and ESP Insights service, which provides remote debug capabilities for your device. The upcoming Matter protocol is going to fuel further innovation for connected devices through their interoperability. Many companies and the community are working towards the goal of creating a high-quality implementation of the specification. Espressif is not just contributing to support Matter on our chips, but also actively contributing to the overall development. Espressif is about making engineers working with our solution more efficient, more creative, smarter, and more expressive, so that you can concentrate on developing your IoT application without having to reinvent the wheels, such as designing the hardware module, matching the antenna, clearing certification, setting up secure manufacturing, designing communication security, designing password provisioning, creating over-the-air firmware upgrade, creating a cloud backend to collect your data, or embedding diagnostics in your product, etc. In general, Espressif is about helping you develop good IoT products better and faster. Espressif engineers are in China, the Czech Republic, India, Brazil, and Singapore, where I'm from. Our engineers have prepared interesting sessions for this DevCon. These sessions cover many of the topics that I've touched upon here, and others. We hope we provide you with more insights into our product and about where we are going. And also, we value this opportunity to hear from you. We have always listened to our valued customers, developers, and the community. We cherish your feedback because Espressif is about creating products that you like. Thank you. Bye-bye.
It was a talk packed with loads of information. Thank you to you, Swee. Okay, coming up next is a joint presentation by Espressif engineers Chen, Hrishikesh, Dhayagude, and Shubham, Patil. They will talk about Espressif solutions for Matter. Matter is an industry unifying standard that provides reliable and secure connectivity for smart home devices. Espressif, with its unique combination of connectivity solutions, hardware and software, makes it easy for our customers to build Matter-enabled smart home devices. This presentation, like everyone else, will be complemented by a short Q&A session based on your questions. You can post them throughout each presentation to our YouTube conference chat. Then, at around 20 to 11 Central European Summer Time, Espressif's Piyush Shah from Pune in India will talk us through the features of Espressif's commercial cloud ESP RainMaker, as well as the ways in which it enables the development of your IoT products. Our morning session will finish with Espressif's Darian Leung from Shanghai. To be honest, I haven't seen him in a while, so I'm really pleased to see him this morning, even virtually so. Darian will talk about FreeRTOS in ESP-IDF. Then we'll have a 15-minute break. But first, let's listen to the presentation about Espressif solutions for Matter. Guys, over to you. We're all ears.
Hello everyone, welcome to the Espressif Developers Conference 2022. I am Hrishikesh, and in today's session, we'll talk about Matter, a new smart home ecosystem protocol. We'll look into what Matter means to us, its advantages, and deep dive into its features. After that, we'll talk about Espressif solutions for Matter. So now, let us take a look at the agenda. First, we'll have the introduction to Matter. Then we'll talk about the Matter data model. After that, we'll talk about commissioning. Commissioning is the process by which a Matter device gets added into the Matter network. Post that, we'll talk about multi-admin. Multi-admin is the way through which a single device can be a part of multiple Matter ecosystems, in a way fabrics at the same time. Then we'll talk about device-to-device automations an interesting concept in Matter that facilitates seamless communication between devices. After that, we'll talk about OTA firmware upgrades for Matter. This will be followed by bridges for non-Matter devices. And finally, we'll talk about Espressif solutions for Matter. So let's get going. Matter, previously Project Chip or Connected Home or IP, is a new working group within the Connectivity Standards Alliance. This new and royalty-free standard aims at creating more compatibility between the devices in the smart home. Matter is a unified framework for connected things. The Alliance has collaborated with the industry leaders for the implementation and the development of the spec. Matter is an open, secure, and reliable protocol. It seamlessly integrates with all the ecosystems that are available. Now, let us take a look at the protocol stack diagram of Matter. As can be seen, Matter is an application layer protocol for the local network. It runs on both TCP as well as UDP. For the current v1.0 release of Matter, only UDP is supported. Matter is IP-based, typically IPv6. Currently, it works on Ethernet, Wi-Fi, and Thread. Bluetooth Low Energy is used for commissioning or setup. Now let us take a look at what Matter means to us. First, for the end users. No more silos. Gone are the days that a vendor-specific app was required to control a vendor-specific device. With Matter, any Matter-enabled app can control any Matter-enabled device. Furthermore, companies like Google, Apple, Amazon, and Samsung have already committed to Matter, which means that their devices would support Matter out of the box. This implies that you might not even require a separate phone app to control a Matter device. Your mobile phones or your voice assistants can natively do it for you. More automations. Matter provides a seamless way to facilitate communication between devices in the same Matter network. For example, if you have a light switch and a light that are into the same Matter network, they can communicate with each other. Multiple transports. Matter facilitates multiple transports like Wi-Fi, Ethernet, and Thread. For transports that are not in the Matter framework, those are facilitated through the Matter bridges. Better security. The Matter specification has baked-in secure features. Those are reviewed and approved by the best in the tech industry. This implies that the Matter devices that will be certified are better secure and as they are based on well-reviewed and better specifications. Now, let us see what Matter means to the device makers. The advantages for the end users apply to the customers of these device makers. Apart from that, the other advantages are ease of development. Now, the device makers won't have to go through the pain of supporting and certifying multiple ecosystems. This will lead to reduced overhead of engineering effort, cost, and time, thus leading to faster products. Power of the open. The Matter implementation is in the open source. It supports a variety of vendors. It means you can prototype, validate, and productize your devices in the shortest possible time. Device-to-device automations. If you are a device maker who creates products like switches and sensors that need to work in conjunction with other devices, then Matter is like a good news for you. With Matter, you don't have to worry about what will the customers tie the output of your devices to. It will be taken care by the Matter protocol. Now, let us take a look at the Matter data model. Data model is the way in which the data is represented. The following are the elements of the Matter data model. First is the Matter node. A node is an addressable entity that has the Matter protocol stack running. A node has multiple endpoints. Consider endpoint like a virtual device. The Matter specification has combined together a common functionality into something called as device types. Endpoints are further divided into clusters. Clusters represent a common functionality that can be presented in a reusable way. Clusters can be server clusters or client clusters. Server clusters have attributes and client clusters operate on them. For any kind of communication between two Matter devices, it always happens through the clusters, the server cluster and the corresponding client cluster. Clusters have attributes, commands, and events. Attributes are entities that can be read or written to. Attributes are volatile or non-volatile. Attributes can be read only or read and write. Commands. Commands invoke a specific behavior on the cluster. Commands can be like read, write, subscribe, invoke. Events. Events indicate a change or an update in the system. Now let us take an example so that the data model is more clearer. The diagram shows a luminaire node that has a dimmable light and an on-off light. As can be seen, on the top, there is endpoint 0. Endpoint 0 is a reserved endpoint, which is the root node device type. It has the functionality that is applicable to the entire node. It includes clusters like ACL, commissioning, basic information, and OTA. In the center is the endpoint 1. It is the application device type, which is the dimmable light in this case. It has two clusters, the on-off clusters that has attribute on-off and commands like on, off, and toggle, and a level control cluster that has current level attribute and command like move to level. At the bottom, there is endpoint 2, which has the on-off light device type. Again, it has the on-off server cluster with attribute on-off and commands like on, off, and toggle. Let us now take a look at the commissioning process. Commissioning is the process by which a device gets added into the Matter network. It starts when the device announces its capability over BLE. If the device has IP connectivity, it does so over MDNS. The commissioner then scans a QR code on the device and gets the setup passcode and other metadata. This setup passcode is used to establish a secure session called as PACE. PACE is based on SPAKE2+ protocol. The subsequent messages are now secured with PACE. The next step is device attestation. Device attestation is the way through which the commissioner validates that the device is a valid or legitimate Matter device. Once the device attestation is complete, the next step is operational credentials. Operational credential involves the commissioner installing an operational certificate onto the device. This operational certificate has an entity called as node ID that defines uniqueness of a device in the Matter network. All the Matter devices that share the same root of trust are a part of the same Matter fabric. The next thing is access control. Access control defines who controls what. There are different privileges of access control defined, like view, operate, manage, and administer. The device is then installed with the appropriate access privileges. The next part is network commissioning. This step involves giving IP connectivity to the device. If it is a Wi-Fi device, it is installed with the details about the Wi-Fi network. If it is a thread device, it is installed with the details related to the thread network. Once the device gets IP connectivity, it starts operational advertisement over the IP network. The commissioner then discovers the device on the IP network and establishes a secure session called as case. The node operational certificates that are installed in the operational credential step are used for this case establishment. This is based on the Sigma protocol. After that, all the messages that are exchanged between the two devices are secured with case. With this, the commissioning is complete. Let us see a demo video of the commissioning process. With ESP Launchpad, you can easily try out Matter on Espressif SoCs without having to do any kind of setup or installation. Here it goes. Now, let us take a look at a multi-admin feature. Through multi-admin, a device can be a part of multiple ecosystems or matter fabrics at the same time. As can be seen in the diagram, there is a light bulb at the center, which is already a part of two ecosystems or matter networks. Ecosystem A from organization 1, seen in green, and ecosystem B from organization 2, seen in red. As you can see, the light bulb has identity XYZ in the ecosystem A, whereas it has identity PQR in the ecosystem B. As a result, the iPhone and the smart wall switch on the ecosystem A can control the light, while the voice assistant in the ecosystem B can control the light simultaneously. The next question is, how is this facilitated? So once the device gets commissioned for the first time, the current administrator opens a commissioning window and the next administrator can commission the device into its network. The total number of node IDs on the device is equivalent to the total number of matter fabrics that the device supports. Now, let us take a look at an important or an interesting concept in Matter, which is device-to-device automations. Matter facilitates communication between devices without having to go through a cloud, a phone app, or a skill. Let us take an example for that. As you can see in the diagram, on the right-hand side, there is a light. At the center, there is a switch. And on the left-hand side, there is a phone app or the commissioner. The light has the on-off server, whereas the switch has the on-off client. Once both of them are commissioned into the same matter network, the commissioner can bind the light to the switch. In short, now the switch knows the address of the light. The switch can then discover the light and establish a case session with it. After that, any action on the switch is reflected onto the light. This is a part of the synchronous control for the device-to-device automations. There is another way through the asynchronous notifications. Let us take an example for that. On the right-hand side, you can see an occupancy sensor that has the occupancy sensing server. In the center, there is a thermostat that has the occupancy sensing client. On the left-hand side is the commissioner. The commissioner first commissions both the thermostat and the sensor into the same matter network. Once that is done, it can bind the sensor with the thermostat. After that, the thermostat establishes a secure session that is case with the sensor. Thermostat can then subscribe to attributes on the sensor, say the occupancy attribute in this case. Then, when there is any change in the occupancy attribute, the same is reflected or reported to the thermostat. This is nothing but subscribing to attributes. Similarly, subscribing to events is also possible. When a particular event occurs, the same is reported to the client. With this, I'll pass on the mic to my colleague Shubham, who will talk about OTA and bridges in Matter. Thank you.
Hello everyone, I'm Shubham and now we'll talk about Matter OTA functionality. Majority of the IoT device requires security as well as feature upgrades in their lifetime. There shall be some way to upgrade an IoT device. Matter standards has already defined a way to upgrade a device. It contains a node which implements a device type called OTA requester. It contains a node which implements a device type called OTA provider and distributed compliance ledger. The flow is like an authorized user uploads an OTA image to distributed compliance ledger. Then OTA provider downloads the OTA image from distributed compliance ledger and forwards it to the OTA requester using Matter protocol. Distributed compliance ledger is a distributed information system which contains information related to the vendors, certification related details, and OTA URLs. Now, let's talk about Matter Bridge for non-Matter devices. Matter Bridge enables Matter devices to communicate with non-Matter devices. If we look at this example, this Matter controller app can communicate with ZigBee Lite. Matter bridge translates between the Matter protocol and a ZigBee protocol. Matter bridge also forwards the commands received from a Matter node to a non-Matter node. Also, Matter bridge exposes the ZigBee Lites to the Matter nodes using its data model. Now, let's look at the data model of Matter bridge. If you look at the topmost block, that is endpoint 0, it contains a descriptor cluster with the parts list that contains bridged as well as non-bridged devices. Additionally, it contains an endpoint which has a device type aggregator. The parts list of that node, that endpoint contains the bridged nodes. In this diagram, if you look at the green block, its parts list contain endpoint 11 and endpoint 12. So the last two blocks are the endpoint 11 and endpoint 12. That contains, so let's look at endpoint 11. It contains a descriptor cluster, and its descriptor cluster contains a device type list. So in there, the endpoint 11 is an extended color light, and endpoint 12 is a dimmable light. So that's how a Matter bridge exposes the non-Matter devices to a Matter nodes. Along with the descriptor cluster, endpoint 11 and endpoint 12 has additionally bridged device information cluster, which contains basic details like vendor ID, product ID, its software version, and some more details. Now, I'll hand over mic to my colleague Shu. He'll talk about Espressif's solution for Matter.
Hi everyone, this is Chen Shu from Espressif. As Hrishikesh and Shubham shared in the previous session, there are so many wonderful features and advantages in MAT protocol. Now, let me talk about the Espressif's one-stop MAT solutions. I will introduce Espressif's MAT platform solutions and Espressif's SDK for Matter, as well as some additional services that we provide to our customer, which would accelerate our customers' Matter products' time to market. Before we look into the platform solutions, I'd like to share a typical Matter topology in the real life. From the topology, we can see a Wi-Fi light, a Wi-Fi switch, and a thread thermostat. A thread border router is required to connect the Wi-Fi and thread network on the IP layer. All these devices could communicate with each other within the local network. No need to go through an app or cloud. On the right side, there is a MAT bridge device. Bridge is one of the useful features in Matter, which allows the use of non-Matter devices in a Matter fabric. For instance, a Matter Wi-Fi switch controls a BLE mesh light, or a Matter thermostat subscribes the temperature data of a ZigBee sensor. Espressif provides customers with platforms that cover all these Matter devices. Our Wi-Fi-enabled SoCs and modules, such as ESP32, ESP32C, ESP32S series, all can be used to build a Matter Wi-Fi device. Our newly announced ESP32H SoC and modules integrated with 15.4 can be used to build Matter thread device. By efficiently combining Espressif's Wi-Fi and thread technology, the thread border router can be built to connect the Wi-Fi and thread network. With the same hardware, a MAT ZigBee bridge device can also be built to bridge ZigBee devices to the Matter fabric. Finally, a Matter BLE mesh bridge can be built on a single ESP SoC with both Wi-Fi and BLE interfaces. Now let's come to the software part. Espressif's SDK for Matter is built on top of ESP-IDF and the open source Connected Home IP SDK. ESP-IDF is Espressif's official IoT framework, integrated with rich, commonly used features and components to build AIoT products, which already powers millions of connected devices worldwide. Beyond the open source Connected Home IP SDK, Espressif SDK for Matter provides a bunch of features and tools for Matter productization. The SDK and docs are all now available on GitHub. The SDK provides simplified data model APIs. The developers can use these APIs to define their own Matter devices quickly. For example, if you want to define a standard matte color temperature light, you can achieve that in a few lines of code, just like this. Of course, you can also add optional or custom features like clusters, attributes easily with the APIs. The SDK also provides rich device types, commonly used drivers, and production-ready examples. We also support the mechanism to run Matte and other applications together on your device. So you can add Matte feature support to your existing products, which already run some other applications. We also provide rich tools and utilities for manufacturing and mass production. This is an often overlooked but a critical component of the device development lifecycle. By using Espressif SDK for Matter, we aim to further simplify and accelerate the development process of Matte products. Now here comes the ESP thread rollout solution. The SDK is built on top of ESP-IDF and OpenThread. It's RTOS-based, so very cost-effective comparing to the Linux-based rollout solutions. It's compliant with the latest Thread 1.3 and supports Matte application. Also, we provide ESP Thread rollout dev kit and reference design, which integrates the RCP update and IF coexistence design. You can now access the SDK from GitHub. Besides the platform solutions and software SDK, we also provide some additional services to our customers. For example, the certification service. The CSA Matter Working Group defines very strict and detailed certification program, which could make sure that Matter products from various device makers could work together securely and seamlessly. Espressif joins the certification program from the very beginning. We can provide our customers the certification services and support them whenever necessary. Also, Matter requires per device unique certificates and a secure manufacturing process. Espressif will provide the pre-provisioning service for Matter, where we will ensure that the modules are programmed securely and the security features are enabled before shipping them out. Espressif will also optionally offer baked-in DACs in modules, so our customers don't need to worry about the PKI service or DAC generation. Furthermore, we will introduce special modules and product-level firmware for standard Matter devices. Without writing any code, the licensed customers can build standard Matter devices with a simple configuration, which greatly reduces R&D investment. By the end, let's watch a demo video. It showcases Espressif's Matter solutions. Thank you.
Hi everyone, I'm Kedar, Senior Director of Engineering for Espressif Systems. At Espressif Systems, we build connectivity solutions for Wi-Fi, Bluetooth, and 802.15.4 based devices. Here we have a demonstration which shows the typical classes of devices that are supported by Matter. We'll talk about a Wi-Fi end device, a Thread end device, and the border router, a Matter gateway that bridges to Zigbee device, and a Matter-based controller. As you can see here, we have assembled a bunch of devices. They have already been commissioned into a Matter fabric, and we have defined device bindings so that the appropriate device controls the right devices. Let's get on with the demo. First, we'll talk about Wi-Fi based end devices. Here you see a Wi-Fi switch that is going to control this fan, which is also a Wi-Fi fan. When I switch on this device, as you can see that the fan has turned on, and when I press it back again, the fan has turned off. As you might notice, this communication has happened over Matter Wi-Fi. Now we'll look at this part of the demo. Here we have a thread-based light and a Wi-Fi based occupancy sensor. Connecting them together is also a thread border router that will ensure that the thread and Wi-Fi sites can talk with each other. As I make the movement in front of the occupancy sensor, the light comes on. The Wi-Fi device in this case has connected to the thread end device and operated upon it. Moving on, we'll now look at the Matter bridge. Here we have a door sensor, which is a typical off-the-shelf Zigbee door sensor. It is part of the Matter network through this Matter bridge. And in this case, it will now be controlling this light, which is a Wi-Fi light. As I open the door, it will switch on the light, and as I close the door, it will switch off the light. In this case, the communication has happened through the Matter bridge, again, completely over Wi-Fi. Finally, we come to the last device type, which is a Matter controller. As you know, Matter allows completely local network-based device control. In this case, what we have is a device which looks at all the devices that are available in the house and shows them in this display. I can turn them on or off through here. Additionally, this SoC also has local network-based voice recognition. So I can give voice commands and it will act upon those completely on the local network without having to go to the cloud. Let's try it out. Hi ESP, turn on the light. Okay. As you can see, the light has now been turned on. And then I can always turn it off using the display. That's all for the demo today. Thanks, folks.
Okay, we are back live from Czech Republic for the Q&A session, but before going to the Q&A session, I'd like to introduce my colleague here, Vojta.
Hello, nice to meet you all. It's glad to be here, and I will be today and also tomorrow helping with the broadcasting, with the setup and so on. So don't waste time with our speaking, and let's invite our speakers of the previous talk, and we can start the Q&A.
On StreamYard.
Okay, guys, so you are live. Welcome here. The stage is yours for the questions. Did you sort or see some interesting questions during the talk in the comments, or you have some here in the live?
Hello.
Yes, we can hear you.
Yep.
Okay. You can go ahead.
Yeah. So, hi folks, this is Hrishikesh. We have tried to answer as many questions as possible over chat. Apart from that, we see a few questions that generally come from our users or customers. So maybe I'll just throw some light on those questions. So the first thing that we generally hear is when will Matter launch in a way, and when we'll see Matter devices on the shelves? So the answer to this is that Matter has already launched in a way on 4th of October 2022, which means that the certification program is now open. People using the devices can go to certification now, and once the certification is ready, done, you can see or expect Matter devices onto the shelves, which is early next month. So one more question that we generally see is trying to understand the relation of Matter with cloud, or there was one question related to MQTT as well. So just to explain on that, Matter only talks about local network. Matter protocol does not include any kind of cloud communication in the specification, right? So anything related to cloud or any MQTT connection or communication that you want to do has to be done out of the band. Yeah, I see a question in the chat which says, will ESP-based Matter solutions require additional certifications by us? So ideally, it shouldn't require any kind of additional certifications, because the base certification would be done by us, and using the certification, what to say, different policies in there, the customers can create derived certifications based on the first level certification that we create. And apart from that, Wi-Fi and Bluetooth related certifications are required, but those would already be done by the Espressif SOCs.
Okay.
So guys, do you see any other question from the chat that could be answered? So we can try to give a little bit more information about Matter. So
yeah, so there was one question which again, which is a general question about how do general users or regular users try out Matter? Is it possible through any of the, what do you say, phones that are possible? Because in the video we talk about the native support in Android and iOS. So the plain answer to that is yes. At this point in time, people can try out Matter using their Android and iOS phones. A hub is required for that, and there are certain instructions which are given by both Apple as well as Google for that, which we would maybe enter in the comment section, the links to the corresponding documentation, so that it is easier for folks to try that out.
do you have still time?
Okay, perfect. Thank you for the answer, guys.
Okay.
Anything else interesting in the chat? You have catch up? Perfect. Thank you for the answer, guys.
Okay, I see. Just go up.
Yeah.
So there was a question about if someone has an application that is built outside Matter, how can that be integrated with Matter? So the simple answer to it would be integration of Matter with that particular whatever functionality that is being achieved by the existing application is required, but that integration should be easy in a way, because Matter, once you get the IP connectivity, then you can control your devices using Matter. So you just have to integrate your code base in such a way that Matter can be what to say, triggered to give you the IP connectivity, and then you can do anything on top of that. In addition to that, if you have any specific data model of your own, say you have light bulb, you have your own characteristics like brightness or state, whatever it is, those will have to be mapped to Matter so that they actually take effect.
Okay, thank you. I have one more question here from the chat, and I think probably we are just running on the top of the time, so it will be the last one. I will just show it, highlight it. So if you can answer this one, it's basically if you think if the Matter is the more consumer products oriented specification, or do you think that it makes sense also in enterprise solutions?
I think for now it is more towards the consumer products. So, Shu, what is your sense out of it? Okay.
Okay, so can you hear me?
Yeah.
Okay, great.
Okay.
Yeah. Okay, so can you hear me?
Yeah. Yes.
Okay,
great.
Seems some problem with my
Yeah.
my audio.
Okay, so can you hear me?
Yeah. Yes.
So to me, I think some benefits for the Matter part. So I think firstly, it resolves the interop among the different device makers and ecosystems. So a device maker make Matter devices. It can work together with the other devices from the other brands, and even work together in the different ecosystems. For example, you can build Matter devices to work with the Google or Apple or Amazon's ecosystem together. Yeah, so to me, I think Matter is the most benefit for Matter. Yeah.
Perfect. And we have like last one nice question is from some beginner, and it's basically how we can start with Matter. And this will be the last question for you guys. How we can start with Matter?
You can go to the GitHub repository of repository to get started. So we have github.com/espressif/ESP Matter.
And that is accompanied by a series of blogs as well. We have a documentation for the Espressif's SDK for Matter as well. What we'll do is maybe at the end of this Q&A, we'll add the links, appropriate links into the comment box.
Okay, guys, thanks a lot for joining. The Q&A is over. If you still have any questions regarding the matter and the talk, you can just write the questions in the chat or just use the feedback form on the espressif.com. And I will now, guys, remove you from the stream, and we will fluently jump into the next talk. So see you after the next talk in the next Q&A with other speakers. Thank you a lot. Let's continue.
Welcome to the Espressif Developer Conference 2022. Today we are going to talk about ESP RainMaker. ESP RainMaker is a commercial cloud for your IoT products. Let's get started with the presentation. This is the overview. First, we'll go through the background and introduction. Then we'll talk about the features. Then we'll see what a commercial RainMaker deployment means. We'll also talk about the design principles that were considered while creating ESP RainMaker. And then we'll also talk about ESP RainMaker and Matter, which is a new protocol which was launched recently. So here's the background to understand why exactly was ESP RainMaker built. So Espressif has been in the business of IoT chips for a very long time, starting with ESP8266 and then moving on to ESP32. We have an SDK called ESP-IDF, which focuses primarily on the firmware side, and it can help to realize typical IoT functionality on the device side. It includes the most common functionality like MQTT connectivity, Wi-Fi provisioning, HTTP server client, and related modules. Espressif has a very strong developer community who has been using this ESP-IDF as well as the Arduino variants for this. But integrating the cloud services, phone apps, and other services like Alexa, Google Assistant, that has been a pain because our developer community is primarily well-versed only with the firmware side. Most solutions available were either hard to use or expensive or half-baked. So by half-baked, I mean that people have some hard-coded Wi-Fi credentials, then use some open source MQTT broker, and without having any access control, they just access the devices from their laptops or mobile phones, which is not that secure. So we felt that there is a need to fill in a gap and build a solution for developers as well as for commercial products, because most use cases are very common, and people keep on reinventing the wheel, and it sort of becomes a repetitive task because everyone has to do the same thing again and again. So with that background, we decided to build ESP RainMaker. Now let's see what ESP RainMaker is. It is an end-to-end platform that enables developers to realize their IoT ideas faster. It consists primarily of 4 pieces, which is the device SDK based on ESP-IDF to build the firmware. Then there are the self-adapting phone apps with the sources available on GitHub. And the most important piece is the cloud middleware, which connects all of this together. And since most people interact with their devices via voice assistants like Alexa and Google, that is also provided as part of the solution. It works with all ESP32 variants, including the S2, C3, S3, and soon it would also work on the cheaper variant, which is the ESP32 C2. The public RainMaker can be used free of cost to evaluate, and even hobbyists can continue using it forever, I can say, because we have a promise that we'll continue supporting it for a long time. And you can build a small ecosystem in your home or launch products with millions of devices. So this is a sort of a block diagram for ESP RainMaker. As you can see, there's the cloud piece in the middle. The ESP SoCs are talking with the cloud. Then there's the ESP RainMaker app and the external voice assistant integrations that we spoke about. So ESP RainMaker was built in such a way that the firmware developer, who is our target customer or target audience, I would say, he would have the most power because the phone apps and the cloud pieces are hard to understand. So we expect that the developer should not have to tinker around the cloud backend or the phone apps, and all the logic would be on the firmware side itself. So the cloud just acts as a tunnel between the devices and the phone apps, and all the logic is on the firmware. So people can define their products, their parameters and everything on the firmware side, and it would automatically reflect on the phone app. We have some standard devices, parameters, and services which have special handling in the phone app and even on the cloud backend. For example, if you are using the standard type as light, then it will show up as a light on Alexa and GVA. RainMaker is also available on Arduino because we understand that most developers prefer Arduino as their development platform. So we added the support in Arduino, but even then we recommend that you use ESP-IDF because that is much more polished and has more features than our Arduino variant. Let's talk about the features of RainMaker. So RainMaker is not just even though it is a thin layer, and I mentioned that it is a tunnel between the devices and the phone app, it is not a simple cloud which just sends the data from here to there. It has most functions which are required for a typical smart home application. So let's just run through the list. There's user management, wherein you can just log in using your email address or third-party logins like Google, Apple, Facebook. The most important feature is device control and monitoring using a completely flexible device model. And the control can be done over local network as well as via cloud. The cloud would be the primary. But if you and the device are in the same network, the control can also happen over the local network itself. Then there are schedules to trigger actions at specified time. This is one of the most important features because people want their devices to turn on and off at specified timings. Then there are scenes which are presets for parameter values for a set of devices. Then there are automations to trigger actions on some devices based on events on some other. Then there are push notifications, like if your device goes offline or something like a fire alarm triggers, then you will get a push notification on your phone app. Then there is device grouping to realize separation based on homes, rooms, device types, etc. We also offer a feature wherein you can share the devices or the complete home with the friends and family, so they also have the access to the same devices. Then there is time series data for use cases requiring history of data. Example is energy consumption. You can monitor the consumption over multiple days or multiple weeks, months, year. And there's a command response communication model to implement additional functionality. It is just part of the framework and it is very much flexible, and you can realize any use case you want with that. So these are not the only features we have. We also have administrative features. So you may have a small fleet of devices in your home or in your building, or it can also have hundreds of thousands of devices spread across the entire world. For all those cases, we offer these administrative features. The primary one being is the device management dashboard. So that is the main interface for accessing your devices as administrators. It would show the health of the system, like how many devices are online, how many are offline, how the devices are getting onboarded, how the users are getting onboarded. There are also mass manufacturing tools. Like once your development is done, when you have to manufacture a large fleet of devices, programming the private keys, certificates, firmware, and everything on them can be a tricky part. So we offer that as a service. Grouping can be done based on the node types, models, etc. You can have a group of lights, a group of switches, which can help you differentiate between the devices and also push OTA upgrades based on groups. So that is the next point we have here, like OTA firmware upgrades for individual nodes as well as group of nodes. Then there are statistics. As I mentioned earlier, we have graphs which show how the devices are getting onboarded, how users are getting onboarded, how users are mapping devices to their account, and so on. Then there is role-based access control. Like a single admin may not be sufficient for larger deployments. So you can assign multiple admins and each can have specified access control. Optionally, you can also have ESP insights, which gives in-depth picture of the health of the solution and provides tools to narrow down on problems. We'll talk more about ESP insights in a separate session. So the public RainMaker is very much suitable for evaluation purposes or for hobby cases. But if someone decides to take this to production and build commercial products with that, we have facility of that as well. So the commercial RainMaker deployment is like a replica of the public RainMaker, but deployed in your own AWS account. So these are the components that we provide as part of a commercial deployment. The primary thing is the cloud backend. It is provided as a serverless application repository in binary form. It would be installed directly in your account, and it can be extended using webhooks, custom APIs, and also reusing the existing database. Phone apps, as mentioned earlier, they are open source. We can help you customize the phone apps as per your standard themes, logos, and related things. And you can launch those phone apps directly in the Play Store with your own branding. And there are voice assistant integrations, like as I mentioned earlier, RainMaker has integration with Alexa and GVA. Those are provided with your own branding and support for your device types. And Espressif also helps in the certification of the skills and the devices. So while building the RainMaker, we considered various design principles to make this suitable for hobbyists as well as for commercial purposes. And the first and foremost point is manageability. We understand that our users are primarily firmware developers or device manufacturers, and they may not be well versed with managing cloud services. So we use serverless architecture to reduce DevOps and to facilitate deployment and management in an easy way. The second part is scalability. So while launching a product, people may start with pilot runs with, say, a few hundred or thousands of devices. And as the product becomes popular, the volume would go on increasing. Since we are using serverless, the scaling happens automatically. You do not have to do any special DevOps to increase the capacity of the cloud backend. The cost is the next important factor. Since we are using serverless, it is more like a pay-as-you-go pricing. If the device count is low, the messaging is low, you won't be charged much. As the count goes on increasing, the cost would go on increasing. But AWS has this good thing, like if the volume is very high, the per device cost goes on reducing. So that is very much useful. Security is one of the most important aspects. Even though this was started as something for hobbyists, we have kept in mind that we follow security best practices so that this can easily be used for commercial products, because that is where we wanted to finally reach. And I think we have reached there already, because we have many customers who are using RainMaker. We don't use any custom security scheme and unnecessary privilege escalation. We use all standard security mechanism like X509 based mutual authentication, then access token and refresh token based access for the end users, etc. Extensibility is the next point. we have tried to add most features that are typically required for an IoT system, but obviously we can't meet all the requirements of all the users. So we have kept this RainMaker very much extensible. We have already seen the benefits of serverless, but let me go through them once again. We are using all the AWS serverless components to build RainMaker. As mentioned earlier, it can be deployed in your own AWS account. It is designed for scalability, security, reliability, and cost. Minimal DevOps and almost no maintenance required, and pay-as-you-go pricing. So we have gone through all these points, so I won't spend much time here. Let's talk about the privacy and security consideration once again. Since ESP RainMaker is deployed in your own AWS account, Espressif does not have any access to it. The access is restricted only to you and your administrators. That we feel is one of the most important feature, because these days people are much more aware of the privacy and security considerations, and they don't want their data to fall in hands of others. So that is why we have built RainMaker in such a way that only you have access to it. We use all standard AWS security and access control mechanisms, which were already mentioned, but to talk about it, it's the device communicate with the cloud using certificate-based mutual authentication. The admin access is restricted using the standard AWS IAM policies. End users log in through AWS Cognito. And we also have WAF, which is a firewall to prevent attacks on the cloud backend. Espressif routinely conducts penetration testing using third-party labs, so that it is ensured that it's not that we feel that the system is secure. We ensure that it is indeed very secure, and that the third-party labs help us ensure that we follow all the best practices. And a few months back, we also did a complete GDPR review. Whatever suggestions we got have been implemented. So if you plan to launch your products in the European market, even that is possible, because all the GDPR certification has been managed already. So we spoke about extensibility. I'll just go through the points how to understand how RainMaker is extensible. So we have very flexible data model. Even though the standard examples are for light bulb, switch, fan, etc., you can create any device or parameter as per your requirement. Like you can build air conditioners, you can build garage door openers, and any other device type that you feel like. Complex use cases wherein the interface is not directly visible to end user can also be realized using what we call as RainMaker services. If you have used RainMaker already, you will see that there are features like scheduling scenes. These are implemented using RainMaker services. So you don't see it on the device control page, but it is handled specially on the phone apps. The most interesting part of this is it does not require any change on the cloud backend. It is completely between the device and the phone apps. So you can extend it easily because the firmware is in your control and the phone apps adapt automatically. If you are well versed with the cloud services, then there are other ways in which RainMaker can be extended. First is webhooks. It can be used for propagating RainMaker events to external systems. OAuth 2 connectors, if you have any existing identity management system, it can be linked to RainMaker so that people would not have to create new accounts and they can continue to use their existing usernames and passwords. And then you can build custom APIs. Since RainMaker would be deployed in your own AWS account, you can reuse the database, you can add new APIs, write custom lambdas, so that any functionality which is not already covered by RainMaker can also be achieved. This is something new. I'm not sure how many of you have heard about it, but Matter is a new royalty-free connectivity standard to increase compatibility among small-term products with security as a fundamental design tenet. So people who have already worked on IoT products may be aware that to make your device work with various ecosystems like Apple, Amazon, Google, you have to explicitly add support. Like for Apple, you have to implement HomeKit. For Alexa, you have to implement the Alexa skill. For Google, you have to implement the Google actions. With Matter, all of this becomes very simple because it is a common protocol for all. Espressif has been an early member of this, and we already have solutions for Matter available on GitHub. Let's talk about how RainMaker plays an important role in this Matter protocol. So RainMaker will provide integrated device management for Matter, including secure module manufacturing, which is one of the most important pieces. Like we have seen in the earlier line, security is a fundamental design tenet of Matter. And it also includes securely programming the private keys and certificates on devices. And Espressif offers services to make this easy for you. The RainMaker dashboard, the administrative features I mentioned, can be used for managing your Matter fleet, which also includes OTA firmware upgrades. So you can create groups and push firmware upgrades only to those, as we had mentioned earlier. And you can also monitor the health of your Matter devices. So Matter is a protocol which works only on the local network. With RainMaker, you can give a remote control facility. So whenever your phone is on the local network, it would use Matter for talking to your devices. But when you are outside the network, the control can happen through RainMaker. So RainMaker helps in completing the system and making the device accessible even if you are not at home. And ESP RainMaker will also help realize a complete Matter ecosystem, which is built on top of Matter's concept called fabrics. Now, fabrics could be a bit hard term to understand because there is a lot of theory behind it, but it would be covered in a separate session so that you will have a better understanding how RainMaker can play an important role in Matter ecosystems. So that is all we had for this. Let me just summarize. So ESP RainMaker is a free to use, feature rich, secure cloud service and works on any ESP32 variants. Our development boards are easily available. As I mentioned, the source code is easily available. So you can just get started right away and build your IoT system. Whatever links you would require or the documents you require can be found on these links that you are currently seeing on the screen. Thank you very much. Goodbye.
Okay, perfect. So the next talk is over, and let's invite the speaker, Piyush. Okay, Piyush, can you hear me? Give me a second. You need to unmute yourself. You are muted. Yeah?
Hi, everyone.
Perfect.
Can you
We
hear
have
me?
you here. Perfect. So the stage is yours. You can start with some of the questions you have sorted out during the talk.
Yes, so I have answered some of the questions on the chat directly, but I'll repeat some of them in case people have missed that. So one of the first questions was, is RainMaker optionally self-hosted in the cloud or strictly through Espressif's hosted solution? So as mentioned there, the public RainMaker can be used by hobbyists and even for others for evaluation. But once you are ready for launching it commercially, you can get your own private deployment and it would be deployed in your own AWS account. Next question, is there any documentation beyond the intro website? So that is more like a single point where we add all the documentation. If there is something missing, you can always raise issues either on the forum or GitHub issues, and we can answer there and also improve the documentation if someone feels that there are some things which are missing or need to be improved. Another question is, do you provide support for RainMaker with Matter? So you must have seen we had the Matter and RainMaker sessions back to back, and in this session I also mentioned about our work on the RainMaker plus Matter front. We also have a working example already, and it would be released in a few days so that everyone can try it out. Another common question is, do we have support for custom Alexa GBS skills? So the current RainMaker public Alexa and GVA skills support some standard device types like light bulbs, outlets, fans, switches. And as we get new customer requests, we go on adding those device types also. And if you get a private deployment, then you can completely rebrand the skill as per your expectations. Like it would have your own logo, own name, custom help text, and all that. That is provided as part of the commercial RainMaker deployment. Another common question is how do we opt for the commercial deployment of RainMaker? So all such queries can be sent to sales@espressif.com. You can mention that you require a commercial RainMaker deployment, and they would provide you the appropriate information and also the pricing models. So people also want to know if RainMaker would be supported on ESP32 C2. So C2 has lesser RAM, but we can still fit RainMaker into it, and we have everything working, including the normal remote control, OTA upgrades, local control, as well as Matter, everything working on the C2. So examples for that also would be released in a few weeks. Then someone had asked if RainMaker can be deployed in Azure or Google Cloud. So as of now, RainMaker is tightly coupled with AWS serverless architecture. So at least in the near term, we would support only AWS. If later we get more requests for Azure or GCC, we can consider those requests as well.
If you don't mind, Piyush, I have sorted one of the questions also from the chat, so I will ping it, highlight it. It's some like more beginners one. So when I just want to start developing the RainMaker application, what I need? Can you answer this one, please?
Yes, so the RainMaker public deployment is free to use for all. So you can just head over to rainmaker.espressif.com. The docs there have the getting started section. You don't really need to have your own AWS account because RainMaker does the hosting for you for hobbyists as well as for initial evaluation. And there's no concept of a local server in RainMaker because RainMaker is primarily a cloud service. And the local communication I mentioned is something which is just from the phone app to the device, with RainMaker backend not being in the picture. But the gist is you don't need your own AWS server. You can just use the public RainMaker.
Okay, perfect.
Which is free to use.
Thanks. You can continue with like some of the others you have sorted. Thank you.
Thank you.
Maybe I can have one more. There were like a lot of questions about the Alexa. So do you have the support for the custom like Alexa or GVA, something like that? Can you answer this one, please?
So we support the smart home skill of Alexa and GVA. So we don't support custom skills, but whatever is supported by the smart home skills of Alexa and GVA, we would support that. So as of today, we don't support all the device types. As I mentioned, we support only the few like light, switch, fan, and those. But if anyone has any special request, we can definitely add that. And that's about it.
Okay, and I have the last one probably. It's highlighted. So it's about the documentation and APIs. If you can answer this one as well, please.
Yes, so the question was about historical data. So there is this new feature called time series, and it is actually enabled by default for the applications like temperature sensor. And if someone is using RainMaker, they would know that when you create a parameter, you need to pass a few properties to it, like read, write, persist. Similarly, there is a property called time series. If you just add that property to a parameter, automatically it would start reflecting in the time series data, and it would start showing up on the phone app.
Okay,
we'll also ensure that these things are not missed out in the documentation. So if there's any confusion, we'll definitely update the documentation.
Okay, perfect. So I think you just answer a bunch of questions. If there are still like some more, you can continue answering in the chat. And I think we can move on the next talk, which is going to be the FreeRTOS in ESP-IDF by Darian. Thanks a lot, Piyush,
for answering, and let's jump to the next one. Bye-bye.
Thank you.
Hi everyone, my name is Darian and I'm a senior embedded software engineer in Espressif, and I'm part of the software platforms department, and I'm here to talk about FreeRTOS and ESP-IDF. So let's get started. So what I'm going to be covering today is some of the basics, since this talk is quite technical. I'll cover what multitasking is and what SMP or symmetric multiprocessing is. And afterwards, I'll cover a bit of history about ESP-IDF and how we came to use FreeRTOS. And then I'll cover some of the different implementations of FreeRTOS, such as vanilla IDF SMP and Amazon SMP. Furthermore, I'll cover some of the design differences between the implementations, and finally, the future plans of each implementation. So let's cover the basics. What is multitasking? So essentially, a CPU can only do one thing at a time. So if we want to create the illusion that the CPU is executing multiple things in parallel, the CPU can switch between tasks rapidly, and it will create the illusion that multiple tasks are running in parallel. So what is symmetric multiprocessing? The technical definition is a multi-core system where each CPU has access to the same memory bus. However, in the context of multitasking, symmetric multiprocessing just means that you have different tasks which can run on both CPUs, and if the CPUs switch between the tasks quick enough, then it will appear as if all 4 tasks are running in parallel on both CPUs. So that covers some of the basics. So let's talk about some history now. How did ESP-IDF come to use FreeRTOS? A long, long time ago, there was a chip called the ESP-8266, and this was paired with the ESP-8266 non-OS SDK. So the ESP-8266 was basically a single-core extensa architecture Wi-Fi SoC. And at the same time, there was a dual-core Wi-Fi SoC under development called the ESP-32. So what were some of the pain points in using the non-OS SDK back then? So first, obviously, there was no operating system, so users couldn't schedule tasks or do any multitasking. It was also difficult to configure, as all of the configuration was provided in a header file with some macro defines. And finally, it was difficult to integrate other libraries, other third-party libraries into the SDK, as there was no clear project structure with the SDK. So this generated some requirements of the NIX SDK that would support the ESP32. First was there had to be an RTOS, and preferably this RTOS should support SMP, given that the ESP32 was going to be a dual-core SMP chip. Second, the SDK had to have a convenient way to configure. And the third requirement was that the SDK had to have a better build system structure, allowing users to easily integrate their third-party libraries or their own libraries into the SDK itself. So the result of that was the ESP-IDF. So the ESP-IDF came called a component-based SDK structure, where all of the different features were treated as different components in different directories. And within each directory, there will be a separate configuration file. And for the SDK, it used kconfig to support ease of user configuration. And finally, the operating system we chose was FreeRTOS, where we modified the single-core original version of FreeRTOS to support dual-core SMP. Some of you may be asking, why FreeRTOS and why modify it? So firstly, FreeRTOS is free and open software. It's quite popular and it's very lightweight. So given that it's popular, there's bound to be a lot of third-party support and third-party libraries that can easily integrate with FreeRTOS. And more importantly, FreeRTOS is a microkernel, meaning that it doesn't come with drivers or any network stack. So it fit quite well with the component structure of IDF, where you could treat FreeRTOS as a component, and then all of your other components, such as your network stack, your drivers, could simply call the FreeRTOS API as if it were a SDK component. So what are the different implementations of FreeRTOS in relation to ESP-IDF? There are 3, which is vanilla FreeRTOS, IDF SMP FreeRTOS, and Amazon SMP FreeRTOS. Side note, these aren't any official names. They're just names given for the purpose of this presentation to differentiate between the implementations. So vanilla FreeRTOS is the traditional single core FreeRTOS written by, I think, the real-time engineers or Richard Barry, and is what you can find online. IDF SMP FreeRTOS is the dual core SMP modified version that was written by us and integrated into IDF. And finally, there's Amazon SMP FreeRTOS, which is quite a recent addition, where Amazon themselves wrote an N-core SMP version of FreeRTOS, and N-core meaning that it can support more than 2 cores. So let's cover some of the highlights of each implementation and their advantages and disadvantages. So with vanilla FreeRTOS, as we've covered before, it's your standard single core FreeRTOS. It's quite popular and it's got quite a long legacy. FreeRTOS basically provides all of the essential kernel features that you would want out of an RTOS. So synchronization primitives, task scheduling, interrupts, critical sections, etc. And it's also highly configurable. There's a list of FreeRTOS configs that you can provide to tweak the scheduler to your liking. So the advantages, extensive legacy, and it's quite stable given that it's pretty much used in a lot of places. And it's now actively maintained by Amazon. So there's a team of professionals working and actively maintaining and updating it. But what are some of the disadvantages? Well, it's single core, so it can't natively support some of our dual core chips like the ESP32 or the ESP32S3. And more importantly, it's not actually supported in ESP-IDF. So when you build for a single core ESP chip, it's not actually building vanilla FreeRTOS. So if it's not building vanilla FreeRTOS, what is it actually building? That's when we come to IDF SMP FreeRTOS. In order to support our dual core chips, such as the ESP32 and the ESP32S3, what happened was we took the original FreeRTOS and then modified it so that it could support dual core SMP. So the current version of ESP-IDF SMP FreeRTOS is based off the vanilla version 10.4.3 source code, where we took the 10.4.3 source code and then we applied the dual core SMP changes onto it. So, and even though it's dual core SMP, it can also run on single core targets. What happens is that you just set the number of cores configuration to 1. But what are the disadvantages? When you set the number of cores to 1, it's not actually running vanilla. So there are some subtle behavioral differences. And also, it doesn't support all of the vanilla FreeRTOS configurations. So I don't think we've ever tested IDF SMP with like preemption disabled, for example. So now we've come to Amazon SMP FreeRTOS. This was I guess a recent addition. Amazon wrote a N-core capable SMP FreeRTOS version of FreeRTOS, and there's an experimental port of it within ESP-IDF where users can enable it using menu config. So what are the advantages? Well, obviously it supports N cores. So, you know, in the future, if there's a possibility where there's an ESP chip with more than 2 cores, then Amazon SMP FreeRTOS is well positioned to immediately support that. And also, Amazon SMP FreeRTOS is actively maintained by Amazon. But what are the disadvantages? The port within ESP-IDF is still under development, so it's not in a completely stable state yet. So now that we've covered the 3 different implementations, what are some of the design differences of the 3 different implementations? So in terms of design differences, I'll cover their operating model, how tasks differ in each implementation, how the scheduling algorithm differs, the tick interrupts, how they differ, and finally critical sections. So let's talk about operating model. So within vanilla FreeRTOS, it's a single core operating system. So the user creates a bunch of tasks to parallelize their application, and some of those tasks will be blocked on events, and all of the tasks that aren't blocked are tasks that are ready. And of these ready state tasks, the CPU must pick one of them to execute at any one time. So every time the CPU picks a task, it will schedule task D, and the next time it schedules, it might pick a task E or something like that. So what about IDF SMP? It's a dual core SMP scheduler. So same concept with the block task and ready task, but from the ready task, there are now 2 CPUs, and each CPU must pick their own task to run. And a task cannot be run by 2 CPUs at any one time. So that's not allowed. And finally, with Amazon SMP FreeRTOS, this problem has now extended to n number of cores. So CPU 0, CPU 1, all the way up to CPU n minus 1. So let's overview some of the tasks. So a task in FreeRTOS is usually implemented as a function, and inside that function, there's some sort of infinite loop. Task can be within one of 4 states, which is running, ready, blocked, and suspended. When a task is created, it's usually in the ready state, meaning that it's ready to be run by a CPU. And if the CPU picks that task to execute, then the task turns from ready to running. However, sometimes the task might need to wait for a particular event. So in that case, when the task waits for something, i.e. calls a blocking API, then it gets put into the block state. And then after the task either receives the event it was waiting for, or it times out for the event. It times out waiting for that event, it will go back into the ready state. So the CPUs in vanilla, both vanilla and SMP, the CPUs always pick tasks from the ready state in order to run. And lastly, there's the suspended state, but basically the suspended state is similar to blocked, but tasks inside the suspended state aren't waiting for anything. They have to be explicitly suspended and explicitly resumed in order to be able to be scheduled. So here's an example of a FreeRTOS task. Tasks are implemented inside functions, and these functions are usually contain an infinite loop. Inside the infinite loop, the task will do some work. It might block on some event. So in this case, it's delaying for a particular amount of time. So after it delays, it enters the task enters a block state. And then after executing some things, it might check for an exit condition. And if the task is ready to exit, then it'll jump out of the loop, in which case the task would delete itself. And one important note is that task functions should never return. So in this case, the task function, the task is deleting itself. And inside the deletion, it doesn't actually return from this function. So what are the differences in tasks between the various FreeRTOS implementations? Well, one of the first differences is the function call to create a task. In vanilla, you call xTaskCreate to create a task, where you call this function and then you provide the C function that implements the task. You give the task a name, its stack size, and you provide an argument for that task. And here you specify the task's priority. We'll get to how priority is used in scheduling later. And lastly, it has a return handle for the created task. However, with the SMP implementation, there's one more piece of information that must be provided about that task, and this is the core affinity. Because SMP systems have multiple cores, we have to specify which cores a task is allowed to run on. Thus, this is what the core affinity is. So in IDF SMP, because there's only 2 cores, the core affinity is specified as an index, meaning that as a core index, meaning that the number given represents the index number of the core. So IDF SMP, the possible values are 0 or 1, or the last one is the task no affinity. So 0 means that the task is only allowed to run on core 0, or in other words, pinned to core 0. And the value is 1, then it means that the task is pinned to core 1. And if the value is task no affinity, it means that the task can run on core 0 or core 1. However, with Amazon SMP FreeRTOS, things get a little bit more complicated because there are now n cores. Amazon SMP provides more flexibility as you can specify a combination of cores this task is allowed to run on. So the core affinity is provided as a bit mask. So for example, you might provide a value of, here's a binary number like 1101. This means that the task is allowed to run on core 0, not allowed to run on core 1, it's allowed to run on core 2, and it's allowed to run on core 3. So in order to specify that a task is allowed to run on all cores within Amazon SMP, you have to provide a bit mask of all ones. So here, the functions, corresponding functions in IDF SMP, you create a task using xTaskCreate pin to core, and here's the extra core index argument. With Amazon SMP, you use xTaskCreate affinity set, and here's where you provide the core affinity mask. Here are some of the task differences with the various implementations. Now let's talk about scheduling. So in vanilla FreeRTOS, the FreeRTOS scheduler can be said to have 3 main properties, which are fixed priority, round robin, and preemptive scheduling. So what does fixed priority mean? It means that, as we previously just mentioned, each task is created with a fixed priority. And in normal circumstances, the task priority remains static for the task's lifetime. So what does priority have to do with scheduling? When the scheduler goes and picks a task to run, it always picks the highest priority tasks that are in the ready state. So, but what if the current highest priority ready state has multiple tasks in it? Then that's where we come to round robin. So if there are like 3 tasks that are in the ready state and are all of, for example, priority 10, then the scheduler will actually iterate over those 3 tasks in a round robin fashion. That means it'll go schedule task A and then B and then C and then back to A, B, and C, etc. And finally, preemptive scheduling. Let's say a higher priority task suddenly becomes ready. The scheduler will preemptive means that the scheduler will switch to that new higher priority task immediately, and it won't require the current previously running task to yield. So how does FreeRTOS actually implement the scheduling algorithm behind the scenes? So in vanilla FreeRTOS, there's a single CPU over here. And what FreeRTOS does is it actually maintains a bunch of task lists called the ready task list. And there's a separate list for each available priority. And inside each list contains all of the ready state tasks of that priority. So for example, if this is priority 10, then this list contains all of the priority 10 tasks that are in the ready state. So with fixed priority scheduling, what the scheduler does when it has to go find a task to run is that it searches from the top of the list, top of the highest priority list down to the lowest priority list. And it'll keep searching until it finds a ready state task to run. So in this case, let's say the CPU was scheduling a task. It'll check the highest priority list. There's nothing here, so it'll keep going down the list until it finds this priority where it finds task A, and then it runs task A. But what if there are multiple tasks within the same list? So let's say task A now blocks and gets moved over here to the block state. So the CPU has to schedule again, and it keeps looking down, and now it finds this priority. Let's say it's priority 9, and there are 3 tasks. Which one does it actually schedule? So this is when we get to round robin scheduling, which is covered here. So what FreeRTOS does when there are multiple tasks of the highest ready priority is that it will iterate between those tasks every time it schedules. So let's say this time the scheduler picked B. Next time when it comes to schedule, it'll pick C, and then next time it'll pick D, and then it'll loop back around to B, C, D, etc., etc. And how it actually implements this is internally within each list, there is a pointer to the last item returned from that list. So let's say the CPU picked B, then the pointer now points to B, saying that that was the last item returned. And next time it comes to schedule, it will just take the last pointer and then get the next item from that, and then the pointer moves up with it as well. So that's how round robin scheduling is done. And let's say for example that all of these tasks become blocked. There's a final idle task which never blocks. So this basically gives the CPU something to run if there are no other tasks available. And idle task is of priority 0, which is the lowest priority. So what about preemptive scheduling? So let's say using the previous example, what if the task A that was previously blocked suddenly unblocks? So as soon as task A unblocks, it is now the highest priority ready state task. So the CPU will immediately switch to running task A. So here's a timing diagram of the previous example we used. Let's say the CPU was running task A, and then task A from here blocks. And then after task A blocks, B, C, and D were of the same priority. So the scheduler basically round robins between B, C, and D until at some point task A unblocks. And because task A unblocks, it's the highest priority task, so the CPU continues running task B. And let's say enough time has passed until all of these tasks, all of the tasks A, B, C, and D have blocked or been deleted, then the final task that is still available is the idle task. So the CPU now runs the idle task. So what about scheduling in the SMP implementations? So there are 2 more things to consider when scheduling in SMP. First is, before a CPU scheduled a task, the CPU must first check whether the task has a compatible affinity, meaning that when a task was created, did the specified core affinity allow the task to be run on the current core? And the second is the task must not already be running by another core. So because of these considerations, this actually affects how fixed priority, round robin, and preemptive scheduling manifests within the SMP implementations. So, for example, for fixed priority in SMP implementation, just because there are n cores does not mean that the n highest priority tasks are always run. For example, if the n highest priority tasks don't have a compatible affinity with one of the cores, then one of that core might be forced to go to an even lower priority to find a runnable task. And with round robin, same thing. Within a single task list, let's say there's A, B, and C. When a task is iterating over the list to find the next task to run, if that task does not have a compatible core affinity, it might have to skip over to the next one. So we won't get a perfect round robin within the same task list. And finally, preemptive scheduling. When a task unblocks, like in the previous example, so when a task unblocks, we have to actually decide which core would be preempted in order to run that higher priority task. So here's an example of fixed priority scheduling in SMP. So I'm using the IDF SMP here because there's 2 cores. So you notice that each of the tasks now have a core affinity on top of them. So for example, task A has no affinity, meaning that it can run on both CPU 0 and CPU 1. And task B, C, D have a core affinity of 0, which means that they can only run on CPU 0. Likewise, task F can only run on core 1. So let's say that CPU 0 and CPU 1 haven't scheduled anything yet. So let's say CPU 0 comes to schedule, it goes from the top of the list and then finds task A is the highest priority task. Task A isn't run by anyone else, and it also has compatible affinity. So CPU 0 runs task A. Now it comes to task CPU 1 to schedule. It goes down the list and finds task A is the highest ready priority task, and it also has compatible affinity. But CPU 1 can't run task A because it's already being run by CPU 0. So it has to go down the list and keep looking. It jumps down to the next priority. CPU 1 sees that there's task B, C, and D, but incompatible affinity, so it has to keep looking. So it goes down to one lower priority and then finds task E and F. Task E has a compatible affinity, so CPU 1 picks task E to run. And let's say CPU 0 comes back to schedule again, same flow, it goes down, finds task A, runs task A. But now when CPU 1 comes to schedule again, it goes down the similar flow, but because there are 2 tasks within the same priority, it will actually round robin and run task F on the next iteration. So the scheduling diagram will look something like this. For CPU 0, it would just be running task A all the way through. And in this case, with CPU 1, it will actually alternate between E and F. It will run a bit of E and then round robin to F and then E and then F, etc., etc. In this example, CPU 1 was a bit lucky because within this same list, it could run both E and F. But what if there was a case where for CPU 1, it was running into a case where this task was pinned to core 0 and core 1 and core 0, where in a single list, there were some tasks which CPU 1 could not run. So it would mean that CPU 1, when round robining through the same list, would end up skipping over some tasks. So for example, it can't run this, so it'll skip over and run task 1. And then afterwards, it'll skip over 0 and then come back to task 1. So we can't use the vanilla FreeRTOS way of using the last item pointer of the list to get them to round robin within this given priority. So what do the SMP implementations actually do? The trick is to actually always search from the start of the list and also put the last run task to the end of the list. So let's say that this is all within the same priority. Let's say like priority 10, and priority 10 is also the highest priority. Let's say CPU 0 is running task A, CPU 1 is running task B, and the task affinities are listed below them. Let's say CPU 0 now has to do a reschedule. How does SMP handle the round robining in this case? So what happens is that because CPU 0 was previously running task A and CPU 0 is rescheduling, task A gets put to the back of the list. And then afterwards, CPU 0 must now start searching from the front of the list for the next task that it can run. So it sees task B, but it can't run task B because it's being run by CPU 1. So CPU 0 continues looking. It sees task C, can't run task C because it has an incompatible affinity. So it jumps to the next one and finally finds task D. CPU 0 can run task D, so what ends up happening is that CPU 0 schedules task D. So CPU 0 ends up scheduling task D, and the resultant list looks like this, where CPU 1 is still running task B, and the CPU 0 is now running task D. It's now CPU 1's turn to schedule. We do the same thing where we take CPU 1's previously running task, and we stick it to the back of the list, and then CPU 1 starts searching from the front of the list for the next task it can run. It sees task C, so CPU 1 starts running task C, which results in this. So CPU 1 running task C and CPU 0 running task D, like that. So now let's say it's back to CPU 0's turn to reschedule. So CPU 0 was previously running task D. We go here and stick it back to the end of the list. And then CPU 0 starts searching from the front of the list for runnable tasks. It can't run task E, and then it jumps to task A. So CPU 0 is now running task A. So CPU 0 schedules task A. And the result of sticking the last run task to the back of the list and then searching from the front is that eventually all of the tasks will have a chance to run, as if a task was not run for a prolonged period of time, it will end up at the front of the list. So this doesn't produce a perfect round-robin scheduling, but it still gives that. It will avoid the scenario where a task is consistently being skipped over by CPUs when they're traversing a list. So now let's talk about preemptive scheduling in SMP. So let's say task A was previously blocked and is now unblocked and is also the highest priority task. So we have to pick which core to preempt. Does task A preempt CPU 0 or does task A preempt CPU 1? Well, the answer to that is it depends. So what does it depend on? In IDF SMP, when a task A unblocks, preemption only occurs if task A has a higher priority than one or more cores. And of those cores, task A has to have a compatible affinity with them. So for example, let's say this is priority 10 and this is priority 9. Task A is unblocked and task A is of priority 10. So task A has a higher priority than both CPU 0 and CPU 1. So that means that task A can technically preempt CPU 0 and CPU 1. But let's say now that task A is pinned to CPU 0, then in no case, under no circumstances will task A ever preempt CPU 1 because task A can't run on CPU 1. But what if task A was not pinned to any of the cores and was also higher priority? Then in IDF SMP, there's a bias towards the current core. So what does this mean? It means that if task A was unblocked and it had no affinity, then whichever core caused this unblock will be responsible for being preempted. So for example, if core 0 was the one that caused task A to unblock, then task A would actually preempt core 0. And likewise, if core 1 was the one to unblock task A, then core 1 would be preempted. So this biasing is specific to IDF SMP. Let's take a look at Amazon SMP. So Amazon SMP has similar considerations where when task A unblocks, it has to have higher priority than one or more cores, and task A also has to have compatible affinity with those cores. And also, you can't have suspended the scheduler because if you suspend scheduling, then task switching basically stops. However, with regards to selecting which core to preempt, Amazon SMP will try to select the lowest priority core with compatible affinity to preempt. So what does that mean? So in a previous example, let's say task A was of priority equals to 10, and it had an affinity of, let's say it could run on core 0, core 1, and core 3, for example. So let's draw some cores here. Let's say 0, 1, 2, and 3. So because task A is can only run on 0, 1, and 3, it would never consider preempting task 2. And let's say it has a priority of 10, and let's say core 0 has a priority of 8 right now, core 1 is 7, and core 3 has 12. Well, priority 10 is less than core 12, so it won't preempt core 3. So what's left is core 0 and core 1. Since core 1 has the lowest priority, then core A ends up preempting core 1. So that's the preemption algorithm in Amazon SMP. So now let's talk about tick interrupt. So what is a tick interrupt? Within FreeRTOS and other operating systems, there is a periodic interrupt that occurs. So for example, interrupt that occurs every 1 millisecond. And that interrupt basically drives the entire operating system's timing. So every time the tick interrupt occurs, it increases something called a tick count. And the tick count is basically the current time of the operating system. And everything, all of the all timing related things within the FreeRTOS are measured in terms of ticks. So for example, if the tick interrupt happens every 1 millisecond, then the highest resolution of the length of delays is 1 millisecond. So when FreeRTOS runs a tick interrupt, the tick interrupt is responsible for incrementing the tick count. And because it increments the tick count, it will know what block tasks have now timed out. So it will unblock any tasks that have timed out. And then furthermore, it will also do something called time slicing, which is to check whether the CPU's current executing priority has other ready tasks of that same priority. And if so, force a reschedule. So what happens is that basically this is driving a periodicity of the round-robin scheduling. And finally, the tick interrupt runs a user-provided application tick hook. So about time slicing, let's take a look at an example. So for example, the tick interrupt happens at these intervals, so T1, T2, T3, T4, etc. And these are the current tasks available. So A is priority 2, B, C, D is priority 1. So let's say here's where time starts, and then task A is being run by the CPU, and then at some point task A blocks. So because task A is now blocked, the scheduler goes back to running task B and task C and task D. But because the tick interrupt forces a reschedule every tick, it causes the round robin schedule to happen every tick. So the result is that each of those tasks of the same priority get almost the same share of time, or the same amount of time slices. That's why it's called time slicing. And this time slicing repeats until task A gets unblocked. So task A gets unblocked and then let's say it blocks again, and then time slicing resumes. So time slicing basically is it's a mechanism to allow tasks to have almost an equal share of running time. That is, say, a task of equal priority have an equal share of running time, but it's not a completely equal distribution. So what about tick interrupts in IDF SMP? Now, this gets complicated by the existence of the extra core. So do we want both cores to increment the tick count or not? So in IDF SMP, both cores receive a periodic tick interrupt, but both of them, the responsibilities of each core are different when they come to execute the tick interrupt. So all of the timing related things, such as incrementing tick count and unblocking timed out tasks, that is delegated to core 0. So basically core 0 does almost all of the same things that the vanilla FreeRTOS tick interrupt does. But a small difference is that for time slicing, it only forces a reschedule for core 0. So when does core 1 do time slicing? Basically, when core 1's tick interrupt comes, then it will check for time slicing for its own core and also run the application tick hook. So for Amazon SMP, things are simplified even further. Basically, only core 1 has a tick interrupt, and core 1 will basically carry out all of the tick interrupt responsibilities. But for time slicing, it will actually check if each core's current priority has other tasks of the same, other ready state tasks of the same priority, and then force a reschedule on those cores if they can time slice, basically. And finally, let's talk about critical sections. So, quick overview. If two threads are concurrently accessing the same data, then there's a possibility that one thread corrupts the access of another thread. So the classic example is if two threads of execution try to increment a variable at the same time, let's say the variable is 0, and then both try to increment it by 1, then if both threads execute at the same time, then instead of the variable being incremented twice, the variable will end up being a value of 1 instead of 2. So a critical section is a section of code that cannot be executed by more than one thread. So basically what happens is that a critical section forces a piece of code to be serialized across when executed by multiple threads. So what are the possible concurrent threads of execution? There are software threads, which are basically other threads, other tasks, hardware threads, which is another CPU core running at the same time, and also ISRs. Basically, while you're incrementing the variable, an ISR could occur, in which case the ISR could also access the same variable, which could cause similar issues. So how are critical sections done in vanilla FreeRTOS? So in vanilla FreeRTOS, the only concurrent threads of execution are basically tasks and ISRs. So to guarantee that a section of code is only ever executed by one thread of execution, all we need to do is basically disable interrupt, because when we disable the interrupts, ISRs can't occur, and we can't switch to another task while interrupts are disabled either. So once we disable interrupts, we guarantee that only one thing can increment this variable at this time. However, with SMP, things get a little bit more complicated, because even if you disable interrupts, the other CPU still exists, and the other CPU is running something at the same time. So disabling interrupts is no longer sufficient to guarantee a critical section. So what we do in IDF SMP is that we use something called spin locks. Basically, before we enter a critical section, all threads of execution that want to access that shared piece of data have to take a lock. And basically, if a thread of execution has already taken a lock, other threads of execution, such as tasks, ISRs, or the other CPU, will basically spin in place until the current lock holder has released it. So in IDF, more specifically in IDF SMP, the locks are granular. So users can define their own data or their own object or structure, and then they can also define a lock to protect that data or object. And users can define their own users, or other IDF components will define their own locks, and they can control the amount of granularity. However, with Amazon SMP, the problems are similar, where the other CPU exists, and they also use spin locks, but the main difference is that critical sections now use a big kernel lock approach, meaning that all critical sections contest for the same lock. So there are some benefits to this, meaning the main one being that there's no possibility of deadlocking, and it also simplifies some of the concurrency issues within the operating system. However, a big downside to this is that all critical sections basically try to contest for the same lock. So if two threads of execution are accessing completely different pieces of data, and they both try to enter critical at the same time, they will still contest with each other. So this could lead to some basically lower performance in code. So now we've discussed all of the most of the major design differences. Let's now talk about the future plans of each implementation in ESP-IDF. So here's an overview of the different implementations, what the current status is, and main goals in the future are for each implementation. So vanilla FreeRTOS currently not supported in IDF, but we want to have some near vanilla support in ESP-IDF in the future. IDF SMP, it's based on the vanilla 10.4.3 code base, but we want to upgrade it to a newer LTS version before it becomes legacy. So why would IDF SMP become legacy? It's because we want to make Amazon SMP FreeRTOS the default OS in ESP-IDF some point in the future. So the current status of the Amazon SMP port in ESP-IDF is that it's quite experimental, and there's still some issues with it and some performance issues we need to solve. However, given enough time, we'll keep working on it, and then in the future, it will become the default FreeRTOS implementation within ESP-IDF. So let's go more in depth. Future plans for vanilla FreeRTOS. Currently, if you build FreeRTOS for a single core target, you're not actually running vanilla FreeRTOS. It's running IDF SMP with the number of cores set to 1. So the downside to that is that due to some of the design differences in IDF SMP, it's not immediately, we can't guarantee that application written for vanilla FreeRTOS would immediately work in IDF. So the reason for us wanting to provide a vanilla FreeRTOS or near vanilla FreeRTOS implementation within ESP-IDF is that users porting code for other single core FreeRTOS projects can immediately integrate them into ESP-IDF. So yep, so what does that involve? This will mean that we have to refactor our current IDF SMP FreeRTOS so that when config number cores is set to 1, it will basically restore vanilla FreeRTOS behavior or something very similar to it. And any places that deviate, we have to clearly document it where the deviations are, where the deviations are, so that users who port code from other FreeRTOS projects will know what effects will have on their application. So what about future plans for IDF SMP? It's currently based on the vanilla FreeRTOS version 10.4.3 code base. So we basically took 10.4.3 vanilla FreeRTOS version 10.4.3, and then we added all of the IDF SMP modifications onto that code. So the goals for that is we want to update the base code to the next FreeRTOS LTS version, which is 10.x.y. We're not sure when that is, but we want to basically give it another LTS update before it turns legacy. And we also want to refactor the way the IDF SMP implementation is written so that it's easier to forward port to newer versions of FreeRTOS. Currently, what happens when we upgrade to a new port over the behavioral change. If we can isolate or find some convenient inject the changes, it will make behavior onto like vanilla code base. But some of you may be asking, why do we want to do this? It's because when IDF SMP finally becomes legacy, we still want to make it easy for like third-party users who want to continue using it to forward port it to newer versions of FreeRTOS. And finally, we have Amazon SMP. So currently, it's still an experimental port, and there are some known issues. So the main goal for this is to make it good enough to be the default FreeRTOS, which means resolving some of the known bugs and issues, improving performance, and also improving test coverage. And the final point is actually quite interesting. This is something that Amazon is currently working on. They have plans in the future to be able to merge the Amazon SMP FreeRTOS code base with the vanilla one. So in the end, they will just have a single version of FreeRTOS, which can do single core and SMP. So I guess that covers everything. And I'm dropping some resources here for each of the FreeRTOS implementations. So please take a look if you're interested, and I'll take some questions. So thanks for listening.
Okay, perfect. So let's move on to the next Q&A session, and I will invite Darian, the speaker of this talk. Hello, Darian. Can you hear me?
All right. Hi, everyone. I can hear you. Can you hear me?
Perfect, perfect. So Darian, we have sorted a few questions for you. So I will just quickly start with the first one. And it's basically, what the heck is a semaphore?
So let's go through these quickly. A semaphore is a signaling mechanism between tasks. If you have a task A and a task B, and task B needs to wait for task A, then semaphore is one of the synchronization features you can use. The other options are mutexes, queues, and I think like event groups and task notifications are some other options you can use. But a semaphore is by far one of the most simple ones.
Okay.
All right. I hope that answers it. Next one.
Yeah. Don't hurry. Like we need to. Have someone to be able to follow us. So let's jump to the next one. And it's with the ESP32, I have two cores which can assign to the task. So is it kind of a multitasking?
Well, yes, I guess like multitasking, this would be something known as like a true hardware thread. So in SMP FreeRTOS, you have a task, but the task can only be run on a particular CPU at any one point in time. But it's possible for the task to jump between the CPUs when it's switching. So yes, if you have 2 cores, it is multitasking.
Okay, perfect. Let's continue. The other question is there like any way for 2 CPUs to interact with each other, and how the single processing code can be built for a multiple core system?
So the CPUs can interact in many ways. So one way is at the FreeRTOS API level. So for example, if you have task A on core 0 and task B on core 1, it's perfectly valid for task A to communicate with task B using like a FreeRTOS queue or the previously mentioned semaphore. We've built IDF SMP FreeRTOS so that like the API works across cores. And how to build like build like single processing code for multiple core systems. You just write a regular FreeRTOS task. It should work on multiple cores. So the amount of changes you need should be minimal.
Okay, perfect. Thanks a lot for a nice answer. The next question is shorter. So Xtask, right, is also part of ESP-IDF. Is this correct?
Yes, it is. It will just basically create a task that is not pinned to any core, meaning that it can run on any core.
Okay. Perfect. The other one, how about the Watchdog bug? I actually stopped working on the ESP32 after that project. It's not nice to read that. So
this is a question we get very commonly, and the most common reason for the task watchdog triggering is that the idle task isn't allowed to run within a certain period of time. So the task watchdog is there to guarantee that at some point in time, the idle task is allowed to run. So why do we need the idle task to run? It's to guarantee that your CPU isn't being oversaturated with tasks. So the solution to that is find out what task is preventing the idle task from running, and then try to make that task block for some event. So either a delay or block on some queue or semaphore or something.
Okay, so I hope it's now clear to the users, and maybe you will just return back to the project.
Yeah.
And the next question, is it possible to change the frequency of time slicing? For example, every ticks?
Yep, there's a config option called config FreeRTOS HC for like hertz, and you can adjust your time slicing frequency there.
Okay, perfect. And I think we are just like running out of time, so I think I will have the last question for you, Darian.
Okay.
Let's highlight it. Why do you want to turn IDF SMP to the legacy if it works well with 2 cores ESP32 SoCs? I mean, Amazon will implement N-core, but IDF SMP can be specialized for 2 cores.
So I think in the future, we want the flexibility to implement in N-cores. And by turning it legacy, it doesn't mean that you can't run IDF SMP FreeRTOS. I think at the end of the talk, I mentioned that we want to make it possible for third-party users to continue forward-pointing IDF SMP to future FreeRTOS releases if they want to, because we understand that like IDF SMP has been around and it's stable, so users want to stay with that. So I think even though Amazon SMP will become the default FreeRTOS in the future, we'll still have some ways for either third-party users to have a way to run IDF SMP, so it won't be completely like unusable.
Okay. So as you promised, you are answering fast, so we can extend a bit. And this is really the last question. And it's, will ESP-IDF actually work at super low tick rates? Like one...
Technically, yes, but it's a trade-off between overhead and precision. So your tick rate defines the precision of your delay. So if you have a tick rate of 10 megahertz, then the highest precision you can get with your delay is 10 milliseconds. So the higher your tick rate, the more frequently your CPU has to be interrupted to process those tick interrupts. The lower your tick rate is, the less overhead, but the less precision you get with your delays.
Okay, perfect. So I think that's it. Darian, thank you a lot for joining. It was nice to have you here.
All right.
For the audience,
thank you.
If you still have some questions, don't hesitate to ask in the YouTube chat. I think Darian will be available for some time, so he can answer.
Yeah, I'll stick around to answer more questions. All right, thanks for having me.
Thank you,
Bye.
Darian. See you. Bye-bye.
Bye.
So guys, we have finished the first block of the talks. Now we will follow up with the 15 minutes breaks. And during that break, it's going to be a static picture, but there's also some like videos from the Espressif based makers. So you can watch them and maybe just check their projects, what they are working on. And see you after 15 minutes break in the second block of the talks. Bye-bye.
At Espressif, we always believe that we have to be assisting our customers in their journey right from production up to support. And we have tried to make sure that we have taken the entire spectrum of these activities into account as part of our solutions. Our SoCs, ESP32, ESP32C3, ESP32S3, and ESP32H2 offer a wide variety of features that allow developers to create rich products based on the feature sets that they need. Additionally, we have also created reference solutions for the typical device types, which could be end devices, border routers, or bridges. Secondly, as the software is built, a product is available, it goes to manufacturing. In the case of Matter, every device needs to have a unique set of information flashed onto it. Our Matter solutions ensure that you can create millions of such unique images by just making a few settings. This just helps you get started with your real production run much faster. Finally, on many manufacturing lines, it's much harder to flash something that is unique to each device. In this case, Espressif offers an optional pre-programming and pre-provisioning service where we will ship out modules to you which have been securely programmed with your unique set of images and data so that you don't have to go through this experience. Once your device has been built, our ESP RainMaker service provides device management features. You would want to upgrade your devices in different ways. ESP RainMaker OTA allows you to upgrade your devices incrementally or even perform A/B testing to ensure that you can run the right level of diagnostics and fix issues. Secondly, we offer a service called ESP Insights that allows you to do in-field diagnostics. With this service, the devices in the field can provide rich metrics, logs, and data, which helps your developers understand and analyze issues upfront even before your end customers report it. This also is an invaluable tool for your product developers who can get insights as to what features the customers prefer to use and what they don't. Matter is a game-changing technology, and we are really excited to see what innovative products come out of this and how end users benefit from the rich user experiences that they offer. Thank you.
Hello everyone, I'm Sachin Soni from TechieSmas YouTube channel where we teach project tutorials in the field of IoT, automation and electronics. I'm really grateful to Espressif Systems as most of our projects are based on the one and only ESP32 chip which is from Espressif Systems. ESP32 is the most popular board in the market which is used by the makers like us to make our DIY projects and also by the professional IoT product manufacturers as well. Now if I talk about my channel particularly, then I have made a lot of projects using ESP32 board like controlling our home appliances using Alexa. Alexa, turn on studio. As you can see, studio got turned on and making our Paytm like soundbox.
Hi Sachin, we received an amount of rupees 12 and 34 paise.
A smart pot that can sense our plant's health. So here I'll first power up the board via USB and put it inside the pot. On the phone, as you can see, we got all the sensors reading immediately, and also as all the parameters are according to the need of the plant, it also showing us the happy emoji on the phone. And a lot other projects. And in all those videos, I have covered all the aspects that are required to make that project, so anyone watching that video can easily replicate our project. So if you'd like to learn and make the projects in the field of IoT, automation and electronics, I'll consider subscribing our channel to learn something new every week.
Ladies and gentlemen, girls and boys, welcome back to Espressif DevCon22. My name is Yanis and I'm your host today. After our first short break, I'm back for the midday session of the first day of Espressif DevCon22. Coming up next is YiYing from Espressif's documentation team in Shanghai. YiYing will give us all the details on how to make your documentation for projects based on any of the various ESP32 series look awesome by using ESP-Docs. After this, at around 25 to 1 local time, Adwait Patankar, Vikram Datu, and Shubham Rastogi will tell us all about ESP Insights, Espressif's device observability framework with which you can spot and solve any firmware issues promptly. In fact, ESP Insights is a framework for building robust software faster, and the guys will tell us all about it. At around 1:05 p.m, Espressif's engineer Scott Mabin from the UK will deliver a presentation about using Rust on Espressif chips. Rust is a new systems-level language with an emphasis on memory safety and efficiency. As part of this talk, Scott will walk us through what Rust is, why Espressif is interested in it, and finally, what you can do with Rust on Espressif chips today. Our midday session will finish with a talk by Sachin Parekh and Mahavir Jain from Pune in India. The guys will talk about ESP Privilege Separation, which is a framework designed to prevent user-facing applications from interfering with protected applications and code. This framework allows splitting the traditional monolithic firmware into two separate and independent binaries, that is, a protected application and a user application. But first, let's listen to YiYing's talk about how you can create professional documentation using ESP-Doc. YiYing, over to you.
Hello everyone, I'm Cindy from Espressif documentation team. In this talk, I will share with you how to create awesome documentation for your ESP32X using the doc package ESP-Docs. Here are the contents. Firstly, I briefly describe 3 typical documentation in HTML at Espressif and what the most suitable doc generator to build them from the source format to the target format. Secondly, I will focus on explaining what is ESP-Docs and its outstanding features. Then I'll talk how to build documentation locally and how to deploy the built documentation automatically to your server, such as your own server or GitHub pages. Let's start with a glance at the 3 typical documentation in HTML at Espressif. So the first type is a simple documentation that does not require advanced features, such as navigation menu, auto-generated table of contents, advanced cross-references. There are lots of such documentation both inside Espressif and outside Espressif. An example at Espressif is the ESP-Docs documentation. So let's take a quick look. You just put some documents in Markdown format into a folder, and then the GitHub renders them for you into HTML. The second type is a more complex documentation that requires some advanced features, but does not generate documents for multiple products from the same source files. ESP-IDF is such an example. This type of doc is written in RST format, built by Sphinx into HTML or PDF, and then hosted on ReaderDocs or RTD. Then we'll have a look at the ESP-IDF guide. So it has advanced features such as auto-generated table of content, index, cross-references, navigation menu, and etc. But if you need to develop an even more complex documentation that requires more advanced features and generates documents for multiple products from the same source files, such as ESP-IDF programming guide, then ESP-Docs is your answer. This type of doc is also written in RC format, but built by ESP-Docs into HTML or PDF and then hosted on Espressif server. Let's have a look at the IDF programming guide. Besides the advanced features provided by Sphinx, it also allows users to view target-specific documentation by selecting a target in the upper left drop-down menu here. This presentation focuses on the doc generator of this type of document, ESP-Docs. And what is ESP-Docs? ESP-Docs is a Python-based wrapper for the documentation building package Sphinx. It is intended to simplify and extend Sphinx functionality to better suit what is needed for building documentation for expressive development for frameworks. It provides functionality for building documentation for multiple targets. The target in this presentation refers to the product, or more specifically, a chip series, such as ESP32 or ESP32C3, from the same restructure or RC source files. And it also provides Sphinx extensions used at Espressif and scripts for deploying docs. The diagram shows some key features or extensions of ESP-Docs. Besides the functionality provided by Sphinx here, with ESP-Docs can also write documentation for multiple targets from the same source files with these 5 extensions. And you can also automatically generate API documentation with the 2 extensions run Doxygen and include bit5. Besides, you can redirect HTML pages with this extension and link to code files of the same version as the documentation with the link rows extension. So in this talk, I will just cover this block and HTML redirect and link rows. First, writing documentation for multiple targets from the same source files. Let me first ask you a question. If you are going to prepare a big documentation, let's say hundreds or thousands of pages for multiple targets, or chips or other products, and the documentation for each target is quite similar to each other with a large number of small yet important differences scattered throughout this documentation, which of the following option would you choose? Option 1, prepare separate documentation for each target. So then there's our ESP32 programming guide, S3 programming guide, C3 programming guide, and X programming guide. Then once you need to do updates to the common part of documentation, you need to do it multiple times. And consistency among those documents will be a big headache. And the question is more ESP32X coming? Definitely yes. Is more separate documentation coming? The answer should be, oh no. So I would say no to this option. So option 2, prepare a single documentation for all targets and list target-specific information one by one. For example, when describing the external SPI RAM for each chip, you need to do it for each chip one by one. So ESP32 is able to use up to 4 megabytes of external SPI RAM memory, and S2 blah blah, and X blah blah blah. So in this way, all chip-specific descriptions such as inline words, paragraphs, documents are all provided to customers, and those customers might be just interested in documentation for only one chip. What makes the situation worse is that more chips are coming, and the chip-specific descriptions will take much more space and distract customers even more. Then I have a question. Is it possible to combine the pros of the 2 options? So in other words, can we provide a single documentation for all chips without distracting users with irrelevant information? Answer is ESP-Docs. With ESP-Docs, you can prepare a single documentation for all targets and show target-specific information depending on the target customers select. For example, when ESP32 is selected here, only the common description and ESP32 specific information will show up. So how does ESP-Docs achieve that? Then there comes the first block of features, writing documentation for multiple targets from the same source files. There are 5 extensions here. Format ESP target allows showing target-specific inline text, and list filter allows showing target-specific paragraphs, and top tree filter and exclude docs extensions allow showing target-specific documents. And this add warnings extension can warn customers the documents that are not updated yet. So that's basically all about the first block. Now let's take a look at the second block or second outstanding feature of ESP-Docs, which is automatically generating API documentation using RunDoxygen. So this RunDoxygen extension runs Doxygen to process Doxy files and to generate XML files describing key headers, and then generate INC files that contain breathe directives. These INC files can be included directly into API reference pages. So the Doxy files here contains a list of all header files we need to generate the API reference for. Let's take a look at the example. So the source file looks like this. You just use this directive include build file and explicitly declare what INC files that you want to include. And then here's the rendered effect after the documentation is built. So the header file and then functions here. If you're writing documentation for multiple targets and you are using ESP-Docs, then don't need to implement this step, because this feature is already bundled in ESP-Docs. But if you're writing documentation for one target and don't want to use ESP-Docs, but still you want this feature, you can prepare a script referring to GenDXD Python script. When you're writing code, you need to follow Doxygen style. And then you need to prepare Doxy files referring to the files in the Doxygen folder for documentation with multiple targets, and referring to Doxy files for docs with only one target. And then when writing doc, use the directive include build file or include directive depending on the documentation you prepare. The next extension is HTML redirect. So during documentation lifetime, some source files are moved between folders or renamed, and URL to these target files change as well. This extension allows users with the old URLs to be redirected to the new URLs. For example, if the folder Ethernet is renamed network, go to page redirect txt and redirect the files in this folder. So in this ESP-IDF programming guide, we have a such file. So we add the following line, API reference Ethernet index and API reference network index. This is the original or the old URL, and this is the new URL. So after the documentation is built, the old URL will be redirected to the new URL. This is the old one, and this is new one. Once you click this link, you will be automatically directed to this link. Again, if you don't want to use ESP-Docs but still want this feature, you could follow this section to implement in your own repo. You download this Python script to your documentation folder, and then in Sphinx configuration file, add HTML redirects to extensions, and then create a file with a list of redirects such as the page redirect txt in ESP-IDF programming guide. And then in this redirect txt file, add the old and new URLs. The next extension is link rows. So this extension helps to link from documentation to the specific files and folders of the same version in project repositories. So in a later commit, When the files or folders in the repository are moved around or deleted, the links in documentation built upon the previous commits do not get broken. Let's say on January 1st, in commit A, I added the following hot link into a source document, and then doc A is built upon commit A. And then on January 2nd, in commit B, I moved the hello world folder, which means above hot link gets broken. So as a result, the above link in doc A gets broken. This is the case when we are using the hard link. If the link row extension is implemented, on January 1st, in commit A, I added the following link row into a source document. So in source document, it looked like this. And then doc A is built upon commit A. In doc A, the link always points to the hello world folder of the commit A. And then on January 2nd, in commit B, I moved the hello world folder. The link in doc A actually is not affected and remains valid, leading to the hello world folder of commit A. So let me give you another example. In documenting code, this is a document. If you insert the source code below here, you will get a valid link pointing to the hello world folder of the same commit ID, even if the folder was deleted in master branch. It will still be directed to this commit ID. So the source looks like this, and the rendered effect is like this. And the actual plain link also points to the code of this commit ID, 997844B, the same as this one. Again, if you don't want to use ESP-Docs and still want this feature, follow this usage section to implement it in your own repo. Write a similar scripted link rows to define the project files you want to link to, and in Sphinx configuration file, add it to extensions. For more information, just click this link files here. Then after we are preparing documentation in RST format, how to build it from the RST format into HTML, here are the instructions. First, you need to install dependencies, Doxygen and ESP-Docs. And then you need to build the documentation. First, you change directory to the documentation folder, and then you have multiple options to build the documentation. The first script or command line builds docs for all supported language and targets. And the build docs target ESP32 language English, build docs for the ESP32 target in the English language. And build docs fast speeds up documentation by excluding Doxygen generated API docs. So for more options for building documentation, just click this link. Okay, so then building and deploying documentation automatically with CI or continuous integration. The whole workflow is you prepare some RST files and GitHub continuous integration or CI builds the documentation using ESP-Docs into HTML, and CI again deploy the build documentation into a hosting site. Currently, documentation built with ESP-Docs can be hosted on your own server and GitHub pages. This table provides example documentation, deploying configuration examples, and some reference materials on how to automatically build and deploy the documentation with CI. So that's basically about how to build and deploy documentation automatically. To sum up, what we covered in this talk is some outstanding features of ESP-Docs. The first one is how to write documentation for multiple targets from the same source files, and then how to automatically generate API documentation. And lastly, two very useful extensions, redirect HTML pages and the link documentation to the folders of the same commit or same version. And then we talked about how to build the documentation locally, and then how to build documentation automatically with see and also deploy the build documentation into a server. So that's basically all about this talk. Thank you for watching.
Okay, perfect. Let's invite Cindy, the speaker, and Marius for answering the Q&A. Hello, guys. Can you hear me?
Yeah, we can hear you. Can you hear us?
Perfect. I can hear you as well. So let's start with the first questions. And it's basically all these different models of chips is or are very confusing. Where can I find a table or a summary which gives the difference? Can you please answer this one?
Yeah. I've already posted a link in the chat box. We have a product selector, and you can also find it in our official website. And this product selector allows you to compare the versions, the differences between chips and modules.
Okay, sounds good. So guys, if you are struggling with that, don't hesitate and visit the product selector. You can just clearly compare all the parameters and pick up the best choice for you. Go to the next one. Espressif-Docs are great. Is there a big reason? Like the documentations are a big reason I chose the ESP32. That's nice. And the question is, will there be a faster way to edit docs without a GitHub pull request?
Yeah, we currently don't have any specific plans for that, but making it easier to contribute to the docs is definitely something we want to do. And if you want to change something or suggest something without making a pull request, there's always a feedback button on every documentation page. And that gets sent directly to our documentation team. So that's also a way to contribute if you don't feel like making a code request yourself.
Yeah. So on every documentation, we have a feedback documentation link at the page bottom. You are always welcome to post your questions, ideas, and also your suggestions on our documentation. And our documentation team will get back to you soon, maybe in a couple of days, and we'll reply to you.
Okay, perfect. And then we have the last one, as you already kind of mentioned, the feedback from the community to the documentation is very valuable. So can you please introduce us like the questionnaire, Cindy?
Yeah. So we have prepared a questionnaire to collect your ideas about our documentation. So actually, as you know, we have prepared a huge volume of documentation, and we would like to have your opinions, ideas, suggestions on any document. Yeah, so this questionnaire is just asking your opinions overall. But if you have suggestions on a particular document, you're always welcome to click the feedback link at the page bottom of each document. Yeah.
Okay, we have one like nice feedback. It's pretty nice. Thanks for sharing that. It's good to hear that the documentation is useful. And I have one last questions from the audience, and it's this one. So sometimes useful info is hidden within the GitHub issues and the ESP forum. How can this be improved? Do you have any suggestions or answer to this?
You'll take it or should I take it?
Maybe.
Yeah. And we can see that this is an issue, especially with the forum that's a bit more separated from all our users at the moment. And I think a lot of people don't know that we do have a forum. So one thing that's being considered internally now is if we should also be using the GitHub discussion feature. And that way we would be able to sort of gather more discussions and more useful information all together with our repository and our GitHub issues. And hopefully that way it would be easier to get to all of this information.
Okay, that was the last nice one. So we are aware of the problem and trying to find some other options. So that's it. I see no other questions in the chat. So if you don't have anything else to be shared, guys, thank you for joining, and we can.
So we are now preparing the documentation for ESP-Docs. So we are going to publish it in a few months. So if you have any questions about the ESP-Docs, how to use it, how to write documentation with ESP-Docs implemented in your repo, please, you can always go to the repo of ESP-Docs and leave your questions there, or check our documentation.
Okay, perfect. So we are done. If there are any more questions about the documentation, please, guys, answer them in the chat, and we will move on to the next talk. So thank you, guys. Bye-bye.
Bye-bye.
And the next talk is going to be about ESP Insight.
Hello everyone, my name is Advait Patankar. I am part of the ESP Insights product development team. Today, I, along with my two colleagues, Vikram and Shubham, will run through what exactly is ESP Insights product and how it is beneficial in your firmware product development. Today in this presentation, we will take a look at the background of what led to the inception of Insights as a product. Then we'll take a look at what exactly is ESP Insights. Then we will deep dive into features and followed by a demo. And then what exactly we plan to do as additional features and what else is possible when you start using ESP Insights. Okay, however good or experienced he or she is a programmer, everyone faces a day in their life wherein the program that they have written does not execute as per the expectations. Now, if you have a developer environment at your perusal, you can actually add some debugging information and take a deep dive and analyze the issues. But when, especially in case of IoT firmware development, this is a tricky situation, right? You have lots of devices in fields, and you may not have direct access to the devices. Now, development is done apart from the testing, debugging, and whatever bug fixes that you eventually figure out is done in the developer environment. But the conditions in the final deployment may vastly be different from the developer environment. And the same firmware which executes perfectly fine in the developer environment does not work that well. Now, visibility into these issues will help diagnose and fix issues, and thereby improving the product quality significantly. To exactly solve this problem, this is where we have launched ESP Insights, and that will help the developers remotely take a peek into the execution environment and take a look at the issues and analyze them faster. Now let's take a look at what exactly is ESP Insights. ESP Insights is a device observability framework that allows developers to remotely peek into their firmware to get rich information about the firmware execution itself and analyze and pinpoint issues and bottlenecks, if any. Now, this will help launch the products faster, proactively fix issues, overall reduce the support cost, and also help observe and analyze device behavior patterns like the time of day when it is used, for how long it is used, and other external factors like the network strength or the power consumption, and so on and so forth. What can ESP Insights capture? So it can capture crashes, reboots, maybe intentional, unintentional, and the reasons. You can also check error logs, warning logs, even custom event logs. Then you can have actually metrics, which gives better visualization of your device data and help analyze issues faster and in a better way rather than going through the logs themselves and scanning through a whole set of logs. Then there is also variables that gives information about the point-in-time system parameters. Now let's take a look at individual things, right? Okay, so let's take a look at crash reporting. Now, ESP-IDF provides a facility to store code dumps in the flash memory whenever a crash occurs. ESP Insights actually writes on top of it and helps on the subsequent reboot. The Insight agents reads the information and reports it to the ESP Insights cloud. The ESP Insights cloud then correlates the data with a pre-uploaded ELF file and provides a backtrace to find the exact line that caused the crash. Now, this is extremely helpful to the firmware developer, right? Then there is also information on unintended reports, like say the watchdog or the brownouts, and that can also be useful to diagnose other issues that don't cause a crash but can still cause a major failure. Let's take a look at crash reporting example. Okay, so this is exactly what a developer will see on their browser. This is very much similar to what they can see on a terminal, and you can see the register values, then actual backtrace and the line in the code which has resulted into the crash. This is a sample of the reboot logs, and it gives you exactly when the reboot has occurred and the reason of reboot as well. So you can actually check that if there was a watchdog that has resulted in the unintentional reboot. Then there is a way to actually correlate with the metrics and variable data as well from the very same page, and you can correlate data. Let's take a look at logging. So ESP-IDF itself has a logging framework which can be used to diagnose issues locally and by observing the log prints on the serial terminal. Now, ESP Insights is a step further and it uses this framework to report errors, warnings, and logs to the cloud, and which can give similar diagnostics capabilities remotely to the developer sitting and watching those from their browser. Then you can also add custom logs that can be reported using what we call as events. Now, this is a sample of logs that are visible from the ESP Insights dashboard itself. Exactly when that log has appeared, what information, whatever you have put it in the event log or actual system logs, that is visible here. Then there is a timeline graph that also suggests about at what point of time, within a day or within a week, how many crashes have occurred or what events have occurred. So overall, it gives a good summary of how your system is behaving in the field. Then let's take a look at another important feature, which is the metrics and the variables. Okay, so as I said previously, that scanning through the whole set of logs sometimes becomes difficult to reach to an exact issue at hand. Metrics basically are the values of interest for which there is also a historical patterns that are also, and you can actually it provides trendings and timeline values as well. So it gives a good visualization of the system performance overall. Also, these metrics and variables can be grouped together and linked to create a hierarchy for better visualization, as I said. There is a set of predefined system metrics under the categories like the heap metrics or the Wi-Fi metrics that are supported by default by the ESP Insights firmware. But there is also, you can extend it further to have your own set of custom metrics and variables and plot it to check the performance of your overall system. We will do a deep dive through our demo session that Vikram will cover later. Here's a sample of the metrics. As I mentioned, it gives a good visualization over the timeline. In say last 24 hours, how your system has performed, how your heap metrics have performed, how your the Wi-Fi signal strength, and all those sort of things can be plotted here. This is a sample of the variable which actually talks about the system parameters like IP address and IP network that you are connected to. These all are extremely helpful in actually debugging the issue and pinpointing to the particular issue at hand. Group analytics is another important feature that we have developed. Now, as I mentioned, if you already know a problematic node, it is very easier to go to that, reach to that node and take a look at the logs, the metrics, the variables for that particular node. If you're not aware of, let's say, thousands of nodes in the field and you are not sure which nodes are behaving unexpected crashes and that sort of stuff, then this is the feature that helps you reach to the nodes. It provides a set of extremely rich search filters wherein you can actually write a query and get a list of nodes that satisfy that search filters. Now, for example, you can actually say, list me all the devices that have crashed in last 2 weeks with the say program counter at say cafe 0042. Okay. And it will list all the nodes that satisfy this condition. And then individually you can go to the nodes, you can check the logs, the metrics, the variables, and reach to a pinpointed issue. Thus, the group analytics overall helps you get the snapshot of the overall health of your system and helps narrow down at the issues. This is the actual sample of the group analytics page. You can actually see the overall event stats. You can actually see a graphical representation of how many errors and sort of actually broken down into the categorization of errors. Then you have the timelines wherein you have how the system has performed within a week or a month at the time at hand. So you can actually select the time filters and apply those. And then the list of nodes are actually shown below, which satisfy the search criteria. Okay, now let's take a look at the demo. Over to Vikram.
Thank you, Advait, for overall insights related discussion. Now let's dive into ESP insights on and how easy it is to enable and use it into your project. So let's just jump straight into the code. So here you can see that this is my app main function. This is a typical function which IDF example has. And additional to your basic code, you can see that I have just done one and only one function call, that is ESP insights init. Okay. Here you can see that I have also done timesync init. So this is used by Insights Cloud to actually plot the time series data. If you haven't done timesync, then the times used is nothing but a device uptime. And so using timesync is kind of exact or precise method to do that. And yeah, so it helps, but it's not mandatory. So your features which are really time sensitive, they would impact if you haven't done timesync. Okay. So you can see that in the config, you have two options. One is which log type to enable. You can OR these bits to decide which of the features of the log you want to enable. So we have in ESP Insight traces. So it contains errors, warnings, and our own custom logs, which we call events. So for example, if you remove these two bits, warning and event, you would see that only errors are getting reported to Insights Cloud. Okay, and Insight can, for now, use two kinds of transports. One is HTTPS method, and another one is MQTT. So if you are going with the RainMaker, using ESP Insights bundle with the RainMaker, then you don't need to take care of this because you anyway are using MQTT broker. So for simplicity, let's use HTTPS as a transport, wherein you would also need auth key. This auth key you can obtain from ESP Insights dashboard. So I will just share the screen and show you how you can obtain one. So this is my dashboard. I have logged into this thing, and under account settings, you get an option for manage auth keys. I have already generated one for myself. Then you can just click on the generate new auth key, download that, and embed into your firmware. Okay, that's how you get access to your own dashboard. Okay. Now, as we mentioned that there is only one and only one line required to enable ESP Insights, that is ESP Insights init. Okay. Following remaining features we'll discuss later. These are not at all necessary at this point. Also, you would need to enable ESP Insights from the menu config because by default we keep it disabled. So you just go to idf.py and do menu config. Under component config, you will be presented with two options related to ESP Insights. One is ESP Insights itself, so which you can enable, disable. You can enable debug prints. Then you can also enable core dump. So for which you would also need to add one extra partition into partition table named core dump. So the facility itself is ESP-IDF's feature, and we, on the subsequent reboot, send that data to cloud. Okay, and under diagnostics, we have some system metrics and variables predefined. Mainly Wi-Fi and heap matrices are there. You can enable those from here. So once you enable ESP Insights and the features, and in the code, you have also done ESP Insights in it. It's just, you just need to do IDF.5/monitor on your chipset. Okay. Okay, I have already done this, and I will just show on the dashboard how it actually looks like. From the logs, also I can see my node ID. So in this case, my node ID is 7CDF, which ends with E50. So I will just look for that. So yeah, this is the node ID. So I will just click on this, and I will be presented with the Insight dashboard. And you can see all the features presented over here, which are just discussed by Advait. Okay, so you can see here, it's the overall graph of time series events, warnings, and errors at particular times, how many are there and all. This is overall dashboard. And then you can see here that you have these errors and logs and warnings. Okay, at any point you can click on the error or warning to expand that, and you can see at which line the error has occurred. Okay, so you can also notice that for some of the errors there isn't detailed info. That is because we haven't uploaded latest binary for that. So that binary is that zip file is created by ESP Insights for us, which is created under build folder, and you can upload that under firmware section, which is present over here in under the firmware packages, and this will get resolved by itself. Okay, okay. Back to the code again. So this line I have just added for creating an error. I'm just trying to open some unknown NVS which doesn't partition NVS which doesn't exist with unknown name, and it will just push this error to our cloud. And let's look at how we can add custom metrics. So apart from Wi-Fi metrics, heap metrics, we can also add our own custom metrics and variables. So we'll look into custom metrics. I have done this for temperature sensor, which I have for ESP32S3. So I just will go into what code I have written. I have just initialized temperature sensor, and then I'm registering this particular metrics with ESP Insights. So this function itself takes 5 parameters. There is so all the 5 parameters are of 4 of them are string type, and 1 is enum, which dictates which kind of data I'm sending to the cloud. So first parameter is tag. So tag is the group under which all my matrices will be grouped on. Okay, this key is the unique key across all the matrices, and it should not collide with any other key. Otherwise, your other data will get overwritten. This is the details that will get printed onto your ESP Insights dashboard. This is the path. So path is used to showcase a tree-like structure, so you could have a better understanding of the data. And this is the temperature we are sending is of type float. So Insights dashboard can understand this float type, and it can then interpret it in that way. Okay, so done with the registering, then we will send actual data to the cloud with this function which I have written. So along with the system dump functions, I have also written temperature matrix dump function. So I will be uploading data after each 6 seconds. So under temperature matrix dump function, you can see that I'm reading temperature from the chip, and I'm just doing ESP-DAG matrix add float with the key which I have used for this particular matrix. And that's all. You can see on the dashboard now that it is nicely populated. Okay, so Wi-Fi and heap matrices are already present. These are system metrics, and we have just enabled those via menu config. And this custom matrix is something we have added by ourselves. You can see that it is showing properly. This is chip temperature in Celsius, the details which we have added via our code. So you can enable, disable this particular this thing, of course. So these blue lines represent reboots, and if there are any red lines, then those represent crashes. You can see here that the temperature is 49. After some time, it's 48, and at some time it drops down to 43 and all. So you can use this to have wonders. Yeah. So similarly, you can also add variables. So code-wise, both are almost the similar things, same things, but only difference is that variables just keep only single snapshot of the data, and it is not time series data. So you can see here there are some system variables. You can add your own variables. So you can just see that how SSID or IPv4 are just not needed to have a time series data, but only the variables. Okay, so this is what we have currently under ESP Insights, and now handing over to Shubham for more detailed and futuristic points we will be having.
Thank you, Vikram, for the wonderful and informative demonstrations. My name is Shubham, and I'll be talking about the future roadmap and the plans that we are currently working on in Insights. So the additional features that we are currently working on are advanced analytical queries. So currently you would have seen queries running in the system. So you can execute and create different kinds of graphs and queries. So on top of that, we'll be supporting a richer set of those, and in future you'll be able to make more richer queries and get your work done more quicker. Another thing is command response that we are working on. It is to facilitate cloud to node communication. So currently the node sends the logs to the clouds, and cloud has no way of controlling what kind of logs it requires, when it requires, how it requires. So command response will basically facilitate that process of cloud telling the node what it has to observe or send. Monitors and watches. So basically, we want to have a periodic automated monitoring setup in our Insights so that the user does not have to check the dashboard more often. And on top of that, we will be delivering these anomaly results via alerts and notifications to our users. The user can choose between different kinds of notification platforms. So they can have a SMS or an email, or they can have the notifications delivered to their Slack channel, or so on and so forth. Next is webhook. So to deliver the enriched logs and matrices to the external systems. We have webhooks, so we can leverage that functionality. Another thing that we have is connectors for private clouds. So like RainMaker. So currently we can have RainMaker in private deployments in customers' environment or anywhere. We can actually acquire logs from those RainMaker environments and then process those and enrich those logs in Insights Cloud and then get the meaningful information out for the user. And last but not the least, the long-term storage. So currently we have we provide 1 year of storage for logs and matrices. So for some of you, it may not be enough. So on top of that, we'll be planning some long-term storage at some discounted storage price in Insights. So, currently, ESP Insights is free to use. You can go to insights.espressif.com and check out the latest features and things that are available on Insights. And we will be excited to see how ESP Insights accelerates your product journey. Do keep us posted. Thank you.
Okay, so let's move to the live Q&A session. After this talk about the ESP Insights, I will invite Advait, one of the speaker of the talk. So Advait, are you able to hear me?
Yep, I can. Hello, everyone.
Perfect. Perfect. Nice to have you here. So let's start with the very first question. And it's, is ESP Insight free to use?
Yes, right now it's free to use for individual developers. We are still working on the pricing model, but we'll ensure that it will remain free for low volume users for sure.
Okay, perfect. The second question, will self-hosting the server be possible?
It should be possible, but we will recommend always using ESP Insights as a service.
Okay, perfect. And also Vikram, the second speaker joined. So nice to have you here. Can you hear us?
Hello. Hello. Hi, everybody. Yeah.
Perfect. So let's continue to the third question. Will ESP Insights support writing to SD card so more that data can be collected?
Right now it does not support, but it's I think good suggestion, and we'll certainly look into it as part of our roadmap.
Yeah. So first thing we want to do is use the flash itself to store the data. So because it will also be secured by a flash encryption. So that is the better way, I guess, to start with. Then, of course, we can expand to SD card and other mechanisms as well.
Okay. The next question, which security practices and data storing retention can be expected?
So right now we don't have any limit on data. So it is sort of, we are retaining data for at least a year. We are again working on the storage and how if someone wants to have it for a longer duration, we can plan for that. Around security practices, it's been currently been stored in RTC store, so no one has access to that. On the cloud side also, we have everything is login based things. Only your own devices are visible. Nobody else data is visible.
Okay, perfect. The next question, can ESP Insights be connected with AWS CloudWatch? Maybe
right now it is not supported, but we are working on connectors to actually support pushing data to third-party thing as well. So it should be possible in future. It will be included in our roadmap.
Okay. And we have last two questions. So up to you guys. You can just also divide the answers.
Sure.
So not only Advait is answering. And this one is a bit longer. So if you deploy ESP Insights to a large population of devices, how do you handle the large amount of IP traffic it generates? And how do you stop the device from the sending when not debugging?
So I think Advait should answer this one as well. Yeah.
Okay. So right now there is no limit on how much data can be sent. So we have the capacity enough on the backend side itself to handle large amount of volumes of data. But yeah, if you want to stop the devices from sending, again, as it was covered by Shubham in the very last pieces of the video itself, we have a new feature coming up, which is called command response, from wherein the admin user can control the frequency as well as what metrics to be disabled and conditioned. So right now the data is only flowing one way from the devices to the cloud. Now the feature being developed, it should be available in a couple of months' time. Cloud should be able to control what the data can device send. So an admin user can take control of that. I hope that answers the question.
Okay, so last question for this talk, but not least for this day. And the question is, will ESP Insight allow to change which parameters are interested on the fly?
So actually, currently, the previous answer also, answers a bit about this. So currently, the only way is to use OTA and change the firmware itself. But in future, we will be also adding command response framework. So wherein you can decide from cloud what parameters you need to send and which parameters you want to disable.
Okay.
Yeah.
Sorry. So it seems a lot of new features are coming to be added. So
those are in pipeline, and I think the next quarter you should see a lot more things happening.
Okay, that's nice. So thank you a lot, guys, for joining. See you. And we are going to move on the next talk, which is going to be the talk about Rust from Scott.
Hi folks, my name is Scott Maven and I work on the Rust language enablement team. And today I'm going to talk about Rust on Espressif chips. So what I'll cover today is what Rust is. I know many of you are probably unfamiliar with Rust, or you may have heard of it, but you don't know why you want to use it. Why we're Espressif adopting Rust and starting to use it and support it. What you can do right now with Rust and Espressif chips, and what's the forward outlook with Rust and Espressif chips. So a background on Rust. Rust is a systems level programming language with the slogan fast, reliable, productive, pick 3. They actually sunsetted this slogan, but I like it too much, so I keep it in these slides. The 1.0 release was back in 2015, so it's relatively young, and it has a fairly rapid release cycle of once every 6 weeks. It was previously governed by Mozilla, but since I think about 2 years ago, it's been transitioned to the Rust Foundation. So why Rust? It compiles down to machine code just like C or C++, so it's very quick and efficient. There's no garbage collection. Memory is deallocated as it goes out of scope. This is obviously the case for the stack, but also heap memory is deallocated on drop, so there's no manual need to call free like you would in C or C++. It eliminates a whole class of memory and synchronization bugs at compile time using the type system and a number of subsystems within that. So Microsoft announced in 2019 that over 70% of their CVEs in the last 12 years were related to memory misuse. So you can see why Rust is very appealing to the likes of Microsoft and things like that, and companies like that. Package management is built into the language, and there's a tool called Cargo, which those of you are familiar with ESP-IDF component manager, it's like that, but obviously supports the entire language instead of just IDF components. And finally, it's a imperative language, but with strong functional elements. And if you ever look at any Rust code, you'll start to see that. So why Rust at Espressif? We see it as an emerging language in the embedded and tooling space. So for example, the IDF installer for Windows is written in Rust. So we're not just thinking about it in the embedded context, but also tooling. We expect to be able to write new parts of ESP-IDF in Rust. And we also expect to be able to rewrite certain parts of ESP-IDF which are a bit tricky to maintain in C, particularly some parsing code. Rust has a diverse and large open source ecosystem, and this ties in with package management because it's extremely easy to grab packages from the community. So why Rust for embedded? Obviously, memory safety is an important thing in any application, but memory safety is even more important in embedded systems. On a desktop, the worst case is usually you're going to crash the application, you'll get a seg fault, and the MMU will protect you in that sense, so it won't crash the kernel or anything. But in embedded systems, this is generally different, and you're probably going to end up rebooting the chip if you do like a null pointer dereference or something like that. So Rust's compile time elimination of those bugs is extremely helpful. There's native async support inside the language, which, and when I say native, I mean it's part of the language. It's not a add-on. And I'll go into a bit more detail about that later. Rust made the active decision to split the core library from the standard library, and the core library is essentially a freestanding library that describes anything that has no, it makes no assumptions about the environment it's operating in. So it doesn't assume threads, it doesn't assume you can allocate, it doesn't assume there's networking. That's where the standard library comes in. It makes those assumptions and builds on top of the core library. This means it's easy to create targets that just target the core library, and then in the situation where you have threads, mutexes, etc., you can then target the standard library. Again, package management is very useful. So we have ecosystem-wide interface crates like embedded HAL, and this describes how certain embedded interfaces like SPI, serial, GPIO pins should interact. What that means is drivers and HAL implementers can depend on embedded HAL, and that essentially forms a contract as to how the interfaces work. And what that means is you can then mix and match any HAL, so basically any chip that implements embedded HAL, with any driver, so temperature sensor, a accelerometer, anything like that, and it just basically works, which is really nice. And usually in C or C++, you would need to have some glue code that every driver would have a slightly different way of setting up this glue code. So it's nice that it is done for you. There are also some other crates like Heapless, which is a non-allocating data structure crate. I know it's a bit of a rite of passage when you start an embedded C project, you write a queue because you obviously need one. But it's nice to just be able to drop Heapless in your cargo.toml, and you have access to a correctly implemented queue, and they've got loads of other things like a min heap, a linear map, I think even a hash map with a efficient hashing algorithm. And there's 1,000 more on the awesome embedded Rust list, and also you can search crates.io for no STD, and you'll find crates suitable for embedded. So what's possible right now? So we currently support 3 approaches with using Rust on Espressif chips. So we have the ESP-IDF project, but you want to use a bit of Rust, a Rust project that you want to utilize ESP-IDF, and bare metal Rust or pure Rust. So ESP-IDF plus Rust. This is for the situation where you have an existing project in ESP-IDF, or perhaps you don't want to write the whole application in Rust. We have the option to create ESP-IDF components in Rust. And because Rust has good interop with C, you can just expose the C interface to the rest of your application. This is particularly useful for things, like I said earlier, like parsing. Rust has very nice tools for parsing strings and parsing just general data formats safely and efficiently. So you may wish to write a Rust component that does a specific amount of a certain amount of parsing for your application and pass the result back to through the C interface to the rest of your application. Then we have the Rust on top of our ESP-IDF approach. So fortunately, ESP-IDF has a new lib component, which the Rust standard library can use to basically interact with ESP-IDF. And this means that you can build the standard library for ESP-IDF, which means you get threads, mutexes, networking, and more, which is really nice. On top of the standard library items, though, we can also leverage the peripheral drivers and other components that exist in ESP-IDF. So by writing Rust wrappers around the raw C interfaces, we can essentially call into ESP-IDF and drive peripherals or certain other components that you may wish to use from Rust. Then we have the bare metal approach. So bare metal programming in C and C++ isn't particularly common, and I would say especially so for R chips. I haven't seen any conscious effort for programming in bare metal in C for R chips. It may exist, but in Rust we're trying to support this, and one of the main reasons is the fact that async is supported by the language and doesn't require any allocations or anything like that. Async in Rust basically compiles down to state machines, and the reason why this is important is because you can, with async, you can have efficient, safe multitasking without a scheduler or anything like that. Typically in bare metal applications, you're generally limited to one, a single thread that does a load of things in one go, and it becomes quite unwieldy to manage that. Whereas async really helps there. So a bit more background on async if you're unfamiliar with it. Async is a form of cooperative multitasking where tasks, and I've put tasks in quotes here to not be confused with FreeRTOS tasks, which are essentially threads. Because obviously in FreeRTOS there's a stack size and the scheduler will swap out the threads. This is not the case with async. When async tasks get to a certain point, they will say, come back later, I'm doing something that's going to take a while, and they manually yield the processing time to something else that may be able to continue. Or in the case of some of the embedded executors that exist in Rust, if there's nothing to do, you can just put the chip to sleep until an event wakes it back up, which is really quite nice. So async in Rust adds two new keywords. The async and await keyword, where async defines a block or a function to be asynchronous, and await defines yield points within that function or block. And so here we have the example, asynchronously writing a message to a UART here. So the yield points are wherever you see a dot await. So in this instance, you would set up the message, queue the bytes to be written to the UART, and then await. And behind the scenes, what this will do is, queue up either a DMA or shove it in the FIFO and wait on an interrupt. And then during that time, the executor can go back and try and do something else until this is woken up. And then obviously the next line, and then another yield point there. So what async is not, I've seen a common misconception when developing an application that is either blocking or async. I don't think this is the case. I think async and blocking can and should be used in conjunction with each other when you can. It's perfectly valid to have a fully async application or a fully blocking application, but mixing the two together can yield some really cool results. So an example of that would be async in an RTOS environment. You may think when you have threads, async may seem redundant because threads are your concurrency model, but it can be used to reduce your memory usage through stack sizes and sometimes even power usage. If you know that you've got nothing to do, the scheduler can put the chips to sleep. So take an application that has one heavy computation task and 3 smaller IO bound tasks. In a traditional thread-only based model, this could use up to 4 threads with varying stack spaces. Combining the async and blocking approach, however, you could reduce this to just 2 threads, one for the heavy computation that you don't wish to be interrupted very often, and another which asynchronously multiplexes the other 3 IO bound tasks. So what you may find is you've probably written something like this asynchronous multiplex task, where you just have a util task that checks 3 or 4 different things, as opposed to them being separate tasks in the sake of saving stack space. What's nice about async is that the compiler writes the state machine for you, which is really cool. And I find, like, just coming back to this example, the execution flows in this order, which logically makes more sense when reviewing code. Even though it may be doing things in between this, there's no chance that write bytes, that goodbye could come before hello world. So on to chip support. There's one limitation for all the projects, so bare metal and ESP-IDF projects, and that is if you're targeting an extensor chip, there needs to be support in our LLVM fork. And because of our LLVM fork, we also have a forked Rust compiler. So if you're targeting extensor, which is the ESP32, ESP8266, the S2 and the S3, you'll need a forked Rust compiler. Fortunately, all of our extensor-based chips are already supported in our forked LLVM. So it's just a case of downloading the other compiler. But as new chips come, they'll need to be supported in there too. Our RISC-V based chips are already supported upstream in LLVM, so there's no need to worry about them. So chip support for the standard library or ESP-IDF approach. The general rule of thumb is if ESP-IDF supports it, then so does this approach. There's a little bit of work to do, perhaps adding a new target in the Rust compiler, or perhaps some CFG work to feature gate certain peripherals for this chip. But most of that is relatively trivial. So support comes very quickly to standard library or component-based projects. Bare metal's a little bit different. I wouldn't say it was slow, but there's a few extra steps. So obviously one is we now have to write the drivers in Rust. We can't just use the ESP-IDF implementation. There's also some precursor work to generate a SVD file, because in Rust we use a tool called SVD to Rust, which will take a SVD description of the chip, all the peripherals, what interrupts it has, etc., and it'll generate Rust code that allows you to access these peripherals, and these are called peripheral access crates. And you can see in the second column of this table, pack is peripheral access crate. As you can see from that table, we already support all the chips except for the C2 and the H2. I know for a fact the C2 is being worked on right now, and I believe we have some level of support for it, but it's not been merged yet. So the general rule of thumb is that bare metal will take a little bit more time to support a chip, but in my experience, it's not been that long. So hopefully by this point, you're excited by Rust. Yeah, so I'd like to talk about what we want to do next. So we'd like to upstream our LLVM extensor backend. This will make things simpler for everyone, including ourselves. So we've had the patches in review for a few years, but we're making a really strong effort right now to try and get some more coverage on that. And once it's upstreamed in LLVM, we can then upstream our Rust patches, which will be nice. We've already actually upstreamed our RISC-V based patches because RISC-V is already supported in upstream Rust. So it's just the extensor stuff to do. We'd like to provide Rust bindings for existing components. So we have bindings for most of the core components that actually live in the ESP-IDF repo on GitHub. But we'd like to start offering bindings to important but external components. For example, ESP RainMaker doesn't live in IDF proper, but it's a very interesting component to use. We'd like to improve bare metal support. This is an ongoing thing. And that would include adding Wi-Fi support to more than just the ESP32 and the ESP32C3. So the standard library supports Wi-Fi and Bluetooth on everything, basically. Just because we use the ESP-IDF implementation. For bare metal, there's a bit more work that goes into adding support for Wi-Fi and Bluetooth. So at the moment, we only support the ESP32 and the ESP32C3. But hopefully we'd like to extend that to the S3, the S2, and the C2. And there's plenty more. Those are just 3 things that I pulled out from the project board. There's we do all of our work out in the open on our GitHub repo organization, sorry, ESP-RS. So feel free to check out the project board after this. So hopefully you're excited by Rust and you may want to try using some Rust on our chips. We actually have some free training available. So we contracted a company called Ferris Systems to write some training on using the Rust standard library approach to create a Rust project using I believe an ESP32C3, but it should work for all of our chips with a bit of tweaking. And there's a workshop available. It's all online, and yeah, it's really cool. So if you're interested even a little bit in Rust, I would definitely check that out. And I have the link here with some other stuff. So there's the link to the Ferris training. We also have a book, which is a work in progress sort of overview book of the ESP-RS effort. This has some installation guides, some debugging guides, an overview of the approaches, so a bit more in depth than what I've gone into today, and sort of how they work a bit more, and plenty more. This is a link to our just our GitHub organization in general, and you'll find plenty of repos in there that I haven't covered today. That'll be very interesting. One of which will be ESP template, and this is a template for a bare metal project. So we use a tool called Cargo Generate as our templating engine. And what that means is you can just do cargo generate and the GitHub URL, and it'll give you a set of options to create the project and create the project for you, which is really cool. And we also have one for IDF projects, and this project generator supports either standard library projects or component-based projects, which is nice. Finally, the last link is a link to my blog. So I've been working on this for many years now, and I've been detailing the progress over the years in a series of blog posts. So if you're interested in the history of how we got this far, you can read back through that. I also post an update every quarter detailing the progress over the last quarter. So if you want to keep up to date, feel free to follow that. But yeah, I think that's me done for today. Thanks for listening.
Okay, perfect. So the Rust talk is over. Unfortunately, Scott is not able to participate in a live Q&A, but he was answering in the chat on YouTube. So thanks a lot, Scott, for that. In general, it seems that there is a lot of guys who likes Rust. So we are really happy to hear that. And as Scott mentioned at the very end, feel free to just jump into the GitHub repo or just leave any feedback. You know, the Rust community is pretty lively, so it's pretty nice to join and also easy. And that's about the Rust. And now we will just continue with the last talk of the second block, and it's about ESP Privilege Separation. So keep in touch, guys, and let's move on.
Hey guys, welcome to the Espressif Developer Conference 2022. Myself, Mahavir Chen, I'm working as a Senior Software Manager with Espressif Systems. Today's talk is Espressif Privilege Separation. And this is completely open source framework, which is available on the GitHub repository. And it was released some time back. The purpose of this particular framework is to achieve user kernel separation on Espressif platform. So let's begin. So let's quickly go through today's agenda. I will briefly introduce this particular framework, the reasoning behind design of this particular framework, and how we went about it. What are the benefits of this particular framework? And then we shall deep dive into the technical details. And we have lined up some of the interesting demos that are built on top of this framework. So let's start with the introduction. So let me cover the background first. The typical real-time embedded systems have the monolithic firmware. In case you have worked with any MCU class devices, or for that matter, ESP-IDF, which is Espressif's official IoT development framework, then it also takes the similar approach of the monolithic firmware. There is single executable or single binary that runs on the MCU. It is completely statically linked. This particular framework runs in the highest privilege mode, and it has pretty much complete system access. Now, there are certain peripherals like memory protection unit, which have been enabled in the ESP-IDF, which is our IoT development framework, that can limit the access to certain memory regions. For example, only read and execute permissions for the instruction memory, and no write permissions. So there is certain level of access that we can control, but otherwise this monolithic firmware has pretty much entire system access. So with this, we can see we are taking ESP32C3 as an example here, which is the exclusively supported SoC in this particular framework. And we can see the architecture over here, which is monolithic firmware executing on the ESP32C3 silicon. So what are the typical problems with traditional or this monolithic firmware based approach? A simple user application fault can take down entire system. There are also some security concerns, because if there are any remote exploits available in the firmware, then it can have a very wider attack surface, because the firmware runs in the highest privilege mode and it has access to the entire system. And the third aspect here is the firmware responsibility. In this particular aspect, the product owner or the product developer has the responsibility to manage Wi-Fi driver, the networking stack, the operating system, TLS stack, and so on. So he needs to know about all of these pieces and has to take the entire responsibility of this particular framework or the firmware. So let's start with the goal. What are we aiming here in the Espressif Privilege Separation framework or offering? So this is the traditional approach of the monolithic firmware. It executes a single firmware binary. And with this particular framework, we shall be splitting up this firmware into two separate executables, kernel.bin and the user.bin. So here we can see a secure application and a non-secure application. They shall have different privilege levels, and they shall have a different memory and peripheral access and controls. We shall go into more details in the subsequent slides. So what are the possible approaches to achieve this particular separation? Primarily, there are two ways. The first is the trusted execution environment. In this particular approach, the OS or the kernel itself is not trusted. The secure application is extremely thin. For example, we can take a use case of a firmware interacting with some crypto coprocessor over a peripheral interface. It could be I2C. Now, in this case, only the device driver that is interacting with this particular crypto co-auth processor is trusted, and rest of the operating system, networking stack, and so on is not trusted. This kind of approach helps in certain security certification to meet criteria for certain security certifications. The second approach is user kernel like separation, which we see in the general purpose operating systems too. In this, the operating system or the kernel is trusted. However, the non-privileged application is extremely thin, and it could be the product specific logic. For example, a smart connected bulb, switch, outlet, and it could be extremely thin or minimal firmware. This particular framework, ESP Privilege Separation, explores the second approach, which is user kernel like separation. So with the background covered, let me introduce the user kernel separation here. As highlighted, we can see the monolithic firmware approach, which contains FreeRTOS, Wi-Fi driver, networking stack, and the application logic, all combined into a single firmware entity. And we can see the split firmware approach, where the secure application contains the kernel, FreeRTOS, Wi-Fi driver, and networking stack pieces, and the user app contains the product-specific business logic. So with secure split, we are saying that both firmware images will run in the separate privilege levels. There would be controlled access to memory and peripherals. Again, this particular access is configurable and can be defined at the product definition stage. And there would be a secure communication channel between the two separate firmwares here to avail some of the services that are exposed by the secure application. For example, it could be some OS services, networking services, and so on. So let's quickly go through some of the benefits of this particular approach. So first and foremost benefit here is the separation of concerns. What we can say here is that the application specific logic could be owned by the ODM OEM. It could be very minimal firmware. For example, a firmware that is responsible for smart switch or smart outlet. And the rest of the firmware could be owned by the platform entity. Now, this firmware could contain kernel, FreeRTOS, Wi-Fi driver, networking stack, and bulk of other pieces that are responsible to run the product. Now, this particular framework also provides a secure development cycle because the non-secure entity or the application here runs in the lower privilege mode. It has a restricted access to memory and peripherals. Thus, any remote exploits or any bugs in this particular firmware have very limited attack surface because of the strict enforcements made on the memory and peripherals. The third important advantage is certification. If there is any modification in the user application part here, then we may need not go through the entire certification process, which is required for some of the frameworks or the products. So it could help in certain scenarios and where the protected application is not being modified. And the fourth important advantage here is the better exception handling or the better exception management. Since this non-secure application does not have the entire memory or the peripheral access, we could easily handle their exceptions in a well manner. So we will have more details on this in the subsequent slides and the technical details too. Let me introduce the ESP Privilege Separation framework, and what it helps to achieve is the separation of firmwares. It provides a system call interface for the two firmwares to interact with each other. There is a configurable memory and peripheral access, and this could be set during the compile time or the build time options itself. There is flexible memory split for the protected and user application. And the biggest advantage is it also provides a consistency with ESP-IDF APIs. So we have envisioned that moving ESP-IDF examples into this particular framework should be very convenient and easy. So here is the traditional approach that we discussed, which is the monolithic firmware based on ESP-IDF framework, and it's a single executable. And with the ESP privilege separation, one could achieve a split in the firmware into two separate entities, protected application and the user application. Protected application runs at the highest privilege, and the user application has restricted memory and peripheral access. And there is a secure communication channel between these two entities in the form of a system call. So with this introduction, now we will move into the technical details section. So I will hand over to my colleague Sachin Parekh, who is working as a senior software engineer with Espressif Systems. Over to you, Sachin.
Thanks, Mahavir, for introducing and providing a brief overview of this framework. Now let's talk about the technical details. Let's begin by looking at how a project in this particular framework would be structured. So on the left, we have the Blink project in the typical IDF scenario. It has a top-level CMake list, which includes all the routines required to build the application. Then there's partition.csv file, which defines the flash layout. And then we have the main folder. The main folder consists of the app_main source file, where the actual code is being written. So this is where the application logic exists. And once you build this project, it would generate a blink.bin file, which would be your application, the monolith application. Now let's see how this same Blink project is structured in the ESP privilege separation. So it has a similar top-level CMake list, the partition.csv file, and it has two different application folders, protected app and user app. Now the protected app consists of its own main folder where the protected application resides. So whatever code that is being written in the main folder would be built as the protected application. And then the user application also has its own main folder, and the code written inside this main folder would be built as user application. So now one thing I would like to highlight over here is that the privilege separation framework is built on top of IDF. So we have tried to maintain the same workflow as you are already familiar with. So the Blink project inside the ESP privilege separation would build two different applications, protected app and user app. And if you're familiar with the CMake build system, then the user app is built as an external project. And the project uses the same IDF build commands. So idf.py build would build the entire project, and it would build two applications, the protected app and the user app. idf.py flash would flash these binaries onto the device. So once these binaries are flashed on the device, let's see how they boot up. So here on the top, we have the application boot up of a typical IDF application. So on reset, the ROM bootloader starts executing. The ROM bootloader looks for a valid second stage bootloader in the flash, and if found, it loads into the memory and hands over the control. The second stage bootloader is responsible for initializing the system. And once initialized, the second stage bootloader looks for a valid application in the flash, and if found, it loads into the memory and hands over the control. Now, at the bottom, you can see the application boot up flow of a privilege separation project. So the first two stages are the same. That is, on reset, the ROM bootloader starts executing. It then loads the second stage bootloader, and the second stage bootloader loads the protected application from flash. Now, typically, the protected application would consist of the FreeRTOS kernel. And once the entire OS is up and running, it would then look for a valid user application in the flash. And if found, it would set appropriate permissions and execute the user application in a separate task. So in this way, we have both the protected application as well as the user application running concurrently on the same device. Now, if they are running concurrently, we need to make sure that their boundaries and their access permissions are managed. So for that, we need something called as execution environment. The primary function of the execution environment is to provide two things. First is a component that manages the permission, and the other is to provide a component that manages the privilege level. So in ESP32C3, we introduced two new hardware peripherals called permission control, which, as the name suggests, is responsible for managing the permission, and the other is the world controller, which is responsible for managing the privilege level. So in ESP32C3, there are only two worlds that are being supported currently. One being world 0, which will also refer to as secure world, and world 1, which we will also refer to as non-secure world. Now, these two worlds would have their own set of permission controls. So the permissions of a particular region can be configured depending on the world that is being executed. So now let's talk more about the permission control peripheral and its function. So the permission control is responsible for splitting the memory between user and the protected or the kernel memory. So it's responsible for enforcing strict permissions. So if there is any violation, it needs to be caught at real time. And if in case there is a violation, it also needs to log certain information, which will help us debug the problem. So now let's see how the internal RAM is being split. So here you can see the diagram of the entire SRAM block. So the permission control has a concept of split lines. So there are three different categories of split line. The first is the main ID split line, which is responsible for splitting the RAM into IRAM and DRAM. So this is the main ID split line. The other category is the IRAM split line. It is responsible for splitting the IRAM block into further blocks. And similarly, we have the DRAM split line, which is again responsible for splitting the DRAM into different blocks. So now once we have split the blocks in multiple regions, we can also configure them. And we'll configure them in such a way that the non-secure world or the world 1 can only access the topmost IRAM block or the bottommost DRAM block. And hence the labels user IRAM and user DRAM. Now, if the non-secure world tries to access any region in the protected space, then it will raise an interrupt. Now, one thing to note over here is that these lines are highly configurable and they can be moved up and down depending on the use case of the application. And other thing is that the reason why we have chosen this particular layout of user IRAM followed by protected IRAM followed by protected DRAM followed by user DRAM is because it allows us flexibility when updating the protected application. So if in case the future protected application requires more IRAM or more DRAM, then we can simply move the main ID split line up and down to accommodate these changes without affecting the user application. So similarly, we have also split the flash cache. So we are talking about the flash virtual memory address space and not the physical flash. So we have split the flash right in the middle. So the top 4 MB belongs to the protected space and the bottom 4 MB belongs to the user space. So now we have the permission in place. Now let's see how the privilege are switched. So the reason why we need a mechanism to switch privilege is because the protected application as well as the user application are running concurrently on the device. So let's first look at how the switch from secure to non-secure world happens. So for that, we need to configure the registers of the world controller. So the world controller consists of a dedicated register, which needs to be configured with the address of an instruction. And once the CPU fetches that instruction, it would switch to the non-secure world. So for example, if you want to execute function foo in the non-secure world, then you need to configure the world controller register with the address of foo. And now whenever CPU would execute function foo, the world will automatically switch. So you need to know the instruction at which the world switch would happen, and you need to configure the world registers every time you want the switch to happen. So now let's talk about how to switch from the non-secure to the secure world. So this can only happen through interrupts and exceptions. So any interrupt or exception generated on the device would automatically switch the world from non-secure to secure world, and then the corresponding handlers would always execute in the secure world. So there are certain architecture-specific instructions, for example, eCall in RISC-V, which allows us to generate a synchronous exception so that we can deterministically switch from non-secure to secure world. So let's see how permission control and world controller work together to enforce permission. So let's say we have the following configuration done for the following address range as highlighted over here. So as you can see, world 0 has complete access, read, write, execute access to any address in this range, while world 1 only has read access to this range. So now if world 1 tries to perform a write operation on any address in this space, then it would trigger a violation interrupt, while world 0 wouldn't trigger any violation interrupts. So now let's see how we can handle the exception in the user space. So in the monolithic application, if there is an exception or hard fault that occurs, then there is no guarantee of the state of the system at that point. So naturally, we just reboot the entire system. But in this particular framework, since we have the protected app and the user app isolated and with well-defined boundaries, we can be sure that when the user application crashes or an exception happens in the user application, then it won't impact or it won't affect the protected space state or the protected app memory. So because of that, we can ensure that the protected application can continue to run even while the user app has crashed. And this can allow a lot of different functionalities. One such that I can think of is the protected application can collect diagnostic information of the crashed user app. And if there is a connectivity, then it can report it back to the backend in real time. So now let's see this in action. So now here we have the Blink example, and I have tweaked it in a way that it would generate an exception when a button on the board is pressed. So I have already built the application, so I won't be building it again, but you can just build it through idf.py build, and it would just build it. And I have also flashed it on the device so that we can save some time. So I'll just run idf.py monitor, and you can see that this is the device that I'm working upon. And you can see that the LED is functional and it is blinking at a regular interval. And if you look at the logs, you can see that the boot up flow, the boot up sequence that we have discussed, that the ROM bootloader executes, and then the second state bootloader executes. And then this is where the protected application is booted up. And then once the protected application starts the scheduler, it then looks for a valid user application, and if found, it loads into the memory and then starts executing it. Now the protected application as well as the user application are running concurrently. So this print that you see, hello from protected environment, is actually from the protected application, while these prints that you see are from the user application. Now if I have this button over here, which can be used as an input, and once I press this button, it will lead to a crash. So if I press it, you can see that a crash dump has been observed. So what happens is the user application has crashed because of some reason. And then once that happens, the protected application detects it, and then it dumps a bunch of information on the console. So you can see it has dumped why exactly the error occurred, and in which particular task did the error occur. And then it also dumps the CPU state at the time of exception. So a lot of information can be inferred just by looking at the state of the CPU during that time. And now if you have the ELF file of the user application on your system, then the idf.py script can also generate a backtrace for you. And this is exactly what it has done. So you can see it has generated the backtrace, and it is pinpointing to this particular application and in this file and on line number 49. So if you look at the statement, it says that I'm trying to store value 0 at null pointer, right? So this definitely is a problematic statement. So just by looking at this dump, I was quickly able to realize my mistake. And if you have the connectivity on the device, then like I said, the protected application can gather all this information and can send it back to the backend in real time. You can see that the blink is still functional, the LED is still functional, and you can still see the print from the protected environment. So this is one of the exciting features that of this particular framework. So now let's get back to the details, technical details. So we saw an interesting demo of the user space exception handling. Now let's go further into the technical details. Now there can be a requirement where the user application wants to access certain protected services. For example, the certain OS primitives. So the user code wants to spawn a new task, or let's say wants to grab a semaphore. So for that, there needs to be a way in which the user application can access those services. Now, if it directly tries to execute those routines, then it would lead to a violation interrupt, as we saw earlier in the demo. So there needs to be a proper interface through which it can be done. So in this, we have implemented the system call interface, through which the user code can request certain services, and if they are valid, then the protected application would execute those in the higher privilege levels. So what exactly goes into the system call is that the user code uses certain architecture specific instruction. So earlier I mentioned the eCall instruction in RISC-V. So what the user application does is it populates the CPU registers with its request, and then it calls the eCall instruction. As soon as the eCall instruction is encountered by the CPU, it generates an exception. The exception causes the world to switch to a secure world, and the secure world handler pitches in. Now the system call handler would validate the user arguments, and if they are valid, then it would execute the intended functionality. So there are certain requirements of this system call interface. That one, it should access protected services in a controlled manner to the user application. Second, to ensure that no user argument is passed to the actual functionality without validation. So if there's a null pointer, you need to make sure that the null pointer is not passed as it is. The checks should be in place. And then other thing is to ensure that no data is being leaked back to the user code once it returns back. And it is also the responsibility of the system call interface to ensure that it returns back to the same place where the user code requested the system call. So you would be wondering if you are required to implement all the system calls. Well, that's not the case, because the framework has most of the core services system calls provided. So we have provided system calls for the OS, the networking stack, the Wi-Fi drivers, and so on and so forth. But still, there could be cases where you would want to implement your own custom system calls, right? So for that, we have made this framework extensible in a way that you can define your own custom system calls at a project level. So you don't need to even tinker with the framework. You can just define your own custom system calls at the project level, and the entire build system would take care of it. Then there's also the ability of API consistency. So what I mean by the API consistency is that you can use the same function prototype in the protected application as well as user application. So let's say, for example, xtask create or vtask delay. So these are certain OS primitives which will be used by both protected application and user application. So now if protected application uses vtask delay, then the build system would pick the vtask delay implementation from the FreeRTOS. But now if the user application calls vtask delay, then the build system would pick the system call implementation which we have provided in the framework, and it would be routed through the system call interface. So this API consistency is achieved through the linker flags. Now let's look at how the components of the IDF are split in this application. So the component split is pretty flexible. Let's take an example of the ESP HTTP client application. So here we have the entire TLS stack, and it is up to the developers of the protected application to decide where to place the ESP HTTP client component. So one example would be to place the entire TLS or the ESP HTTP client component inside the kernel. So for that, protected application would have to implement its own custom system calls for the ESP HTTP client component, and then the user application would use this system calls to access HTTP client or the network. Now, other approach is to only handle the lower level socket operations at the protected app level and defer the rest in the user application. So for example, here the entire TLS stack can go into the user application, and the protected application would just care about the socket operations. So this is the real life example which I was just talking about. So we have this ESP HTTP client example in our repository, which you can go and try it out. So in this, what we have done is the user app has the entire embed TLS stack and ESP HTTP client component, and the protected application only handles the operating systems, the Wi-Fi stack, and the networking stack. So in this way, the component splits can be achieved the way you want and depending upon the application use case. So now let's look at certain design choices that we have made. So the first is the device driver model. So in the IDF application, if you see, the device drivers are not consistent. Each and every peripheral has its own set of APIs and they have different prototypes. So what we have designed, or what we have envisioned, is that the user application should not deal with all those different APIs. So we have planned to implement the entire device driver in the protected space and expose these device drivers to the user through the POSIX compliant IO system calls, which are open, read, write, etc. So from the user app development side, you just need to worry about these 4 or 5 function calls, POSIX compliant function calls, and it will give you access to various peripherals. And the other approach is to grant the user application access to the peripheral register address, and then it would be the responsibility of the user application to develop its own driver. Now, naturally, the follow-up question is, how would the user space interrupt or event handler handle? So now the user code cannot be allowed to execute in the ISR context. The reasons is that it could lead to a nasty misbehavior. So for that, we had to implement our own dispatching mechanism in which we create a different task and dedicated task, which executes the interrupt or the event handler of the user as soon as the event occurs. So these handlers run in the task context, but they are ensure that they get the priority over all the other tasks. Now, this definitely has certain impact on the memory, and it also introduces certain latency. So now let's look at the OTA part. So now, since we have the protected application and the user application running independently, one natural requirement would be to know whether the user application can be updated. And yes, we do provide this facility. So it is possible to update the protected application as well as user application in this framework. Now, since the update of the application relies on verifying the image and writing on the flash, this entire workflow is only handled by the protected application. Now, it is also possible to independently update protected and user app at different time intervals. So it could be possible that you first update the protected application and then at some later stage, you update the user application. Now, security is also of a concern while doing OTA upgrade. So we also have the ability to securely sign and verify these application while doing the OTA upgrades. So it ensures that only authorized code can execute on your device. And both of these applications can have different signing keys. So it decouples them from one another. So now let's look at the overall OTA upgrade workflow. So like I mentioned that the entire process is handled by the protected application, but it's the user code which will instigate. So initially it would just pass the URL to the protected application through system call. And this URL should consist of a valid user application. It verifies the URL, and then once it's verified, it handles the entire OTA workflow in the background. Now, if you look at the partition table, you would see that we maintain 2 symmetric app partitions, one for protected application and one for user application. So over here, OTA underscore 0 and OTA underscore 1 are corresponding to the protected application, while user 0 and user 1 correspond to the user application. So now let's take a look at the demo and let's see it in action. So here we have the ESP user OTA example. It will demonstrate the update of the user app through Wi-Fi. So here you can see that I'm running a local Python HTTP server where I have hosted my binary, which I'll be updating. So again, I'll just make sure that I'll just flash. So in this particular application, the protected application connects to the Wi-Fi, and the user application does nothing at this particular moment. And now once we update the user application, it should start blinking the LED, which we have already seen in the previous example. So I'll be updating the user app with the blink example. So if you can see over here, it just has the LED at the solid state, and it's solidly on it, and it doesn't toggle at a regular interval. So now what I would do is I would just copy the command to update. So here I'm passing the URL through CLI. So as you can see, I can input something. So the command is user OTA followed by the URL. So I'm passing user OTA followed by the URL. And once I hit enter, the OTA workflow would begin. Now you can see over here, as soon as I have updated, you could see that the LED has started blinking. And if you look at the logs, you would realize that the update was only roughly around 100 KB. So this is one of the feature of this framework where the user application is very minimal. So here only around 100 KB was required to change the identity of this device or change the user application, as opposed to the typical 1.5 MB of the entire application. Now let's get back to the technical details. So with all the features and highlights being talked about, let's see what impact does this framework have on your application. So definitely there are impacts in the performance and the resource areas. So every system call execution has an overhead of certain CPU cycles, and then since the user application code can never execute in the ISR context, it has certain latency while servicing the interrupt routines. So the numbers are highlighted in these slides. And there's also certain resource impact. So each user space task requires a corresponding kernel stack. This is because the kernel stack ensures that the data isn't being tampered while executing the system call, and no data is also leaked out. And there are certain tasks which are required to dispatch the event or the ISR handlers and to clean up the user memory. So even these tasks consume certain memory. So with all that discussed and talked about, let's see the resources that are available online for you guys to try it out. So we have the repository hosted on the GitHub. And then we also have our documentation where you can find all these details that we have talked about and much more in greater depth. We have also published 2 blog post articles, one being the introducing ESP Privilege Separation and the other being a case study, a real world case study where we are using ESP RainMaker and ESP Privilege Separation framework together. And if you want to dive deeper into the chip, you can refer to the technical manual reference and you can find a lot of information over there. One thing that I would like to note over here is that the framework is still in the beta phase, and we urge you to try this framework out at your end, tinker with it, and we'd love to hear your feedback and the use case that you are envisioning. And in the meantime, if you encounter any bugs or issue, feel free to report in the same GitHub repository and we'll be happy to help. With that, I would like to conclude this presentation. Thank you for watching this presentation, and we'd like to hear back from you. Thank you.
Okay, so we are back live from Brno, and I will invite the speakers of the talk. So let's add them to the streaming. Hello guys, please, you need to unmute yourself on your machine. You are muted now.
Yeah.
Yes.
Hello everyone.
Hello.
Perfect. So we are live. We can go and start with the questions. So the first one. Will this separation be only available for the C3 or it will be also for the S3?
So we do have plan to add support for S3. So it will be probably merge in the coming weeks.
Okay, perfect. So it seems it's going to be early. The second question, is there any talent for the S3 support? So it's basically the same. It was answered. So let's move on to the next one. Will this support separation on PSRAM?
Yeah, so our initial plan is to support Unicore S3. Like we only enable a single core on S3, and then once that support is let's say stable enough, then we'll move on to adding support for PSRAM and then eventually for dual core support.
Okay, thank you. The next question is from Leung Haze. Can I have multiple user apps on the same device?
So yes, multiple user apps can reside on their individual flash partitions, and the protected app can pick and choose which one to activate. So at this moment, only a single user app can run, but definitely multiple apps can reside on the flash. We haven't yet faced the use case where it would be desirable to have multiple user apps running simultaneously.
Okay, thank you for the answer. Next question. How will OTA or over-the-air work on this? Like if the protected app crashes, will the user app crash as well?
Yes, so I think OTA demo was covered in the talk itself, and that is definitely the case. If protected app crashes, then it will take the whole system down. However, if there is any crash in the user app side, then we can definitely handle it on the protected app side and can take the corrective measures. So the framework provides various configuration options to set the policy to monitor and handle the user app exceptions.
Okay, thank you. The next question. Can we prevent the user app from decrypting any program code to make it harder to dump firmware?
Yeah, so user code does not have access to the region that belongs to the protected application. So it would still be possible for the user app to read contents of its own application, but it won't be possible for the user app to read contents of other section of the flash.
Okay, thank you a lot. And last two questions for you guys. The one is about how much work is required for developers to support this?
So we already have a demo which uses a RainMaker example, and we have tried to fit the RainMaker example on top of a privilege separation framework to demonstrate how you should be doing it. It doesn't take much effort. We have documented this in our documentation. So if one follows that, it should be pretty straightforward to add support in the existing framework.
Okay, sounds good. So just like go to the demo, copy paste it, or start with that, and you are ready to go. Perfect. And the last question, can the protected core restart a user core?
The user does not have a dedicated core as such. It has a dedicated code and it executes on the same core. So the protected app can restart the user code, but there's no such thing as user core as of now. Maybe in the later on chips, maybe we can figure out.
Okay, perfect. Thank you a lot, guys. This was the last question. Is there anything else you would like to share, or you are good to go?
Yeah, so just would like to add, this framework is in beta phase, and we would definitely love to hear any feedback, and would recommend to try out examples that are provided in the framework.
Okay, that was a good point on the end, Mahaver. Thanks a lot, guys. Bye-bye.
Yes, thank you.
Thank you.
Yes,
bye.
Okay, so this Q&A is over, and we will now continue with the break again. The break was supposed to be 15 minutes, but we have some delay, so we will just make it only 10 minutes. So take the rest, guys, drink water, and see you in 10 minutes.
Ladies and gentlemen, girls and boys, welcome back to Espressif DevCon22. My name is Yanis and I'm your host today. After our second short break, I'm back for the afternoon session of the first day of Espressif DevCon22. Coming up next is Hrishikesh, the founder of Wokwi. Yuri's talk is entitled Your Browser is ESP32, as he will explain how Wokwi enables you to simulate your IoT and embedded system projects right in your web browser. He will explore many use cases and code examples such as ESP-IDF, Arduino, MicroPython, CircuitPython, and Rust, talking to MQTT servers, running an embedded HTTP server, interacting with various sensors and peripherals, and even dumping the network traffic at the packet level. The best part, you can try everything at home. Yes, even if you don't have any hardware. After this, Espressif's Ricardo Tafas and Silvia Alves from Brazil will talk about applications of asymmetric multiprocessing with ESP32 devices. This talk presents the asymmetric multiprocessing architecture adopted by ESP32 when this option was made available through Zephyr. Silvio and Ricardo will explore a few potential application scenarios, finishing off with an AMP demo on ESP32. At around 10 to 4, Espressif's David Termark from Brno will talk about IDF networking. More specifically, he will focus on the best practices in terms of handling interfaces, events, and disconnects. Additionally, David will present a simple example of network programming with protocol libraries, events, and asynchronous APIs. He will finish with tips on how to use various networking events to handle disconnects smoothly. Our afternoon session will close with a talk from two guest speakers. Gammell and Mike Szczys from Golioth will be looking at thousands of ESP32s all at the same time. In other words, they'll talk about device management for ESP-IDF-based devices. Recently, Golioth released an ESP-IDF SDK to make it even easier for users to hook into data services. In this talk, Chris and Mike will discuss challenges in creating IoT fleets, various concepts for getting data on and off different devices, and how they were able to quickly create an interface for ESP for Espressif users thanks to the concise design of ESP-IDF. Attend this talk if you'd like to learn how to hyperscale your device fleet and still understand what is happening on each and every device. But first, let's listen to Hrishikesh's talk about using ESP32 as your browser. Yuri, off you go with your presentation.
Hey everyone, and welcome to my talk in Espressif DevCon 2020 something. And today we are going to talk about something quite revolutionary, about taking your hardware, your beloved ESP32 dev board, and running it in simulation in the browser. So you can take your projects and prototype them without having the real hardware. Not only you can prototype without the real hardware, you can also easily share your hardware projects. And if you want to teach something using ESP32, then that's also like a great opportunity to conduct teaching sessions without having a lot of hardware and worrying about shipping and export and all that stuff. So let's talk about Wokwi. And first surprise for today, there are no slides. We are all going to see a lot of like demos, but there are going to be no slides. So I prepared a document. You can open this link later and see all the links with all the demos that I'm going to show today. And I think the first thing we are going to do, we are just going to get out of those slides because we don't need them anymore, and open the simulation homepage, wokwi.com. That's the simulator, and there are like a bunch of demos on the homepage, but I want to show you, usually when you show hardware demo, you start with Blink, but I think like Blink is overused, so we are going with to do something a bit more complicated. We will start a new ESP32 project. So this is like the Wokwi workspace. Let's make the font a bit bigger. Yeah, that's a hack to make the font bigger. So you can easily see the code, and we have like an ESP32 board and Arduino code that runs on this board, and as soon as I hit play, this code is compiled and you can see the result. But I promised something a bit more interesting than just hello world, so let's add this temperature sensor and start making the connections. I press G to get a nice grid, so it's easier to connect the stuff. And let's connect the VCC pin, the ground pin, and also the data pin for this DHT22. DHT is digital humidity temperature sensor. 22 is like the precision or something like that of the part number. So now we have got a sensor wired, and in order to talk with the sensor, we need to add a library. So we are going to use this DHT library for the ESP-X. And by the way, if you click on a part like this temperature sensor, there is this question mark, and when you click on it, you go to the documentation where you can find all the information about the pins of the parts, usage examples, how to initialize it, and you can even see there is like a note about the ESP32 that tells you that this is the recommended library. So if you want to use this DHT sensor with the ESP32, then use this library we just used. And now that we have this library in the project, we can include it. So let's include DHT ESP.h, and then we can define a constants for sensor pin. We connected it to pin D15 here, so that would be pin 15, and we can define an object of DHT ESP with the temperature. So we call it like temp sensor, and then we can initialize this by calling temp sensor dot setup with the pin, so that would be 15, and we also need to tell it like which kind of DHT sensor we had, the DHT22. And finally, we finished initializing everything. We can just move this line, and instead of printing hello ESP32, we can print hello and then add a temperature. So temp sensor dot get temperature and humidity. It also has like humidity info, and then we can just print the temperature. Let's add a new line so it's a little bit easier to see what we did here. And finally, we'll add a small delay so it doesn't flood our serial console. And let's see if our not blink, not hello world example worked well. So I'm going to hit play now. It's compiling the project. That usually takes a few seconds. And yeah, I needed to convert the temperature into a string. So let's do that, string with 2 decimal points. And let's compile it again. And whenever I hit play, this code is sent to a cloud service that compiles the code and then downloads the binary file, the compiled firmware into the browser for the simulation. And now we can see it's running, it's printing a low 24, and if I change the temperature to something super high, like 42.2 Celsius, you can see like it's printing the new temperature. So yeah, this is how you prototype with Wokwi. Just add components, install any libraries if you need, and write your code. We can even make it a bit more interesting by adding another like 7-segment display. So let's add a 7-segment display and connect the pins like we did before, ground and power. Where was that? Yeah, power. Let's connect it. Yeah, it tells us where to connect it. And then we have also this data pin. Let's connect it, I think, here. 12, doesn't really matter, we can define those pins in the code. And I have a small code snippet that includes, adds this display. So let's first install the library. There is another library for this part. It's called TM whatever tiny display, and we can paste the code. And this code is very similar to what we had before. It's instead of printing the temperature to the console, it just shows this temperature on the 7-segment display. So as I'm going to hit play, the code is compiled just like we had before. And once the compilation is finished, we hope to see we can now see the temperature printed on this 7-segment display module. So that's the idea. You add your components, connect them, you write the code, install any libraries that you may need. You can use this library manager or just this text file. And once you are happy with what you got, you click on save. And voila, you can see this, you have this link, and you can share this link. I will share it with you in the document, but you can share this link with whoever you want on the internet, and all they need to do is just to paste it into the browser, click play, and they can start tinkering with what you just created with this project. So that was a quick introduction to show you what we can do, but this is only the tip of the iceberg. Other than connecting sensors and interacting with them, I think the most the ESP32 is mostly famous because of its very useful feature, which is Wi-Fi, and you can use the Wi-Fi to create IoT projects. And I think the next thing we will see is, let's close the docs, is ESP32 plus Wi-Fi. So this is another piece of Arduino code that you can see here if you are familiar with NTP, that's the Network Time Protocol. You can see it's connected to this NTP org server, and it downloads the current date and time. And in this simulation, we are using a different display module, the LCD1602, using the Liquid Crystal library. And what this basically does, it just initializes the LCD, prints connecting to Wi-Fi, then it starts to connect to the virtual simulated Wi-Fi. And once we are connected, it will update the time and display it every 250 milliseconds in the loop. So print local time goes to, calls the get local time function, and then it prints the time on the LCD display. By the way, that's a cool thing of the LCD library. It has like a specific method, a specific version of println that can print time structures. So let's see this in action. And now we are running the simulation. It's connecting to the Wi-Fi. You can see it got an IP address from the virtual Wi-Fi server. And we have a connection error. So embarrassing. Let's try that again. I wonder why we have a connection error. Because it's a live demo, of course, then the NTP server is down or something like that. Yeah, let's try that one more time and see if we can figure this out. Yeah, it does. Oh, yeah, it worked third time. So not sure why it had twice connection errors, why the NTP server had not worked while doing the demo, but you can see that now it works, and we can see the current date and time on the LCD screen. And you probably wonder what's going on here. Like, is it really connecting from the web browser to the internet? How does that work? And we'll talk about that in a second. Let's see one more demo with IoT. This time, instead of like using the NTP protocol, we are going to use the HTTP protocol. And this is another example. You can see it connects to this server. That's a joke API that gives you a JSON joke whenever you connect to it. And then it does some parsing. It's using the Arduino JSON library. You can see here we are using Arduino JSON and this other library to control the display. And it prints the display, the joke on the display. So when we start it, you will see it says that it's connected to the Wi-Fi and prints the IP once it's connected, and then it will start printing jokes whenever we press this button. So let's see this in action. Let's hope that this time the internet will work well, so it's connected, and you can see a joke. Unfortunately, it's a bit long joke, so it's cut at the end. Let's get a new one so we can see the full joke. Can we get a new one, please? Yes, perfect. And yeah, you can see, oh yeah, kerning joke. If you are familiar with fonts, you will understand this. We messed up the kerning again, guys. So how does this work? How does this simulation connect to the internet? So I'm going to tell you what's going on behind the scenes. So behind the scenes, this is actually running a virtual access point, and the ESP32, the simulated ESP32 connects to that access point and sends Wi-Fi frames to this access point, and those Wi-Fi frames are then forwarded from your browser. This whole thing happens in your browser. They are forwarded from your browser into an IoT gateway that we run on Wokwi.com, which takes those and sends them to the internet, and then it gets the responses from let's say this joke API dev, and it sends it back to your browser as Wi-Fi frames. And we are going to see an example of it soon. But first, let me show you another cool feature of the simulator, because we have seen some Arduino examples, and we have seen like how to interact with the virtual Wi-Fi and connect to internet servers. But what we still haven't seen is that you can also do this with not only with Arduino, but also with other programming languages like MicroPython. So I think this is my favorite demo with MicroPython. Oh, sorry, this is not with MicroPython. This is my favorite, one of my favorite demos with MicroPython. It's simple, and it includes like a complete IoT project, as I would call it. It's again the ESP32 with the same sensor we have seen before, the DHT22 temperature sensor. And you can see the code now is written in Python. And when we start the simulation, the ESP32 will actually load MicroPython, the MicroPython firmware, and then it will use this MicroPython firmware that it loaded to run this code from the virtual flash on the ESP32. And this MicroPython code connects to an MQTT server, which we will see in a moment. And then when you are connected to the MQTT server, it sends the temperature data. You can see here, it is reading from the sensor, and whenever there is like a change, it sends it to the MQTT server. So before running it, let's just open the MQTT client. So that's like MQTT client for the web, and let's just fit the simulation into view. We can actually hide the code because we don't need it right now. We have looked over it. And now we are going to connect the MQTT client to the MQTT server and subscribe to, yeah, I said I won't need the code, but we do need it to subscribe to Wokwi weather. Yeah, that's the topic that the code uses. And we can see we are subscribed, and now we can start a simulation. And when it connects to the Wi-Fi, we should be able to see it. It sends a message. Let me make the font a little bigger. It sends a message to the MQTT server with the current humidity and temperature. And of course, if we change the parameters, we will get even more messages. So this is like the simulated ESP32 running this MicroPython code that connects to the MQTT server and sends messages. And I think this is a good opportunity to actually look into this implementation and see what happened behind the scenes when we send those MQTT messages. So I'm going to press F1, which opens the secret command menu, and then I'm going to download Wi-Fi package capture file. And this file will include all the Wi-Fi data that was exchanged between the ESP32 and the virtual access point during the simulation. And then if I open this file on my computer, I can actually see that there are all these, I don't know if I can easily, oh yeah, I can make the font larger. There are all these like Wi-Fi frames that were used. So those all probe request, response, authentication, association, all this part was just connecting to the Wi-Fi. And then we have like all this DHCP stuff, which is how the simulated ESP32 got its IP address and DNS configuration from the Wokwi IoT gateway. And once it connected, it actually sent a DNS query to look up the address, the IP address of the MQTT broker. And as soon as it got the address of the MQTT broker, it started like doing MQTT. We can right click and follow the TCP stream to see all the like MQTT data that it sent, like all those JSON that it sent. So this really shows you how the whole things work behind the scenes. It's in the packet level that is like the simulator is actually sending and receiving Wi-Fi frames, and those are then sent out of the browser into a proxy. And this actually lets you see all the implementation details of all like the Wi-Fi and the TCP/IP protocols, whatever simulation you are using. So if that was a bit too technical for you, that's okay. It's pretty advanced networking stuff. But for those of you who do have some experience with networking, I wanted to show you how this whole thing works behind the scenes. Just like this demo, we have another cool demo, which is, I will put the link, you can try it yourself. It's an ESP32 connected to a bunch of NeoPixels. And then you can use the same MQTT server to send it messages and change. You know what? We already have like the MQTT connection. So, or did they close it? I think they did. Let's do a real quick demo. So put this one to the right side, this one to the left side, connect, and then we can just publish a message. Let's do this demo. And publish to this demo topic, and as soon as I publish, you can see like the Python code here got the message and updated the colors. You can try another one just for the sake of it. So just another cool demo. This way it's the other way around. Instead of sending messages to the MQTT server, we are listening to MQTT messages and acting accordingly, updating the LEDs in this case. So that was another cool demo with MicroPython and MQTT. And I think the next thing I want to show is just, it's nothing very new or something you haven't like seen before in terms of what a simulator can do, but I just love this because this is something that a user did. It's an ESP32 control connected to 3 OLED displays. And what I love about this is that he used a very creative method of connecting the displays to the ESP32. He used 3 relays, so he could control each of the displays individually, even though they are all connected to the same I2C bus. So they are all connected to the same I2C port, those 2 pins. They all have the same address, but as soon as the simulation starts, you will be able to see that each of them is updated individually. And we are not going to go over this code because it's pretty long, but if you want, I will share the link so you can dive into it later and see how he uses like the relays to switch the I2C bus to different Adafruit displays and control them individually. What I do want to focus on next is showing you another cool, from my perspective at least, IoT demo, which is this one, the ESP32 IoT server. I said we won't have any blinks, but it's not exactly a blink, but it's pretty similar. So sorry if You expected to see no blinks, you will see one now. So this is a simulation of an HTTP server running on the ESP32, and it has one API endpoint called /toggle that toggles an LED. It gets like one of those two LED indices, the blue one or the green one, and toggles their state. You can check out the code later, but it's basically just toggling the state and doing digital write to update the state of the LED. And let's run it. And once it's running, we can open another web browser to connect to the HTTP server running in the simulation. So yeah, I got another web browser here and it connected. You can see this is like the web page that is sent by this small web server, a simple HTML file with 2 links for the LEDs. And as soon as I click on one of those, you can see like the HTTP server is getting and handling the request. So you can also use Wokwi to simulate servers, not only like client IoT applications, but also like projects that use HTTP server or other kinds of servers. And now we are going to blink the LED a few times, just as any proper hardware demo has blinking LEDs. Cool. And while talking about blinking, that reminded me, we have seen like some MicroPython demos, but there is something else that I want to show you, something that I love about MicroPython. And for that, let's just start a new MicroPython project and add an LED, and not the LED matrix, sorry about that, just a standard LED. Flip this LED with P key and set up the grid with G, and let's say connect it to D2 and to the ground. Okay, so that's an empty MicroPython project, and if we start it, it prints hello ESP32. The font is a bit smaller, so I will try to make it a little larger. It prints hello ESP32 and the program finishes, so we get to the MicroPython console. And what I like about this is that we can see how powerful MicroPython is. MicroPython has this machine module which allows you to talk directly with the hardware. So for instance, we can use the hardware registers that control the GPIO port for the ESP32 to control the LED. So another type of link. And we are going to do it, first of all, by running some magic values to some very spatial memory addresses. You don't really have to know about these memory addresses. Again, this is pretty advanced stuff, so if you don't know, it's totally fine. But this address sets pin number, writing to it sends a given pin to output. 4 hexa means pin number 2, that's bit number 2. And then if we write to a different address, this will actually set a pin to high, turning the LED on. And we can also write to another address, this one, to turn the LED off. And you can easily see how we could create a loop that would blink an LED, but I promise no blink program, so it won't be a blink today. That's one of the things I really love about MicroPython. It's simple on one hand, but when you need to get like raw access to the hardware, you can do it just like we did today. And since Wokwi actually simulates the entire ESP32's chip with all the instruction set and all the peripherals, or most of them, you can use this interface to actually learn about the internal peripherals and hardware of the ESP32. By the way, talking about the hardware, there is, in the Wokwi doc site, there is a nice guide for the ESP32. So if you go there, there is a table that shows you which peripherals are there and which are not. And we are adding new stuff all the time. So if you need something, I will show you soon how to create a feature request so you can get it. But you can see that we support the ESP32, ESP32S2 and C3, and there are a bunch of peripherals that are already working and you can use. So yeah, so that was just another piece of fun fact about the powerful features of MicroPython. And other than using Arduino and MicroPython, you can also use other runtimes. This is just an example of using the ESP-IDF directly. So it's a simple, or simple if you use the IDF. If you have never used the IDF before, it's not so simple. It's a code example that creates 3 tasks, red, blue, and green. Each task has a different LED that it controls, and there is like those parameters that tells the task which LED it controls and how fast to toggle it on and off. So you see we are like using different rate for each LED, so it's not going to be just the standard blink. I promise there won't be standard blink, but it's going to implement some sort of binary counter with the LEDs by running those 3 tasks in parallel. This is the implementation of the task. And again, I don't want to go into the specifics of the code because I realize that many of the people here are not very familiar with FreeRTOS and the IDF, so I don't want to confuse everybody, but you can see this is like what the code does. And the purpose of this demo was to show you that Wokwi can also run ESP-IDF code and not just Arduino and MicroPython. And there is even more. We have been working very closely with the Espressif Rust team to let you run Rust code on Wokwi. And there is wokwi.com/rust with a bunch of examples that we created. Let's take a look at this crispy click. It's a simple but nice one that I like. And let's increase the font size like we did before. And this crispy click, as you can see, is implemented in Rust. So this is the Rust language. If you haven't heard about it, there is a great talk from Scott Meben about running Rust on Espressif chips. So do watch it. And this has like a lot of code. We are not going to dive into it. I'm not Rust expert either. I couldn't write this code myself. Thanks for the nice people from Espressif Privilege, I think, provided this example. But I just wanted to show you that we are also like able to run other programming languages like Rust. So I will have the link, and you can also go to wokwi.com/rust and play with this later if you want, or if you are into Rust. There are also a lot of other interesting things you can do with Wokwi, so I will just show you some of the things we are working on right now to see if any of you is interested. You can jump on to our Discord community and help us prototype them. So this is one thing I'm extremely excited about. It lets you, our users, define your own custom chips or custom logic that goes, sensors or whatever that goes into the simulation. So this is one example created by one of our users. Let's see if, no, that user didn't write, he just used the template, so it has my name, but he didn't write his own name here. Oh, YiYing, yeah. So this is the user who created this. And we have a keypad in Wokwi, but YiYing needed something else for his project. He needed a keypad with an I2C based controller chip. So instead of having the code that scans the keypad run continuously on the ESP32, he had some chip in his project. I don't think he wrote here what the name of the chip was, but he had some board or breakout board in his project that scanned the keypad from him and exposed the information about which key was pressed over the I2C bus. And we didn't have this chip on Wokwi, and now we have, because that nice person, YiYing, wrote it as a custom chip. So custom chip is a new API we are working on that lets you define your own chips, and you define the pins in a JSON file, and then you define the behavior in a C file with the API that we provide. And the cool thing about it that as a user, you just use it as if it was a physical part, or an actual part, not a physical, simulated part built into Wokwi. You can see that it's using here a standard I2C keypad library that talks to this chip and gets the data from this chip. So if you press some key, it goes through the chip decodes this key, and then sends this key to the ESP32 over I2C. I think this is really powerful because now you are no longer limited to just the parts that we provide, but you can create your own parts. Another cool example is this user who implemented his own LM75A temperature sensor. I think this was Anderson Costa from Brazil who did this. And again, it's an I2C temperature sensor, and there is a JSON file that defines like these inputs and all the pins, and the C file that defines all the code. And if you are interested in that, let me know. There is new APIs coming to create custom displays. If you wanted to create an e-paper display or custom LCD display, you will be able to do it. APIs to interface with SPI, UART, I2C, all the common protocols. And I know you can ask for other stuff. That's why it's a prototype to get your feedback. So that's one cool thing that is happening with Wokwi. Another cool advanced use case that I'm working on right now is a command line version of Wokwi. Don't know if it's going to be public or not, but if you are interested, let me know. Let's do a quick demo. So this is the command line version of Wokwi. Let's make the font a bit larger. And I'm telling it to simulate the ESP32C3 to load these bin files into memory and run the simulation. And as soon as I hit enter, you can see this is the hello world example from the ESP-IDF running in the simulator in the command line. And there is another demo here where I run micro, not this, Wokwi ESP32 row input, and then there is the MicroPython firmware. So I'm going to load the MicroPython firmware and row input. That wasn't it. Just hold on. It's too new, so I still don't remember the syntax. It's probably input row. Yeah, right. Input row. So yeah, so this time it's going to, well, it's perhaps too new, so it's, oh yeah, it worked, yeah. So I got the MicroPython REPL on the simulated ESP32, but this time it's just bring the frequency of the CPU. This time this is running in the command line, and you can imagine how this can be useful running ESP32 project simulation in command line for continuous integration use cases or automated testing. So if you are interested in any of this, drop me a line on the Discord and let me know. And before we say goodbye, I wanted to show you just one more cool feature of the simulator, which is also useful for debugging. We had this demo we created with a DHT22 sensor, but what happens when things doesn't work? So for that we have this logic analyzer, and you can connect it to any pin in the simulation. For instance, in this case, we are going to connect the logic analyzer to the data pin of the DHT22. And the logic analyzer is going to record everything that is happening on this pin. So when we start a simulation, we can see the amount of data it recorded, and we can also see let's change the temperature to very hot. We can also see this activity LED blinks whenever there is activity. But the cool thing is when you stop the simulation, you can actually open the recording file. I'm using a desktop software called PulseView to view this file, and looking at it, I can see the signals and their exact timing to the microsecond, even nanosecond accuracy of the signals that went on the wire that I recorded. And actually, if I wanted, I could ask PulseView to just decode this data for me. So just by some configuration, we can see like Pulse View can decode these bits and show me the values that went over the wire. So this is super useful when something doesn't work, so you can see if there is activity on the wire, and if you are using the I2C protocol, for instance, you can see all the I2C messages and responses. I didn't want to show you that because that's usually a lot of data, and what I like about this DHT demo that is, it seems a lot of data when you look at the raw recording for the input pin, but then when you look at the decoder, it starts to make sense because there are just a few bytes of data, humidity, temperature, and checksum. So this is one of the tools that I use myself when I debug things that don't work on Wokwi. We do have like a way to submit bug reports, and the first thing I do when there is a bug report, I usually just take your project, hook a logic analyzer, and see if the pins are sending the data, any data, if they are sending the correct data, and that's how I debug. And one extra thing I wanted to show you is just something cool I discovered when I was working on Wokwi. So that's the ESP32. And apparently the ESP32 had some secret tiny basic interpreter buried into the boot ROM. And when you start a simulation here, this is just an Arduino code that jumps into the tiny basic inside the ESP32 boot ROM. I found the address by disassembling the boot ROM, and it calls this. So when we start the simulation, you can see this, just let's zoom in a bit. Yeah, you can see this basic interpreter. Now, I'm not very expert in basic, but I did learn a few commands. So if you type about, you can see some information. There is also help, print hello world, of course. And there is IO set. So IO set, let's set pin 4 to output, and IO dir, let's set the direction to output, and IO set it to high. And we can just play with this pin. So yeah, that's just something cool that I learned while working on the ESP32 simulator, that you had this hidden basic Easter egg in the boot ROM of this chip, and if you want you can play around with it. There are like for loops and all of that stuff if you want, if you are like into basic. I'm not so much, so you can check it out later. I'll include the link to this project as well. And before we say goodbye, Wokwi is already able to do a lot of things, but we keep getting requests and adding new stuff. And one of the things we are working on now is adding the new ESP32S3 chip, which is quite popular. It has some AI capabilities. As well, we have like this roadmap where you can see wokwi.com/features. You can see the next things we are going to work on. That's things that users suggested. So if you have a suggestion, you can just click here, open an issue on GitHub, and let us know what you need. You can see that the interactive debugger is on top. This is what we are working on right now to let you add breakpoints, step, watches, all those stuff inside the code editor across all the platforms. So ESP32, Extensa, RISC-V, and AVR and ARM that we also have on Wokwi. And if you love any of those features, like if you wanted to have I2S on the ESP32 or resistor divider simulation or a breadboard, which is apparently not popular, but not as much as I expected, you can buy vote powers and vote for it by clicking on this button. So this is where you can not only see what's coming next, but you can also affect on what's coming next. So that was a really quick overview of Wokwi and what it can do, and hopefully how you can use it for your projects, and some of the advanced capabilities like the custom chips, logic analyzer, the Wi-Fi packet dump, and the maybe upcoming CI integration. there is one demo I forgot to show, but it timed out. But it's a really cool thing that the Rust team has been doing. This is also like using Wokwi inside GitLab or GitHub workspaces in your cloud projects. If you want to hear more about that, just go to the Discord server. There is like the link on the homepage and chat with us. Maybe they will also show it in one of their talks. So do check out all the other talks in the conference. So I would love to get your feedback and learn how to make, how you find Wokwi and what you use Wokwi for. So feel free to join the Discord community and share your projects. And I hope that you enjoy this. Thank you.
Okay, so let's invite Ure to the live Q&A session. Hello, Ure. How's it going?
Hey, everything is perfect. I managed to change my shirt color while we were waiting for the Q&A session.
Yeah, I just need to text you in the chat because you were too fast answering all the questions, so there's no other questions for the live Q&A. So that's it. No, we still have some, so we'll just go through them. Basically, there were a bunch of questions about the support of different frameworks. So I think we can just pick some of them pretty quick and then move to some more, complex ones. So the first one is basically, is the tool exclusively for Arduino projects, or can we use ESP-IDF framework?
So yeah, you can use ESP-IDF either as I showed in the demo using the Arduino core, but just calling the ESP-IDF functions, FreeRTOS stuff. You can also load your own binary file that you compile locally, and that basically allows you to use any version of whatever framework that you want, as long as it can run on the physical chip. It should run on the simulator. And we are also considering adding some better support for building ESP-IDF projects on Wokwi. This is work in progress. It might happen at some point. Waiting for your feedback about it.
Okay, perfect. The second question, is it possible to use ESP RainMaker using Wokwi simulator?
Good question. I guess it is possible. I haven't tried, so if anyone wants to try it and report back, then I will have a better answer. But I see no reason why it won't work. So hopefully so. Okay,
so it's open to anyone to just try it, yeah? Kind of. Okay, perfect. The next one. Can we use the MicroPython to run script in ESP's in C or C++ project?
Well, this is not precisely Wokwi related question, but I know it might be possible to embed MicroPython into ESP-IDF projects. I know it's possible to embed it into the Zephyr project if you're using Zephyr project to write your firmware. So I guess there is a way.
Okay. The next question is about debugging. So is it possible to debug the code inside the Wokwi?
I love this question. The answer is right now it's possible, but it's pretty hard because there is a setup with GDB, and GDB itself is not very user-friendly. So as I showed, we are working on an integrated debugger with watches, breakpoints, variables, whatever you want. If you want to test it and give feedback, there is a GitHub issue on the top of the features page, and you can also come to Discord, and this is the right time to join and give feedback about the design of the debugger, because it's exactly now when we are building the user interface and starting to figure out how we should make the debugger and how to make it best for you, for the users.
Okay, one more question related to the frameworks. Did you try to run NupX on Wokwi? Is it possible? Is it supported?
So I haven't tried, but one of the users tried and it almost worked. There was like one thing we had to fix and now it works perfectly. And I think he's writing blogs about that. Miguel, that's his name, is writing blogs in Portuguese about how to get NATX, how to build it on your computer, create the bin file and load it to Wokwi. So if anyone is interested, I can look up the link later. Just ping me and I will send you the link. You also have to read Portuguese or use
Okay,
Google
perfect.
Translate.
So I have like 3 last questions for you. You already answered that it's possible to use ESP-IDF. There's one related. So it seems that it uses IDF out of the Arduino framework, what means that now it's tied to IDF 4.4.2 version. Is it right? Or can I tell Wokwi which IDF version should be used to build the application?
I guess in that case, if you need a specific IDF version, then build it locally and load the bin file. There is a way to tell it to use older Arduino core versions, obviously not newer ones because they weren't released yet, but it's not officially supported. So if you have like a need for a specific version, then right now the best bet is to build it on your computer. Down the road, we may have a Visual Studio Code plugin, so you will be able to build it on your computer and then automatically load it into Wokwi without like doing this F1 load firmware file and selecting the bin file, but we are not there yet.
Okay. One is more like a good feedback, but maybe you can expand this a bit more. So here it's like the recommendation to join the club and participate in Discord. Is there anything else you would like to add to that, or it's just like clearly written?
Just would like to say thank you very much, Fabio.
Perfect. And 2 last questions. The one is, what are the native file stores? So could I export in a file to Arduino for hardware testing?
So basically, if you want to export your projects, there is a way in the menu on the top, you can download a zip file with the INO file, all the libraries, or the other files that you have in your project, and also the diagram file, which describes all the connections. Or if you just wanted to test the very same build that you have on the simulator, you can press F1, download compiled hex file, and you get a hex file you can load to the Arduino, or if you are using ESP32, a bin file that you can burn into your ESP32. And coming soonish, I mean, we have a prototype, but we need to see how users react to this and how they need it. There is a way to use Wokwi to download firmware code directly into your microcontrollers using the web serial specification. So maybe, or if you want, there is a prototype that you can try, ping on Discord, I will share the details, to use Wokwi to program your physical ESP32 board.
Okay, perfect. And very last question, any peripherals that are yet to emulate it in the roadmap, or we can try firmware supporting all ESP32 features, for example, security under Wokwi?
So ESP32 is huge. It has a lot of features. Most people don't use, I think, even 10% of the features that the ESP32 has. The major features we don't support at the moment are Bluetooth. There is no support for I2S. Security like AES, Shah, and that kind of stuff is supported because it's required for HTTPS. And if you open the documentation of Wokwi and look for the ESP32 guide, there is a very big table with all like the peripherals of each chip, and it says whether it's supported, partially supported, or not supported at all. And then there is like the features page where you can vote for features, and you can ask for features that you are interested in and are not yet supported.
Okay, so this is a nice ending. I will just share this last comment. So if you like the Wokwi, you can also participate tomorrow on one of the talk called Just a Few Dots files in the repo, and there will be the demo built on the Wokwi. So thanks a lot, Ray, for joining us, and bye-bye.
Bye-bye. See you next DevCon.
See you. So now let's jump to the next meeting, not meeting, but the talk. And it's called Application of Asymmetric Multiprocessing on ESP32 Devices.
Hello everyone, my name is Ricardo. I'm software manager at Espressif. And today we're going to talk about AMP. So thank you everyone for joining this presentation. Today we're going to talk a little bit about our view and our solution regarding AMP. We'll check a little bit about how we implemented and some of the backgrounds surrounding this implementation. A little bit about the configuration, some applications we imagined for this solution, and a few demonstrations on where we stand on this technology. So before we start, AMP, as we expect everyone to know, is asymmetric multiprocessing, which it happens when we have two CPU cores and two different CPU cores, or same core that work in a different way. So for example, on ESP32, we have the same core, but they behave a little bit differently on the way we understand and we have these cores. So we can consider that as asymmetric multiprocessing. So which devices we develop these solutions for? Of course, we must have multi-core. So it's for ESP32, ESP32S3, which is not developed yet, but it's on our roadmap. And we can count on future ESP32 devices that consists of multi-core. We're not talking about the low power cores here. We're just talking about the full power cores. So for example, the ESP32S2, the RISC-V contained on it, it was not addressed by this type of solution. So now diving a little bit into details, we based our solution on Zephyr. One of the reasons is because we needed to extract all the power from ESP32 devices, and we have some limitations on Zephyr regarding the networking. And also that Zephyr has a very advanced support for Open AMP, which is a nice solution to have the communication between asymmetric cores. Also, how do we bring up this application? How can this multi-core solution start? So we have one. The first option is the Zephyr app bring up. This happens when Zephyr starts the second core. And we also have when the application is started up by MCU boot directly from the bootloader. So the flow for the Zephyr bring up is that on ESP32 devices, we have the ROM bootloader. After the ROM bootloader, instead of the regular or widely known IDF boot, we use the MCU boot. MCU boot then loads Zephyr. Zephyr running on core 0, then starts up another Zephyr instance, for example, or another firmware on core 1, and it resumes its operation on core 0. When we have MCU boot to do the bring up, we have as the same, the ROM bootloader. After the ROM bootloader, we start MCU boot, and MCU boot then starts directly both the Zephyr image on core 0 and the Zephyr image on core 1. MCU boot, on all cases, is always running on core 0 before it starts the second image on core 1. So the targets that we have for the communication between the asymmetric cores is the IPM, the standard libraries on Zephyr, Open AMP, using the Zephyr port for libmetal, or users can use all the resources they want to exchange resources, and we have then mutexes, mailboxes, and all of that. Just as a note, this is all still a work in progress from Espressif. The push requests have just recently been merged. So the configurations for these systems on which image is going to be used on each core. So the first regular use is 2 custom Zephyr images, where users can run their custom Zephyr with their custom firmware on one core, and another custom Zephyr with another custom firmware on the other core. They can or cannot have a communication between them. That's up to the application. Second, if user doesn't want the networking interfering with their own firmware, they can use Zephyr and use another core just as a network accelerator, which is kind of an on-chip offloaded networking solution. Also, users can eventually decide to run Zephyr plus image containing with a Rust image or a bare metal image. So they can have all the features from a full-fledged RTOS plus all the detailed and close to the closest they can get to the hardware with a bare metal solution. And finally, users can also have one Zephyr image and whatever factory-defined firmware they want to run, doing whatever specific task they want. It could be some sort of cryptographic library, it can be some sort of software accelerator they can have on the second core. So the second core ends up being a software-defined custom peripheral. So on these scenarios, there are several possible applications. So the first application is an offloaded solution, just like I mentioned on the configuration, where we have one Zephyr image running a custom built Zephyr, and a second image running a networking tuned specific Zephyr image. So when the system boots, in this case, it should be noted that Zephyr is going to run the second image. So Zephyr starts, then the network driver, for example, starts up the second core. On the second core runs a second Zephyr image. One question that could arise is where the second image could be located in such situation. Well, it could be on the file system. It could be bundled with the firmware built. It could be whenever location that Zephyr has access to. So which kind of applications is this scenario used for? General purpose, or in those solutions that need to reduce the number of chips. So let's say, for example, the user already have a solution that has an offloaded Wi-Fi solution plus another CPU, and then can bundle those 2 chips and replace them with just one ESP32. The second scenario is for sensitive data computation. So users may have a connected core, a connected firmware on one of the cores, in this case on core 1, and they may have some security or sensitive data being computed on core 1. So in this case, it's favorable that they use MCU boot load, so the unsecure core won't have any kind of privilege over the secure system, and eventually they can have or may not have, depending on the application, communication between the cores. In this case, of course, more configuration besides just firing up the images have to be made to make sure that the secure software runs safely from the unsecure software or exposed software. On these scenarios, the application is point of sales, banking, imaging, and identification. Several countries have hard regulations regarding user data protection. So, for example, devices running ID, they eventually can count on this kind of application to make sure that the current and local user data don't risk being transmitted over the internet. The third scenario, when user wants to isolate an IoT service provider from their custom product routines. So, for example, one user, they have some form of connectivity from a cloud provider, for example, AWS or Azure, or even Espressif's RainMaker. So they can be using the cloud provider firmware on one core and have it completely separated from their application. On this case, users may or may not use the MCU bootload, because eventually they would want to fire up the connectivity software only when needed and only when wanted. So they may have reduced the power consumption, for example, to keep one core shut off, and while still not running any kind of cloud firmware. Eventually, they can also figure that for security reasons, they just want to communicate on particular windows. So they want to shut the cloud software that come off the shelf from the cloud provider. The application for this scenario is when, on typical uses for ESP32, along with an IoT cloud provider, when the user doesn't want to mix or integrate their firmware or create another build to integrate connected or the cloud provider application into their own application. Or this could be used when user wants to turn on and off for whatever reason, maybe for safety reasons, maybe for power concerns, the connected firmware. It, of course, can be used on all kinds of connected products to well-known clouds. The fourth scenario, when the cloud provider, instead of the user, wants to offer a connected off-the-shelf solution that won't require any sort of compiling and building. And eventually, in this case, users can upload their firmware through the cloud provider network. So in this case, we can have the Zephyr cloud provider to start the user custom image, where it actually makes the user product. And eventually, they can communicate and exchange information through OpenAMP or another protocol. This is very useful for solutions that are connected off the shelf. And users may or may not want to handle their firmware to the provider. So eventually they would like to have just receive the binaries from the cloud provider and just use the building tools so they can generate the image, and MCU boot starts up all both cores. So in this case, or even on the other case, the application is that cloud providers, they can provide a pre-built image that won't change, that will be guaranteed to be connected, provided that the user won't be changing or dealing or building the provided custom firmware, the provided firmware. They can only just start up with no, actually it can even start up with no actual application as long as it connects to the network. It downloads the user application directly from the internet. It's also useful for OEM manufacturers. So the device ships out with zero programming, but zero programming on the sense of a product like programming, but it can get connected to the internet and eventually download the custom firmware. So product identifies itself and downloads the proper firmware from the OEM manufacturer site or the user's website. Scenario 5, which is a scenario that was brought up due to the crisis of the semiconductor industry. With the lack of chips, several products were not manufactured properly, or they had to wait in line for complete manufacturing. And these devices, mostly when IoT and when connected, they have one critical core running critical software, or at least robust software intended to protect the user safety, the end user safety, and another core to provide the connectivity to the network. Due to the demands and lack of available devices, ESP32 can be used with an IMP solution to both have connectivity and a robust software that won't depend or won't be connected to the internet. So in this case, the user had the critical firmware on Core 0 and all connected software on Core 1, and critical routines or robust routines on Core 0. In this scenario, users won't have the interference from all networking on the critical routines, and they can provide a safer application for their users. Critical certification always depends on the device manufacturer, and this is still a work in progress and still under study on Espressif. So we're not there yet, but at least we're building the basics and the images and all the necessary tools for this solution. Applications for this scenario: home appliances, control systems that need to be the fastest they can, industrial applications, and automotive. Okay, so this is currently our solution on AMP. It's still work in progress on Espressif. It's not more than less than 2 months, less than 1 month actually, that it was merged upstream on Zephyr. So currently, this is an intended software product. It's still in earlier than alpha stage. It's still a proof of concept, to which we are discussing some applications. What comes next? If it's a software product, it's intended for people to use it. So what's come next is tooling. So we have to provide the tools for people to use it. The current state of this implementation is that there is a lot of handcrafted commands and configurations that have to be set for one to be able to build an AMP solution. It's already there, but it's far from, it's going to take a lot of time just to set up the environment, then actually building the application itself. Second to that, if it's something that people can have the tools to use, documentation. And finally, better than documentation, the examples. I would like to thank everyone for joining me on this presentation. Silvio, my colleague, will now present some demonstrations about these solutions that we brought up and that we are working on. Thank you all for joining me, and have a nice demonstration.
Hello, my name is Silvio. I'm a software engineer at Espressif, and today I'm gonna continue Tafa's presentation regarding AMP. And the idea here is to share with you 3 different sample codes related to AMP and IPM. So let's start. We can see here 4 folders, but it is in fact 3 samples. It's the IPM, MCU boot, and Rust. So the idea is I'm gonna show you the 3 and then flashing on the board and see the results. So the first sample is the IPM. So this is a project that's already upstreamed in Zephyrs. And what we have here, it's a project within a project. So we can see here the source file of this IPM project, okay? And it's loading here. And it basically gets the IPM instance of the ESP32, right? It registers a callback, and it starts the IPM, and then it just keep like, it sends a request, and then wait for the other core to reply. So this sample code is going to run on the Pro CPU of the ESP32. And there's another code in here that we call IPM ESP32 net. This one runs on the app core. And it's basically the same idea. So we have here the main call, and it just get the IPM instance registers the callback, enables it, and then just sends a reply to the ProCPU request. Here is the callback, so it just releases the semaphore, so the message like keep going back and forth. Okay, so first of all, I'm going to build the net sample code. I have a ESP32 board attached to my USB port. So now it's been completed, and then I just need to build the ESP32, the main project in here. So I'm running West build for the ESP32. Now that the build is completed, I'm going to flash and open the monitor to analyze the output. So I'm gonna pause the simulation. It's running. I'm gonna pause it. So what we see here is that we have the ProCPU sending a fake request and waiting response from the app CPU. Once you get the response from the app CPU, it prints the message from the app CPU. This is a response. So this is the basic sample code that we can flash. We can use both cores independently of each other, either talking to each other or not. So we can understand the MP approach. Now that we completed this IPM sample, I can do the same thing using the MCU boot. So we need to build the MCU bootloader for the ESP32, and then we need to flash both images on each slot to each other, and then MCU boot is going to perform the proper handling to run both applications. So first thing I have to do is I'm gonna change the shell here. So currently I'm on the MCU boot upstream repository. So I'm gonna build the MCU bootloader image for ESP32. We can find this how-to on upstream README file. And now I can flash it. So it's been flashed. So ESP32 board already has the MCU bootloader. Now I'm going to switch to this project in here, MCU boot project. It's similar to the first one. So what we have here is the same source code. It's the same IPM sending communication to each other core. But now we're going to flash it using the MCU boot. So first thing I have to do is I'm going to build the ESP32 net. And I'm going to add some overlay to enable the MCU boot. So this is building the application. That's the net one. And we're going to flash it without starting the project. So it's going to flash it. Now we are going to build the other project. That's the ESP32, this one here. We're going to build it. And we're going to use its custom overlay to enable MCU boot as well. So now that both images have been flashed, we can start it. Now we're going to flash. So I'm flashing this last image, and then we're going to open the monitor so we can take a look at the output. Okay, so I'm going to pause it. What we see here is the MCU boot banner. So it's loaded properly. And then we can see here that both images were loaded. So we have here loading image 1 and loading image 0. So we have the ProCPU running and also the app CPU running. And the behavior is the same as the first sample code. So we have the ProCPU sending a fake request. and we have the app CPU response as well. So we just, in this sample code, we just performed the same approach of the first sample, but using MCU boot. And finally, there is another approach that it's a draft, but it's something that we can allow on the AMP environment. I'm going to show you how to run Rust in the app CPU. So we're gonna run on the Pro CPU Zephyr's application and on the app CPU Rust application. So first of all, we have here the ESP hall. This is Rust repository, and I'm going to open the sample code for the Hello World. Hello World is open here. This is a basic Rust sample code. So we have the main entry in here, and you just get the instance initialization of peripherals, clocks, timer. We disable the watchdog, and then we start the timer to toggle every 1 second. So during this time, it just prints app CPU hello world from Rust. So I'm gonna build this project using the cargo build example hello world. And this is completed. Now we have some procedures to take care of. So I'm gonna use ESP2 so we can convert the ELF file generated from the build in binary file. And this is going to copy this rust.bin to the Rust folder. So I'm going to delete this, and I'm going to run ESP2 to generate this file again. Yeah, so rust.bin is here. And the next step is we still have to convert this binary file into an array file. So I'm gonna run a Python script that we can convert this binary file into this array in C. So I'm just gonna delete this one, ESP32 net firmware. And then I'm gonna run the Python script it's in here. The Python script to convert the rust.bin into the source file. So once we do this, it creates the array here. And Zephyr main project is going to loop every second, printing Pro CPU hello from Zephyr. And as I showed before, Rust is going to run and display hello world from Rust. So now I just have to build the project using West build for ESP32. And now I just have to flash it and open the monitor to take a look at the output. We have some garbage here. It's something that has been worked out, but we can see here, I'm gonna stop it. And we can see here, again, Pro CPU sending hello from Zephyr, and also app CPU sending hello from Rust. So in these sample codes, there's no IPM running. They are just printing some content from each core. But this it's a sample code that we can use to evaluate next steps regarding AMP support using other platforms like Rust or bare metal. And that's all I got for today. Thank you very much.
Okay, well, let's invite our two speakers for the Q&A. So Ricardo and
Hello, everyone.
Silvio.
Hello, folks.
Okay, so you are both here, so we can start. I have sorted 3 questions, and so we can start with those. The first one is the power in the sense of the computing power. If this is possible, how it works?
I think it's related to the presentation of Ricardo about MP and ESP32 computing power, right?
Yes. The point is that we figured when we were supporting ESP32 that Zephyr network has a limitation, that when we enabled symmetric multiprocessing, the network got disabled. And we figured that, well, we have 2 cores. It's not, how can I put that? Well, we can't just let 1 core sit there and doing nothing. So we figured, well, which alternatives do we have without having to rewrite the whole network stack? And actually, there were some requests, as I pointed, from people requesting, oh, how can we get robust software, or how can I split from the all the networking part, the application? And we figured that the AMP could be a very good solution for that, and actually solves our lack of support for the 2nd core when having the network enabled. So by the end of the day, several smaller things got together, and we decided that we can harness the computing power of ESP32 without losing functionality, and even actually gaining new types of applications. So that's, yes, it's related to computing power. When I say power, it's not energy consuming, because when you have more cores, actually you're going to consume more power.
Okay, perfect. It was a nice answer. I will just gladly ask you, Ricardo, can you please speak a bit louder? Like your mic is okay, but it's a bit quiet. So let's move to the second question. And is there some sort of way to communicate firmware applications? For instance, Core 0 runs Zephyr app and Core 1 runs Rust app. What would be the best way to have messages exchange between the apps?
Yeah, so when it comes to Zephyr, we implemented a soft IPM. IPM is the interprocess messaging. So in Zephyr, we have the IPM that is the interface responsible for exchanging message between both cores. So this IPM interface has 4 channels. Channel 1 is for the Wi-Fi packets, channel 2 is for the Bluetooth packets, and channel 3 and 4 are for application custom packets. So each channel supports 64 bytes. So it's up to the application to handle larger packets, but this is the way we do the communication between the cores. And of course, if you want to use some bare metal application or Rust application using this IPM, we have to implement the same feature on the environment as well, like Rust bare metal.
Okay, sounds good. The next question is about the demo. So what board are you using, or did you use for the demo, Sylvia?
Yeah, we have been using only ESP32 for now.
Okay. Perfect. I will ask Ricardo, what are the current updates and the future plans?
Future plans, it's of course related to Zephyr as well. So future plans is enabling ESP32 S3 on Zephyr, so we can have this solution for more cores, not only for more SoCs, not only ESP32. Also, as I mentioned on the presentation, we do need more, make it more user-friendly. As you see, Silvio had to do a lot of commands to make it work. We want to have something more like ESP-IDF, single command line like, or at least fewer commands, fewer things to set up before having to build this. So basically, it's support new SoCs, better tools, and Rodrigo just commented that he would love to see more one particular examples. As I said, examples are going to be one thing that we're going to work on. I think that if you have good examples, sometimes you don't even need documentation, because just see how it's done and just get it done on your own application. So that's where we're going to put our effort. Besides, of course, this is all work in progress. We will find bugs, we will fix bugs, people will come with suggestions. So there is all the regular software development part, but other than that, tools, documentation, examples.
Okay, there is one more question. Is there any mid-long-term support planned for XL6, XL7? This is very important for me, so I would like to know.
Okay. In Espressif in general, there is a I think that we have some TOC1 or CO some comments about that. We don't plan to left this, so you go can just see what his comments are in that sense. But regarding Zephyr, we have plans to keep supporting ESP32, ESP32S2, and ESP32S3 along with newer devices. So there is no plan to drop support anytime for these chips. They are XL6 and XL7. So for Zephyr, okay, we're supporting the chips that are going to come. Company-wise, I think then maybe asking our CEO and eventually on the next presentation from the higher management, where we're going, it's going to be, you're going to get a more precise answer. Besides that, as I commented, there's TOC1's comments about this around the internet. You can Google and look for that.
Okay, that's good. So maybe we can save these questions for the general Q&A for some of our managers.
Definitely.
And the last question for you guys, when will be expert ADC support on Zephyr?
Yeah, it's on its way. We
have been
working on this. We have been working on this, so in a few days or eventually weeks, it's going to be upstreamed.
Okay, it sounds promising. So I think if you don't have anything else to be shared, guys, that's it. Thanks you a lot for participating, and see you. Bye-bye.
Thank you, everyone.
Bye, folks. Thanks.
Bye.
Okay, the next talk will be the IDF networking.
Hello everyone, and welcome to my talk about IDF networking. My name is David Čermák, and I'm going to present a talk about best practices in handling interfaces, events, and disconnect in IDF networking. So I will talk about networking layers in IDF. I will describe what we have in IDF around the TCP/IP stack, and how we can use it, how we can configure that. Then I will give some examples about applications, like different various settings of the event handling from different layers. And at the end, I will conclude with tips and actions that we recommend how users could set up and configure IDF networking, and how disconnects and different errors could be handled. Before we start, let's talk about the motivation for this talk, because networking in IDF is probably the first thing that everyone would use, and we have plentiful of examples of using networking for various components, various networking libraries. One example is here the MQTT over TLS. We have an example for that. Everyone can start it, everyone can run it, and it works, it publishes. So that should be no problem. But yeah, the problems that users could encounter with this specific example and with other networking applications is that we could get disconnected from the Wi-Fi, from the network, or from the MQTT broker. We could see that the endpoint is not available. In our case, the MQTT broker is offline. We could even suffer from out-of-order delivery of different events from Wi-Fi and IP layer. So we could get a disconnection from Wi-Fi and at the same time connection to IP, so getting the valid IP address. and that's due to the asynchronicity of the things of the network and events and different layers. We also know that TCP is not real time, but sometimes we forget, and we forget that TCP takes care of resending data, retrying, backing off. So sometimes takes some time until an endpoint is considered disconnected. About the networking layers in IDF, so we all know that the TCP IP stack that we use in IDF is LWIP, so the most common TCP IP stack that is used in other embedded platforms too. LWIP is also called lightweight IP, and around this TCP IP stack we have several layers which are IDF specific, so drivers for Wi-Fi, Ethernet, PPPoS, that is clear. We have this component called ESP-IDF. I will talk about it in more details later. It is used to connect or couple this TCP IP stack to drivers and to take care of initialization and sending and posting events. I would also like to mention this VFS or socket layer because we not only support networking sockets, but we could also VFS stands for virtual file system. So some other file system sockets, some other file system descriptors that could be used to interact with networking sockets. About the layers, we already said that we have drivers here. We have the TCP IP stack here, which in itself has some modules like network interface, row API, some applications, socket API, and up here we have the application libraries. So we already talked about MQTT. We have others, HTTP, WebSocket, ASIO, and many others are available. Around the TCP IP stack from both sides, you can see this ESP-IDF. So the ESP-IDF layer here takes care of routing the network interfaces to drivers, and here it actually looks at some applications like DHCP servers, DHCP client, DNS, and talks to IDF system to actually keep it updated and actual. Also, I already talked about VFS, virtual file system. So the socket API that we use from application libraries are not LWIP sockets, but there is a thin layer that helps us working with other sockets than networking sockets. So what is really specific to IDF platform? How is it different from other networking programming? So to answer that, we will have to look at what the application that we are talking about, what it really does. So the common use cases is that we use socket layer programming, or we could use some generic network library that's available for many other platforms, including host platforms, Linux, Windows, and it's also available for Espressif chips. Or we could have like IDF component directly. So this is probably the most common use case that our customers do. ESP, MQTT, WebSocket client, and others. It is also possible to use LWIP row API, which is not recommended and it is not very scalable, but it is still possible. As for the environment and complexity, we have to think about how responsive our application would be if it's really something very conservative, an application which really relies on TCP layer to reconnect, retry, and make the connection stable again, or if we want something more real-time, or usually what it is something in between. So what our users typically want, they still want TCP, but they want the TCP that's somehow responsive, that the application is somehow alive, that if something is not available, we just bail out after a couple of seconds, not after minutes or hours. As for the complexity in terms of network interfaces, the most typical use case is that we have one single network interface, usually Wi-Fi station, and we just use that interface only. We could have multiple network interfaces with or without an interaction between them. The typical use case here is that we have Wi-Fi, at the same time we have an Ethernet connection, and at the same time we have a cellular network connection. And all these interfaces have different priorities. So if we have all of them up and running, we usually use Ethernet, preferably use Ethernet or Wi-Fi. If Wi-Fi is down and Ethernet is down, then we go with the cellular network connection over PPP or PPP over serial. So now, how the IDF platform is different. So we need to be aware of that, of the fact that it's a really embedded target and we have limited resources. So number of sockets, buffer sizes, memory, performance. We are in embedded space, so network programming in IDF. We have to be aware of this fact. Then number one is events. In IDF we have this event, this component called ESP event. So for networking we could receive events from different layers, from driver, from link layer, from LWIP, from ESP-IDF. Second point, interfaces. Already said that we have this ESP-IDF component that is used to as a wrapper around network interfaces, and I will talk about it later with a lot of examples. And also the last point is the networking API, which usually and preferably is a socket API or some network library which uses socket API behind the scenes. But at this point, we have to be aware of the fact that these are not standard sockets, these are LWIP sockets. So there are some subtle differences between classic, like common Unix or Linux or Windows sockets and LWIP sockets. So let's jump to the first example and look at the events. So in the motivation slide, I talked about this MQTT over TLS example, and if what happens if we get disconnected from Ethernet. So let's run this example. I already flashed the board, so let's just run the monitor. As you can see, this is the standard Ethernet kit, and it connects to the network and keeps publishing. Now, if I remove the Ethernet cable, we should get a disconnection. So as you can see, Ethernet link is down here, and after some time we could probably get a lost IP event. Yes, when I reconnect, we could get a link up event here, and after some time we get an IP address and got reconnected to to the MQT broker again, and then after a connection, as you can see, it tried to catch up with publishes and try to publish more frequently. So let's look at the code, what it does. As I said, this is the most default MQTT example that we have in IDF, but I have added this while loop, and I have also added the event handler registration. By default, we look at Ethernet events. I think this is also part of the IDF example. So look at the Ethernet events and look at all of them. We saw that the Ethernet link was down and was up. So that part worked okay. As for the IP events, and this IP layer, this comes from ESP-NetIF. So we typically also look at this GATT IP. And again, this listening to this event is also in the default example. But what I have added, I have also added this lost IP event. So from both driver level, from the Ethernet, we get both events disconnect and connect, and from IP level we get both symmetrical events, GATT IP and lost IP, as we could see here. So link up, link down. Link up was here after we reconnected. Yes, here, and we got lost IP here, and another got IP here with the IP address. And I have also, as I said, I have added this this publishing mechanism, this never-ending loop that keeps indefinitely publishing some data just for the purpose of the demonstration. So let's jump back to the presentation, what we had, and come up with some recommendations. So it's always good to listen to events from drivers. Here we had events from the Ethernet, so we had both events from connection and disconnection, the Ethernet driver. But we could also listen for all of the IP level events, so not only GATT IP but also lost IP. You might have noticed that the lost IP event came a couple of seconds after we got disconnected. This is why there is a lost IP timer in ESP-NetIF, and it's configurable. I have set it to 10 seconds for this example, just to demonstrate how it works. But by default, it is set to 2 minutes. And of course, we have to watch for events from the networking library itself. And if you remember, we got disconnection events and error events from the MQTT library as well. But this is really specific to the networking library that we use. So the questions that we have to ask is, does it make sense to keep sending and receiving if we are disconnected? So in other words, do we have to publish even if we are disconnected from the link layer? And does it make sense to keep trying to reconnect to MQTT even if the link layer is down? This is how the MQTT library works by default, because it has no knowledge about events from drivers. So even if the Ethernet driver is disconnected or the link is down, it always tries to reconnect, it fails, and then after some time it tries again. So usually the answers to these two questions are no, and this is basically the like our common recommendation that if there is no real intention for that, just publish or send or work with the network library only if the link layer is okay, if we are connected. And if we don't have to, if it's not too much trouble, we don't have to reconnect if the link layer is down. So what other tips we have? So we could use some keep alive mechanism. MQTT protocol itself has it, and the library in itself does that as well. So this is very useful. If we use some protocol that doesn't have it, TCP itself has a keep alive mechanism, so this could be easily set up and configured using socket options. So let's go to the next example. The next example will be about interfaces. So we'll be mainly talking about ESP NetIF and about like 2 interfaces that I have created just for the purpose of this demonstration, and how we are able to actually route packets or choose the preferred path the packets would go. So the default network interface, the default gateway. So let's jump again to the command prompt, and yeah, for this I wouldn't use Ethernet kit, but just very basic W room kit, so dev kit C. Again, it's pre-configured, and it has no connection, no external Ethernet, nothing. So it uses just Wi-Fi, nothing else. But let's take a look at this example. So as you can see, we got 2 IP addresses from 2 different ranges. So from this interface, which is the station, which is the default one, it connects to our network in the office, to our Espressif network. So it got this IP address, but it also got another IP address from this range, 192.168.3, and the name of the interface is called Wi-Fi access point with DHCP client. And then after it got these 2 IP addresses on these 2 interfaces, it then there is HTTP GET performed for some address. I will show you quickly the code. So let's see what we have here. So this is the again modified soft access point example, again from IDF. So this is what I have just mentioned. So this is the URL. We are trying to connect or perform a get HTTP operation on http bin.org, and we do it periodically, every 5 seconds. And I've already said that we have 2 interfaces. So let's look at how these 2 interfaces are being initialized. We already mentioned that we have this board has only Wi-Fi, and this Wi-Fi is enabled and started in this mode access point plus station. But this is the Wi-Fi. This is the driver level. What about network interfaces? We run the Wi-Fi in access point plus Wi-Fi, but we'll have to initialize 2 interfaces, one for station and one for access point. As you can see, we initialize or we create the default Wi-Fi we are using the default API to create that, but the default Wi-Fi access point is commented out. So we have the default station, but as for the access point, it's not default. And let's see how is it created. So we create the ESP NetIF Wi-Fi for Wi-Fi access point. That's the same as the thing that we would have done with this create default Wi-Fi, but with this configuration. And again, this configuration is something what matters. So this configuration, and again, this line is commented out, so it does not create this default Wi-Fi access point, but it creates the default Wi-Fi station. So that's the most interesting part, because we are actually initializing the access point with the configuration, which is almost the same as the configuration for station. So we have a station or an interface, network interface that behaves like a Wi-Fi station, but it runs on a Wi-Fi access point. One important thing that I will mention in the comments is that if we are configuring the interface key, this has to be a unique string, unique name. So we wouldn't just create it. It wouldn't work if we just leave it as it. We have to update the interface key. We could also update the interface description. It doesn't matter, but it's nice to call it what it really is. In this case, this is the Wi-Fi access point with the HCP client. And one important thing is the routing priority, which we set to 101. So let's look at what is the definition of the default Wi-Fi station and what is their routing priority. So it's 100. So this is this priority is higher. So the access point, this access point that we create has higher routing priority. So all the traffic that goes outside of our network should go via this access point. So let's look again what we have. So we created this access point that got this IP address, and we are calling HTTP GET to some address which is somewhere in the internet. So we need to connect to the internet, but not via station, not via our Espressif network with this. We need to connect to Wi-Fi access point. So how does it work? Because this interface has more priority. Let's start it again so that we have some we see what's going on, what's happening. So again, we got these two IP addresses, and we are getting these HTTP events. Now I have another board here, and this one is an Ethernet kit, and this Ethernet kit is the counterpart to this access point. So on this board, I actually run a Wi-Fi station that has the HCP server. So this board actually takes care of assigning this access point, this address. And at the same time, you can see that this is Ethernet kit. So and it has IP routing enabled. So it passes this data from the Wi-Fi station, which provides the address to this board which we have, and pass it to the Ethernet interface. So in this case, we are actually able to connect to internet. If I remove if I remove the Ethernet cable here, we should get a disconnection failure. Hopefully, after some time, yeah, we get it here. So failed to create a new connection. So now the default routing is still over the access point, but we have no means to connect to the internet in that way. Now, if I remove or replace this board completely and attach a default station, that's the basic default station that we have. Let's look what's happening. So this station actually joined the network, and now it started working. Why? Because it has no connection to Ethernet either. So it's just a stupid default Wi-Fi station which has no connectivity whatsoever. The reason for that is very simple. Because this routing priority is higher, since it's higher, it routes traffic only if both of these interfaces are up. But I have a condition here down below that if the IP address is a 0, we just set the link down to this access point, so the traffic could easily go to the default station mode. So again to the internet. So in this way, in this case, if we remove the connection, but at the same time we got the interface down, then we are still able to connect via the second interface. So let's jump back to the presentation and see what information we have learned about ESP-NetIF or about the wrapper to network interfaces. So we actually suggest or recommend to use default settings, default configuration wherever it is possible. If we want to have multiple instances of the same config, just be aware that we need to update this interface key. This is the unique name of the interface, and we are not allowed to add two interfaces with the same interface key. This point is very useful for Ethernet interfaces because we can have as many Ethernet interfaces as we like, because we could add Ethernets, SPI Ethernets together with one internal Ethernet for ESP32 only, for other devices, SPI Ethernet, and we can reuse the configuration for the default Ethernet, but we need to update the name or the key of the ESP-NetIF. So when we use the default config, we need to update something. We typically should update this inherent configuration, because the configuration of ESP-NetIF is really complex. There is a driver-specific configuration and network stack related configuration, but this part is really for expert users. What users typically update is just this basic inherent default configuration, and then we update some specific items. And the most common fields to update are this IP info. So and this is very useful for access point or for those interfaces that run the HCP server, because here we can easily define ranges. I already said that interface key needs to be unique, needs to update that, and routing priority. So we need to set up the rules which interface would be the default if all of them are active, up and running. So we can look at the ESP-NetIF as a toolbox, so some set of building blocks that we could construct different networking interfaces in different manner using some default configuration and updating just some parts. So this is about interfaces, and the last point I wanted to mention is about socket API or API in general, and which is basically the recommended one is the socket. So here I am going to run an TCP client example, and I'm going to talk about connection, timeout with connection, because LWIP sockets, this is again one of the differences. For example, with Linux sockets, we for the blocking sockets we don't or LWIP does not support any timeout for the blocking sockets. So, but there are ways to make the connection fail after some timeout. And I would like also to demonstrate something about this custom event file descriptor to unblock a select which is blocked on something, and perhaps talk about some more LWIPs, TCP/IP settings, so that connection to something that's not there could fail really quickly. So let's again open the example, and for that I'm again going to reconnect to the Ethernet kit, as you can see, and in this case I'm afraid I would need to flash and monitor, because there was well, that's probably the previous example on this Ethernet kit. So let's wait until it flashes and connects, and let's see what we have. So it connects to the Ethernet, socket is created and connecting to 1, 2, 3, 4. And now let's disconnect the wire, and as you can see, the link is down, and we got this message disconnected and exiting. So let's again jump to the code and see what we have here. So this is again from the default TCP client example, but instead of connecting the way the TCP client does, so connecting with the blocking socket, we set the socket to the non-blocking mode and try to connect. And if in progress, we just call select. But we don't call the select just on this single socket, but we have another file descriptor here. So let's look at this disconnect FD, what it does. So that's a global variable, which we actually write into in case we got a disconnected event from the Ethernet, because again we ran this example on the Ethernet kit. So we actually watch for this file descriptor as well for as we do for the socket, and try call select on that. And if the select returned, so this is the blocking call, and it does whenever something in this file or in this file changed. So in our case, it was disconnected exiting. So we got here, and we exited from select, and this is the message that was printed because the disconnect file descriptor was actually set. So in that case, we just close the socket and do after close. So this is very useful to inform let's say a task that calls select and does select on multiple, not only one socket, but we could have many more sockets that we care about, but this way we can inform the select to return immediately and watch for this custom file descriptor to see if something unexpected has happened, for example, on the board or something else. This demonstration actually showed the disconnection, but in this specific case, it's not so needed because the select would return as well because the Ethernet link down actually sets the network interface down, and in this case, the network interface in LWIP would know about that, and select would return even if we didn't use file descriptor. But this is just for the demonstration that we could use this event file descriptor for some other means to communicate, or if we use some custom network interface. What I also wanted to show you is that this connection, even if we don't want to spend too much time on connection, we can update some TCP parameters. So I have prepared here the TCP, some TCP parameters of LWIP. So maximum number of retransmission of SYN segments and the initial retransmit timeout time. The default is 3 seconds, but in IDF the default is 1.5 seconds. These options are generally available in our kconfig, so we can update it there as well. But here, for the simplicity, I could update it directly, just updating it simply to avoid the need to rebuild the entire IDF. So we will just rebuild the LWIP component, and as you can see, I have reconnected the Ethernet wire, and once it builds, it would flash the program, and hopefully it will disconnect by itself. So if we look again at the numbers, it should retry only 3 times and initially wait only 500 milliseconds before the initial retransmission. So yeah, we got here. So select returned, and we got an error that the connection actually failed. So this is the way we can also adjust parameters of the TCP protocol itself, so to make the TCP a little bit more responsive. So I'm not saying that these numbers are really something that we should use or we should stick with. Probably the initial retransmit timeout of 1500 milliseconds is good enough. So the IDF default is probably fine. We could adjust the maximum retransmit of SYN segments, or also the data segments. But basically, in most cases, the IDF defaults are just fine. So let's return back to the presentation, and let's see what we have learned when showing this example. So about socket API, I've already mentioned that these are LWIP sockets. So we need to be aware that there are certain differences. So please read the documentation in IDF docs about LWIP. It's pretty well described. There are certain differences, mainly related to closing sockets from another thread. shutting down sockets, and other. I've already mentioned the connection timeout. So another point, if you like to handle timeouts for connection, you need to switch the sockets to non-blocking mode and check for or use select to actually check for either timeout or connection succeeded or failure. We also could use event file descriptors to pass additional information either about disconnection or about something, some other signal to a blocked select call. And if we are using some custom network interface implementation, if we set up our own network interface implementation with our own driver, we need to be sure that we always set the network interface down if the physical layer disconnects. In that case, we could be sure that the LWIP, the TCP/IP stack, always know that something happens on the physical layer and could report an failure. So let me just conclude with what I have to say about all of these three examples. Already said that we in IDF use LWIP, so there are certain things, certain stuff in networking configuration that is specific to LWIP. So already mentioned something about sockets. There are some other parts like DNS or output buffers and stuff like that. But please check the documentation for that. It is very important. But in general, in the common use cases, LWIP sockets behave almost like the normal common Linux sockets. About performance and kind of responsiveness, liveness of the application, I have shown that it's possible to set up the TCP parameters in kconfig options. As for if we are looking for the best performance, we need to adjust buffers to maximum, and it's always good to look at our iperf example in IDF, because this is the example that's used to measure the maximum performance. It includes IRAM optimizations. It sets the input and output buffers to maximum, so it is really adjusted to generate maximum throughput, maximum performance. About keep alive, it's always good to have a mechanism that tells you that the other part is not active. So you can use TCP keep alive, you can use library or protocol specific keep alive mechanism, or even in application you can, for example, ping or check if certain address or service is active, and if not, you can send an event or this event file descriptor to take actions. About interfaces, we said that this interface key needs to be unique, and we need to be aware of the routing priority and the default network interface. In IDF now, the ESP NetIF provides an API to actually override the default NetIF to set it directly, so not based on the routing priority, but if the application has some complex rules to decide which interface should be the default one, then users are suggested to actually use this default native API. As for the events, we have shown that we have the IP events, which comes basically from the TCP/IP stack. Plus, we have also the event that comes from drivers from the physical layer, and the link layer. If the link is up or down, we could have the network library events. And the first example I have shown the event from the MQTT library, the disconnection event or the error event. And we could also have application events, as I mentioned already. So this is all from me. Thank you for watching, and if you have any questions, please ask.
Okay, so let's invite David into the stream and we can start answering some of the questions. Hello, David. How is it going?
Hello, everybody. Going great.
Okay, perfect. So I can hear you. So we are ready to go. So don't waste time and let's kick out with the first question. There is some way to use ESP32 in AP mode and station mode simultaneously. Can you please answer this?
Yes, I sort of answered that in the chat already. We don't have a default station plus AP example directly in IDF, but if you follow that links that I shared in the chat, the second example that I showed is actually using that. It uses two interfaces of Wi-Fi. But it doesn't use the default interfaces as you have seen. There are some misconfiguration which I made just to make this presentation a little bit more interesting. So if you just go to default, it will work the same way.
Okay. Next question: is there an example of handling gracious interface handover, Wi-Fi, Ethernet, PPP?
I think I mentioned that in the chat too. We don't have like example that users can just run and play with that, start using it from without any kind of modification. But the configuration of network interfaces for Wi-Fi, Ethernet, and PPP, the default configurations are prepared that we could basically just copy the portions of Ethernet, Wi-Fi, and PPOS example together, and it should work. Because the routing priority is currently by default set that the Ethernet has the highest priority, then we have Wi-Fi station, and then it's PPOS. The one important thing to mention here is that this default priority routing works only if a certain interface goes down. So, for example, it would work correctly only if the, for example, Ethernet link is down, which means that somebody basically removes the cable. So if there is some other obstacle on the way through via this connection over the Ethernet, it wouldn't work, and we would need to use this like default NetIF override function that I mentioned in the last slide.
Okay, the next one. Can you talk about whether the IDF SDK supports TLS on the server side when using the BSD socket interface? The OpenSSL APIs are deprecated, and the only ESP TLS APIs are only client-side.
Mm-hmm. Yes. We have removed OpenSSL component from IDF. So currently users have two options: either use embed TLS API, which is kind of complicated, but we also have this small component that is called ESP TLS. So users can basically use that. I agree that by default it has only the client side, but there is a menu config option that actually enables the server side. So yeah, it's possible to use ESP-TLS. It has a very simple API, like start, read, write, stop, and the important thing is to enable it in menu config.
Okay, David. So it seems I'm just giving you 2 easy questions. So let's share the next one. And it's recommendable run a network in one core and add in another core. Can you just share your opinion on this?
Yeah, as I said in the chat, this is kind of a tough question, or some sort of. I don't have a good answer for that question. Some people say it's better to have the networking stack with Wi-Fi running on one core and everything else on other. To my experience, it doesn't really affect the performance that much. And one related question was there about the best performance. And if you check what is the iPerf configuration, if I'm not mistaken, it uses single core mode. I'm not 100% sure about that, but the idea is that for iPerf, because this is also used in our CI to actually check and verify the performance, we need repeatable numbers. So for repeatability, or let's say standard deviation of the performance, it's good to have it, let's say, separated or even running on a single core. But in general, I think it doesn't really matter too much. You can even get a better performance with tasks that are not basically coupled, or the affinity is not set to certain cores. But the repeatability would differ and might differ. So unless users are doing really something specific, I wouldn't recommend to actually play with the cores and pin certain system tasks to some cores.
Okay, and the last question for you, David. Is it possible to init and start an APSTA interface, but without configure STA1 to let users set it, for example, by a launched web server, keeping the access point always up?
Yes, it is possible, but we always need to keep the thing initialized. So we need to run the init only once. But then there is other API like start, stop for the AP and connect for the station. So in my second example that I shown and shared the links, you can see how you configure the Wi-Fi using station plus access point, and you need to initialize it like that. But you just start the access point, and whenever you need, you would also start and connect the station, and that should work.
Okay, perfect, David. So thanks for detailed talk. I'm just sharing one nice feedback for you, and see you soon. Bye-bye.
Thank you too. Bye-bye.
And guys, we are now going to the last talk of the third block, and it's from the external company called Golioth.
Hi, we're excited to be here at Espressif's DevCon 2022, and we're going to be talking today about thousands of ESP32s device management for ESP-IDF-based devices. My name is Chris Gammell. This is my coworker, Mike Szczys. We both work at Golioth, and we have really enjoyed working in the ESP-IDF recently. We'll be talking about that here in a little bit. So first things first, let's just give a little background about who we are. if I can find my mouse. My name's Chris. I've been working in hardware a long time. I now work at Golioth in the developer relations group. If you have a hardware background, you might know it kind of like a field applications engineer, that sort of thing. But basically, Mike and I, we make demos, we make videos, we make blog posts, and we talk at conferences, and we love talking about it. Mike, how about you?
Yeah, my name is Mike Szczys. So I am a developer relations engineer at Golioth along with Chris, and have a lot of fun there playing with microcontrollers. I started off in the early 2000s with the propeller microcontrollers and moved on to the AVR. I was amazed by the speed of the AVR. So you can understand that the Espressif chips kind of blow my mind. Also, just what we're able to do, like connecting these microcontrollers up to the internet and doing amazing things with them. Boy, I wouldn't even have thought this was possible 15 years ago. So having a great time with it.
Great. Finally, Nick Miller is our lead firmware engineer. He's not here today, but he is the author of our Golioth ESP-IDF SDK. He had glowing things to say, which we will relate later in this talk. Nick had some past experience with the ESP-IDF ecosystem, and he was able to turn around our SDK very quickly, and we've been very, very excited about it. So we're going to show some of that here today. Speaking of showing here today, let's talk about some of our learning objectives. So what are we trying to see in this talk? We're going to be talking about large fleets of devices. And even if you don't have that, if you only have one Espressif device on your desk, well, first off, buy some more. They're great. And as you start to grow, or as you think about it, even maybe you're like, maybe in 5 years I might have a bigger device fleet. One of the problems is you don't know what you don't know, and that's what we're here to kind of talk about today. What are some of the challenges around growing a device fleet? As your device fleet gets bigger, what do you have to deal with, and how might things change? We're also going to do a demo. Mike's going to do a demo about Golioth and how we kind of work with that stuff. How we have some simplified functions to make control of your devices easier. Well, actually, what is the next point here? We make it easy to collect sensor data, to control individual devices in and amongst thousands of devices, and do the critical thing like over-the-air updates. That's another thing that people really, really seem to like about Golioth, and it was very easy to implement in ESP-IDF. So let's talk a little bit about you. You are probably someone who is interested in hardware and firmware, even if you have a different background. If you're interested in Espressif, you probably are a fan of the hardware like Mike and myself are. But you probably don't want to become a cloud expert. So if you want to control one device, 1,000 devices, 1 million devices on the cloud, otherwise you probably do need to become a cloud expert. We think we found some ways to reduce that barrier to entry, and you still might want to then go and actually talk to all the devices that you have out there. So it's going to depend on your application, depend on how many devices you decide to do. But let's assume you're going to be putting thousands of devices out in the field. And let's talk about some of the challenges about that. Some of the things that you do when you have 1 or 10 devices on your bench, it starts to change. The nature of those interactions change at hundreds or thousands of devices. And one thing that Mike and I do is we talk to users both around the ESP-IDF the SDK that we developed, and also other programmatic ways that people can make their devices talk to the cloud. And a thing that comes up a lot, I think Mike will agree with me here, is scripting, right? So scripting is like this, I can write a Python script, talk to REST API, make it do this, make it do that, maybe even control the hardware over a UART or similar. And that's great. It actually does work. You can do that out to 1,000 devices, thousands, millions, whatever, but it just gets more complex and more opaque. So if you are potentially telling all of the devices you have in the field to go and update their firmware, maybe go talk to an S3 bucket, that's a common one that I've heard. That's great, but then you also need to put in tooling for, did they actually all do it? Which ones worked? Which ones didn't? Which had problems? Which are still kind of hanging in there? Maybe what is going on with the network in order for them they couldn't download the entire image. And so putting some other stuff in place there can make that a little bit more clear, and that's what we aim to do. Another thing is, as your team grows, so if you imagine you have 1,000 devices in the field, maybe you have a business you're starting to build an IoT deployment around, well, you're going to need to hire people eventually, maybe for deployment, for monitoring, whatever it is. And even if you have the same skill set, you might not have the same deep domain, the same deep expertise around the actual deployment itself. So Mike and I, Mike is much more skilled than I am in a lot of areas. But if I'm the one who designed the device and the firmware, and then I ask Mike to come and help me, I have a little bit more kind of in-depth knowledge of how I built things, where the demons are, that sort of thing. And then I bring in other people who are skilled or unskilled, and I want to make it easier for them to be able to help me out and interact with the devices. Another thing we see often is resources that are installed locally. So what I usually think about here is like a Node-RED instance that might be on a Raspberry Pi on your local network, or maybe on your computer. It needs to scale by being out on the cloud, right? So you need to be outside your firewall, but also you need to have kind of larger implementations of this, and that can be dangerous or hard to manage. But basically, while Node-RED, Mike and I prototype with Node-RED a lot. Getting past tens of hundreds of devices, it's possible, but it just becomes more burdensome. And so there's other ways to go and actually control devices and react to them and forward data along that we think we found some other ways to do that sort of thing, but we want to help explain what that looks like. When you do have thousands of devices and they're all sending stuff back, so Mike's going to be showing a demo here that's sending, I think every 5 seconds. Is that right, Mike? At the beginning?
Yep, that's how it starts.
Yeah, so every 5 seconds it sends at the beginning. Even at that, every 5 seconds from one device throughout a day, throughout a week, throughout a year, whatever, it's a significant amount of data for a single device. And now as you're linearly scaling your actual deployment, that database starts to get really, really big, and thinking about how you want to manage that data. When do you want to cut it off and start deleting the old data? And it just seems more and more like a job. Speaking of linear growth, as your device management, as your device size, your fleet size grows, and it scales linearly, your time doesn't, right? So I might be able to look at 10 devices blinking on the desk and say, oh yeah, they're all online right now. But when it's 1,000, they might not be in your desk in the first place. But even if you had 1,000, it might be hard to pick out the one device that isn't blinking right now. And so you think about being able to monitor each and every device. Your time is a very valuable thing, and you want to be able to see that device health. Finally, we already talked about firmware updates a little bit, but plugging in one cable to update a device, that's fine. But doing it 1,000 times, that's probably a week plus of work. And depending on where your devices are, and if they're installed up on a big tower, that's a long cable you need. So so one of the things that we think can help with all this is Golioth, the company that we work for. It's a device management platform, and we're trying to solve a lot of these scaling issues. One of the things that we see is kind of balancing the ease of use and programmatic control, because what we were talking about with scripting is kind of programmatic control. Ease of use might be more of a UI base. We actually think that we can do both. And so that helps you to scale between having more people on your team. You might want to allow more people on your team to manage devices on things like our management console. But then as you want to roll out big changes to the rest of your fleet, you can then programmatically go and access our REST API, which makes it easy for that scripting or for things like apps to go and talk to our devices, which is actually something Mike is about to show. So Mike, take it away with our demo, and we'll come back to the slides here in a second.
Yeah, so I'm going to take just a moment here to get my camera switched over. And let's see. All right, how are we looking, Chris?
Excellent, like usual, Mike.
All right, thank you. Okay, so we have on the bottom right corner here, this is a live image of the ESP32 C3 Dev Kit C. This is a wonderful board you can get from Espressif. If you don't have one already, you should definitely pick one up. It, of course, has the Wi-Fi modem in it. That also has a core temperature sensor, which we're going to be using for streaming data, and an RGB LED light that we'll get to in a moment for user feedback. So if I just hit the reset button on this, we can see the bring up. It's looking for Wi-Fi right now. It's going to attach to my Wi-Fi point. This particular example does a few things at the beginning. So it looks for over-the-air updates, and it's going to wait until it gets a firmware revision, so it's to see if it should do an update or not. It also downloads some settings, and we'll look at that all in just a moment. But for right now, these core temperature readings are the thing that I think is the most interesting. So, a lot of IoT devices have a sensor, get some data, get that back to the server. So if you're talking about thousands or millions of devices, you want to be able to do that. You want to be able to handle that data. This is the Golioth web console, and I'm looking on here just for this device. And I can go into our LightDB stream, which is a time series database. And I can see I'm getting these timestamps that go along with the data that's coming in. Now, I like to show this view because you can see this is a JSON object. You can send complex JSON objects. So if you have numerous readings nested and all of that sort of thing, you can use that just fine. But for today, I'm just doing a sensor with one data reading. But this is just for this device. And we're talking about managing thousands of devices. So I can go and see the same stream, the time series database for all of the devices that are reporting. And in this case, it's 2 for the demo. One is on Chris's desk and one is on my desk. And I can do the automatic refreshes on these. Let me make sure I'm in the last 4 hours. And we'll see the settings is my device, and the Chris is Chris's device. And you can see these coming in about every 5 seconds on the timestamps here. The thing about this data is it's not very compelling to just watch the numbers go down, and it's maybe not easy to tell whose number goes where. If you're trying to proof something out for your boss or get a customer to say yes to a contract, you might want to do something more graphical like this. So Chris talked about the REST API. This is along those lines. I'm using an API key and our WebSockets to get live data as it comes real time from both devices. Chris and I are not in the same office. We work in different parts of the country, yet I'm able to both see and control his device. Let's talk about that device control. So I mentioned that we have 2 types of databases. So if I go back to my device settings, we can see the stream is what we're looking at for our core temperature, but the other one is going to be state. So this is like, is the LED on or is the LED off? This is stuff I don't really need to know over time. I just need to know what's the setting at right now. And for my device down in the bottom right here, this is actually registered to observe this desired endpoint on the web. And so every time this updates, the Golioth servers are going to tell this device, hey, your data just updated. And the data I'm actually looking for is LED 0, and I can set that to a value. And as soon as I click submit, we should see the device reacts by the blue LED coming on. You'll notice that that endpoint, it was deleted by the device to indicate that it got that command. I can do the same thing again in order to turn it off, and you'll see that data is gone. So this is great for testing for 1 devices or 2 devices, but what if you're trying to control lots of devices? So one of the things you can do, similar to how I did this graphing on Grafana, which is an external platform, I actually found this web app, this Android app in the App Store. This is called Home Habit, and it lets you assign buttons to REST API calls. And so I've got one that is a button for turning on my LED right here and another for turning off. Now, if you watch when I press this button, you're going to see this desired value will be set. And that's because the REST API call is what's being used on the dashboard as well. And it's what controls the endpoint that the device is listening for. I have the ability to do Chris's as well, but I think you've seen enough LEDs go on.
I have it up right now if you do want to show it, Mike.
Oh, yeah. Okay. So we should be able to turn
my face just so it's in. Yeah, there it goes. It's on. Yep.
Yeah. Chris is on. Chris is off. And because this is a REST API call, I'm calling the exact devices with these buttons, but I could call groups of devices. I could call the entire fleet. I could have the LEDs for a million device fleet come on with these. Whatever API call you want to run will be fine right there. So that is device state and running some API calls on there. Probably one of the biggest that we hear customers looking for is the ability to update firmware. So like Chris said, if you're going to plug a USB cable into a device, that might be fine for 10 devices. But if you get to 1,000 or 100,000, you're in big trouble. But not with Golioth. We've got it all figured out. So here you can see I'm actually using a blueprint on these artifacts. The artifacts in this case are all firmware binaries that we've uploaded. And I'm telling it like, hey, I've given a blueprint to certain devices. So if those devices are listening for updates, this update is the one they're looking for. Once I have those, I can create a release. Here we'll see our blueprint again for our ESP32C3 dev kits. And both Chris and I are running the 1.2.5 right now. I have another release available, 1.2.6, but I haven't rolled it out yet. And so when I actually click the rollout button and I go back into my IDF monitor, you're going to see that it will tell us it's running the current version 1.2.5. It's going to find out from the server that 1.2.6 is now available. And we actually see it's downloading blocks. So it's going to go through, download this, verify it, and upgrade to this. I don't think we have time for that right now on this demo, Chris. So I'm actually going to turn that back off again. And the device will, I've just clicked reset, so the device will stop trying to update on it. But this is another feature that I think is really interesting. If you roll out firmware and you tested it, it works, but you realize you made a mistake, like you got a decimal point in the wrong place on your data or some other reason that you don't want it running on production. Instead of having to go back and find on GitHub the last hash that was working and compiling it and testing it and pushing it out again, you can just do a one-click rollback, and the devices are going to be notified, oh, 1.2.6 is not good anymore. They're going to find 1.2.5 is the last known good one, and they're going to download that and start running it. So a lot of peace of mind there for devices in the field and what you're doing with the updates. Another thing when I think about devices in the field is like how to troubleshoot them. So you might want to be able to get logs from your devices. Well, if you don't have a USB cable connected for the monitor, how are you going to get these logs that are coming out? And Golioth actually has a logging service for that. I can go and look at it. You can look at it by device or by the fleet. I'm just going to look at it by device here. And you can see these log messages that have been coming back. I have debug messages set up for reading the temp. I can filter those out. So I can just look at my info messages, which tell me like when the app came up and some more about the state of it. And of course, if you don't want to have all of these, think about millions of devices sending debug logs. That's probably not a great use of your database. You're going to have trouble finding things in there. You can just turn those off or set the debug level remotely. In this case, I'm not setting debug level. I could here. I instead set the delay between sensor readings. So Chris mentioned before, there's 5 seconds between sensor readings. Now I could change this right here, but this is only going to affect this device. However, as with the other things we've been showing, there is a device settings option for the fleet level. And so I'm going to go ahead and reset this from 5 seconds to 2 seconds. And if we look on the monitor, we see already this device has seen that. Chris's device will have seen that as well, where he's at. And if I go back and look at the incoming data, we can see now our timestamps, both Chris and I have changed to 2 seconds in between readings. So like if you wanted to set your log levels, you could change and say, okay, debug levels I want just for this one device, or you could say I want all devices to only send error. You can also do by groups of devices using those blueprints as we looked at before. I think the last thing that I want to look at is the remote procedure call. So this is really a great way to interact with your devices. So in my case, I have just implemented a function called reboot. And we'll look at all of this code in just a moment. But I can send a reboot message to my device, and it got that, and it's going to reboot in a few seconds here. The great thing is it's also going to tell me it got the message at this timestamp, it took this long to react to it, and the status is okay on this. You can also send parameters. So if you want to send some commands in with whatever your function is going to be, you can work with that, and then you can get data back as well, and you'll see that displayed here. So this is wonderful for things like, oh, I want to check RSSI values of the Wi-Fi for this one device because I've been having problems with it. Why don't I send a remote procedure call and have it tell me like what's going on with the signal or whatever other thing you're doing. Yeah, that's a lot. Chris, do you think we should roll on to the next part and look at some code?
Yeah, let's look at some code. That's great. Okay, so we're going to go back to our slides here. And we're going to talk a little bit more about what Mike had shown you on the actual Golioth console. So remember the console.golioth.io, that's what Mike was just showing for a lot of that management, that GUI-based interaction. You also Mike showed some REST API interactions as well. So that's really that balance point between making it ease of use and being able to target individual devices and kind of understand everything that's happening around a device without having to do lots and lots of scripting there. All right, so let's talk about some of the things that Mike showed there and really the concepts of getting data on and off of devices. So the first one was LightDB state. And this is how Mike turned my LED on from, I don't know, we have 1,000 miles apart, Mike? I'm in North Carolina.
Yeah, something like that. And I would like to mention, Chris, that all this Golioth SDK is built on top of the ESP-IDF. So you just include it as a component of your ESP-IDF project, and then you get these kind of like one-liner commands. And so in this case, like sending data from the device to Golioth is the top line, the set int async, and then getting data back is the bottom one, which is you tell it where to put the data. And also in this case, it's a synchronous. So we have both asynchronous and synchronous API calls. This one will wait 5 seconds before it gives up waiting for the server to come back. But you'll notice the top one is asynchronous. I didn't put it on here, but there's a way to observe these states as well. And in those cases, you set a callback and you just register the callback with one line. We'll see that that pattern in just a moment.
Yeah, Mike brings up a good point too, is that all the code you're going to be seeing here is device-side code. And there is no server-side code because all of the interfaces, all of the endpoints that you're talking to, and really all of the tooling and infrastructure behind it, that is all taken care of for you by Golioth. So whereas you might be used to writing like Lambda functions or similar, or snippets of Python you have to go and kind of maintain on the server, this is all device-side code. And so to call back to the beginning of the presentation, when I said as a hardware person, I don't want to have to become a cloud expert. This is a good example where enabling just these single lines gives you all this stuff. In this case, being able to control a wide range of hardware that you have out in the field.
LightDB Stream is the other type of database we were talking about that's time series data. So it's going to have timestamps, and you're going to be able to graph that data or do whatever other type of filtering that you want. And in this case, just a single line call. So I got the T sensor out value here, and I'm just writing that to the temp for temperature endpoint. And so every time you need to push something up to the cloud, you can just send this command. It will assign the timestamp automatically, but there is also the option for you to include a timestamp and a JSON object. So if you're caching sensor readings and uploading them later, you can get the right timestamps in your database.
Yeah, we've done that for GPS examples in the past where the satellites give you their timestamp, you store them and move on. I think this is a great example of just that, it's basically like a server.write, as like a pseudocode kind of application there. And then you get access to all of this data on the server ready to go. And we'll show some other options for seeing that later.
The setting service is what we used for changing the seconds delay between the temperature settings. Reading the temperature sensor. So you could do this, like I said, for changing like the log level of what is being sent back to Golioth. And in this case, the upper block on the left is the callback function. You can see in there, I'm just checking for a specific endpoint, the loop delay seconds endpoint. And if I get that, I will go off and do something in my code. I'm actually just changing a global variable. I took that out for this example. And then otherwise you could return that the setting was not recognized, and then Golioth will know whether or not your settings are in sync. There's a place on the dashboard for that. The bottom line is the one-liner for registering that you're going to use the settings and telling it which callback to execute.
Yeah, I really like that this is the kind of the arbitrary code piece of it, right? So you could kind of put a lot of different things, you can call it functions, you could kick off a task, that sort of thing. That's what we do for the reboot function. When I think about like a large scale deployment, like your example of RSSI is great because you might not want to be sending back RSSI every single time you publish all your data, but you can do it on demand then. And so you could really think about how you might want to be debugging more of your device. So you kind of have submenus on submenus to really dig into what's happening. I'm getting this confused with the RPC right now.
RPC, yeah.
Yeah, sorry, that's the next one. On this one, you could really imagine having a wide range of available settings and being able to target each and every one individually.
Yeah, you could also have streaming data.
The gun on that one, Mike.
Well, you could have streaming data for your RSSI already set up, and you could use the settings procedure to just turn it on and off. Like you could turn a whole bunch of debugging features on and off, and have like a whole suite that's just waiting there, and have the settings service like, oh, this device, turn it on, or you could be like, all the devices that are in Akron, Ohio, turn this on, and have a lot of
turn on debug mode, and then it floods.
Yeah,
gets you a whole bunch of data to help.
Yeah, because I mean, again, you don't want to have someone drive out to the plant and hook cables up to your devices. Like you want to be able to do as much as you can to fix the thing without going there as possible.
That's right. All right, now the thing that I jumped ahead to.
Yeah,
I'm so excited about it.
Remote procedure call is, I think, when you need a little bit more interactivity, right? So for instance, like you might have multiple Wi-Fi networks that you're trying to spec out, but you don't know what they are at compile time. So you can't just set up, turn it on or turn it off. Remote procedure call, you could send something that says, hey, look for this Wi-Fi network and tell me how strong the signal is, and then send that information back to me. Like there's a lot of utility here for you to not just run a function, but to run a function with parameters that you weren't thinking of when you programmed the device.
Yeah.
And of course, you're not stuck with what happened when you first compiled the firmware, because you can just compile new firmware and send it to the device. In this case, I'm blown away by how easy this is on the ESP-IDF SDK. Literally, I just tell it the current version so the device knows what firmware it's running. And then this one-liner below that tells the Golioth servers, hey, I'd like to know when you have a firmware update, inform me. And so you will just get a push notification from Golioth when a new version is available, or like the next time you power up, if you're in low power mode, it will always check on power up and you'll be able to automatically do firmware updates.
Yep. Cutting down on cables and plant visits, like you mentioned. Let's talk a little bit about, once you have that data on the cloud, other things that Mike kind of covered here. One thing is the concept of blueprints, and really this and the next item are ways to kind of slice and dice your deployment. So when you really want to have a targeted strike just at the devices in Akron, like Mike mentioned, you might have those tagged. That's the next one here is tagging. You might have them tagged as Akron, but you might have 3 different types of Espressif devices out there. You might have a ESP32C3, original ESP32, and ESP32S2. And you might want to be able to narrow it down to just the C3 devices. I only want to see those, or I only want to see the ESP32 C3 devices in Akron. You could start to really slice and dice your deployment and understand what's going on, even instrumenting it off platform in something like Grafana as well. Mike also showed this with the multiple viewpoints and seeing the streaming data come in. You might want to prototype what that looks like, being able to, we are showing a single sensor reading, but I've had some sensor platforms that had 50 different parameters that were being sent back to the cloud, and you want to understand which ones you're using, how they're working hierarchically, and how you might be exporting them to different places. And finally, on the export side of things, we do work with, we have native integrations with things like AWS SQS, Azure Event Hub, and webhooks, GCP, and an ever-growing list of those. But we realize that most people are going to be working with a cloud-side team that they might want to export that data to in the future, and we want to make that really, really easy. On the choice to make the ESP-IDF SDK as part of Golioth, we decided to build it because we saw a vibrant community, obviously as part of this event, but also a well-developed ecosystem in the ESP-IDF. We've been really impressed with that. And this is some of the stuff that Nick wanted us to pass along as the author of our SDK there. One thing that really helps a lot here is standardized setup across hardware. So even though there are multiple product lines and all ever growing, the kind of standardization in the ESP-IDF has been really useful. Being able to work with a well understood version of FreeRTOS with a networking stack, embed TLS, and then an external library. That's kind of the listing of the requirements to go in for us to build an SDK. We need to be able to send secure messages back to the Golioth cloud because we're secure by default, and we need to be able to have an understanding of all of the variations in the hardware we might see. It was easy to pull in co-app support using that library, and really Espressif just did a great job with testing and building this ecosystem for us to build upon. Not only that, example code was really useful, especially a co-app client. So Golioth operates with co-app endpoints as opposed to something like MQTT. We think there's a lot of benefits in terms of lower data overhead. Again, when you're scaling, you might not care about a couple kilobytes here, kilobytes there, but thinking about the data traffic and all of the compression that might happen with co-app versus MQTT, UDP versus TCP, all of those kind of different things there. We really like working in co-app, and you'll see that in some of our examples. The great documentation, though, and being able to tap into the community has been very, very helpful. So we're very interested in helping people hyperscale to your device fleet, 100 devices, 1,000 devices, 1 million devices, 100 million devices. We're here to help you with that. We can always talk to you about that sort of thing. Mike and I, as I mentioned at the beginning, DevRel, developer relations, we write a lot of content, not just about the Espressif ecosystem, but also all of the things that we cover and some of just kind of general interest points as well. We do recommend you check out our blog.golioth.io. If you sign up for the console, you actually get subscribed to that, and you'll see stuff come out every Tuesday, Thursday on the blog, and we have a newsletter every 2 weeks. And finally, you should please try out the console. So it's all free, up to 50 devices, and our dev tier gives you those first 50 free. We think that's a pretty good size, and you start to see some of these scaling problems at that point. Thanks for having us. We really appreciate it, and we're really excited about the future with Espressif and DevCon22. Mike, any other thoughts?
I just had a great time. It's been wonderful being here. Thank you.
Thanks so much.
Okay, so let's add the guys from Golioth, Mike and Chris. Hello, guys.
Hello.
Hey.
Perfect. It was an interesting talk, nice demo and so on. So let's just start with the questions. We have the first one from the audience, and it's, is the website customized to each client?
Yeah, so we actually have projects that you can switch between on the dashboard. So if you have multiple customers, we would recommend that each goes on their own project so that their devices are separate from each other. As far as customizing a dashboard, everything on our website is using an API to be displayed. So anything you see can be built into your own website, or if you want to, so you could then do a different branding and a different look for each customer. But we also have the ability to do output streams, which make it very easy to connect to other sites. Chris, I think like DataCake and Ubidots both do that kind of like custom customer dashboard option, and we have built-in integrations for those.
That's right. And I would also say, so like Mike said, so say you have a consulting client, maybe you have like a couple consulting clients, they each have their own project, but one of them gets really big, right? They hit the jackpot, they have 1 million devices in the field. We also, really cool thing about Golioth is it can be deployed onto your own AWS servers or your own Azure servers. And actually, because it's, Kubernetes based, you could basically go and install it on any, you could install it in a server closet as well. So basically taking that exact same code that, your ESP devices are talking to, the Golioth endpoints and things like that. You could take that and then install it into a server closet, for instance, and have a local deployment or a really massive deployment if you're on Google Cloud or AWS or whatever you wanted it to. So, so short answer, yes, it can be customized to each client.
Perfect. From the point of the beginner, at the very end, you have mentioned that you can just start for free with 50 devices and just run your first fleet. Can you maybe explain a bit more, like how can I just like start step by step?
Sure. So the easy way to do it is you can sign up on console.goliath.io. That gets you, your first account and those 50 devices. From there, you're going to create a device and you'll get credentials that then you're going to be putting into ESP-IDF. So once you compile your code in ESP-IDF, you put that on your ESP32. Then there's a time when you're going to give your Wi-Fi credentials and your Golioth credentials so that you're verified to be on the network. And really, it's all about getting that first device on there. In the ESP-IDF, like Mike showed in the demos as well, there's a bunch of, in the Golioth basics thing, all of that sample code that we were showing there is already there, so you could start to see things like light DB state showing right away.
Okay, perfect. We have here a few questions from Espressif. So the first one is, recently the support for ESP-IDF was added on Golioth. How this experience has been for you?
Go ahead, Mike.
Yeah, it was a really great experience. I talked to Nick Miller, who is our lead firmware engineer and developed the ESP-IDF SDK for Golioth. And he recounted that it was a great experience because a lot of the things that were already built on, like CoAP was already in there, embed TLS and DTLS were already in there. And then there were great examples that he was able to follow, like how Espressif and ESP-IDF handle firmware updates. So building the over-the-air update service of Golioth into the ESP-IDF was like, it couldn't have been easier, I think. And so anybody that's looking to do an integration, this is a great ecosystem to be in.
Okay.
Yeah, and I would say as well, like, so Mike and I do a lot of Zephyr stuff. We were switching over to ESP-IDF and it was just like, it was a snap to just like understand what was going on immediately. All of the tooling, super awesome. So really, really great polished product.
Okay. Let's continue with the next question. How do we send JSON data to the Golioth cloud service and also connect it to integrate it with Google Assistant, for example?
So JSON data to the cloud service is simply putting formatting your string. So I use like an SN print K type of statement to format my string into JSON, and that just builds in, you know, like the curly brackets and quotes around strings and that sort of thing. Once you have that string, it's a one-line command to send it to Golioth, and usually we're sending those to the Golioth stream, which is a time series database. So if you think about sensor data, you want a reading every 5 seconds. You want to know the timestamp on that. If there's, we also have a state database. So if you're like, is the LED on right now? It doesn't really matter as much when the LED was on or off. You just want to know the state right now. Both of those, you format your JSON. You just call the function that sends it there. As far as integrating into Google Assistant, that's Chris. What are your thoughts on that part of it?
So I think then you might have to, the Google Assistant stuff, we don't have any native examples for that. But I would imagine that, so say you were trying to control, like Mike said, an LED on one of the devices that's out in the field. If you had some kind of external service that's talking to Google Assistant or handling the, you know, the incoming from Google Assistant, then in order to turn the LED onto device 22 that's in Akron, Ohio, like Mike had mentioned during our talk, you know, basically you could access that directly through the REST API. And so to actually turn on an LED on device 22 in Akron, Ohio, it would just be able to query where that device is, and you know, you already verified onto that you're able to talk to the REST API through our API token that we issue, and then you can flip that LED from 0 to 1.
Right. For a lot of other integrations that I've done, I've used our WebSockets because you get real-time data updates. As soon as data is received from the device, Golioth will send it to any WebSockets that you set up. As far as accessing, Chris mentioned the REST API. We also have webhooks set up and a bunch of native integrations to different cloud services. I'm just not as familiar with you know, plumbing it directly into Google Assistant.
Okay, so I have like 2 last questions for you. The first one, hello there. Does Golioth have support for ESP S3 voice recognition?
Not that I know of.
I think that would come from the ESP-IDF itself. So if there's support in the ESP-IDF, you can then, you know, use that support and send it to Golioth, because Golioth is just a component that you add into your ESP-IDF project. So if you have an existing project, add it in, start using those APIs to send data up to the cloud and get control back.
Okay, and the last question. Do you plan to have support for TLV alongside with JSON?
I don't know what TLV is,
well, so if you're asking about serialization, we have CBOR serialization. So a lot of people don't want to use JSON because it makes the packets larger. And Golioth also has support for cellular devices. And built into that, we use the CBOR serialization to make sure the packets for your bandwidth are as small as possible. And of course, that CBOR serialization is also available for any of the Espressif parts that you're using with Golioth.
Okay, so I think that's it. Thank you, Mike and Chris, for joining us, and see you soon. Bye-bye.
Thank you. Appreciate you having us.
And now we will have 10 minutes break, and after that we will just continue with the last block of the talks. Okay, so it seems we have an issue with the introduction from Ioannis with the sound. It should happen. So instead of nice speech from him, I will go live and introduce the next talks. So basically, we have three more. The first one will be Espressif-IDE for ESP-IDF application development. The speaker is Denis Almazov. Then we will follow up with the Arduino under the hood, the Lib Builder and Arduino as component in ESP-IDF. This talk will be held by Rodrigo Garcia from Brazil. And after that, we will have last talk today, the external one from Adafruit. And this talk is called CircuitPython for ESP32. At the very end, we will just finish up with the general Q&A from Amey and Kedar from Indian team. So let's just start with the Denis talk, and that's it.
Hi, my name is Denis, and my topic today is Espressif-IDE for developing ESP-IDF applications. In today's presentation, we will take a look on some general features of Espressif-IDE, and we also will focus more on some important features like memory analysis and debugging features. So Espressif-IDE is IDE based on Eclipse CDT, which is using for developing IoT application, and it has some plugins like Eclipse CDT, OpenOCD plugin, Embedded CD plugin, and of course ESP-IDF Eclipse plugin. On this slide, you can see some general features of Espressif-IDE. We'll take a look on them in the demo. Now let's take a look on memory analysis features. So on the left side of this slide, you can see application size analysis editor, which allows us to analyze static memory footprint of your application. And on the right side, you can see the memory trace graph, which is a part of heap tracing. Heap tracing allows us to request heap information, track memory corruption, memory leaks, and this helps us to find some memory-related bugs. Speaking about debugging, Espressif-IDE suggests several options for user, for example, GDB hardware debugging or ESP-IDF OpenOCD debugging, which is more comfortable way to create debugging configuration, because as you will see, we are providing everything for the user, and the user only need to check if his settings are correct and select his board, and he's ready to start debugging. Also, if user is using UART connection, he can put his chip to the panic mode, and with a serial monitor, he can use GDB stub debugging. Also, with using serial monitor and some print functions, he can debug application as well. And the last option mentioned here is application level tracing. Application level tracing is a feature that helps us to analyze program behavior. It's important to say that Espressif-IDE runs on all three platforms, Windows, Mac, and Linux, and it has support for Chinese language as well. Now let me show you mentioned features in a demo. So I will switch to the Espressif-IDE, and the first thing that user needs to do when he opens Espressif-IDE for the first time is to set up ESP-IDF and set up tools. To it, he should go to the Espressif menu and select the first option here, download and configure ESP-IDF. In this wizard, he can use an existing ESP-IDF directory or download the new ESP-IDF by choosing some version, or even clone the master branch to have the latest features of ESP-IDF. As I have already ESP-IDF installed, I will skip this step, and after installing ESP-IDF, Espressif-IDE will suggest you to install the tools, but you can always do it manually by clicking on this install tools command, or by using tools installation wizard, which is now in preview state. Let's take a look on it. On tools installation wizard, we have two pre-configured options on the beginning for Git and Python. On the next page, we can see existing ESP-IDF path, or we can click on new and download the new ESP-IDF, as it was mentioned before, or even clone the master as well. So on the next page, we can see the table with a list of all tools, and we can see status for these tools. We can select recommended tools, select all tools, filter it by different chips. We have a type filter here, which allows us to find necessary tool, which we can select and unselect. And by clicking install tools, all configuration variables will be configured. And as you can see, my tools are already installed. I will skip this step. And let's take a look what we have here in Espressif menu left. We have this update ESP-IDF master command, which is visible only if you are using ESP-IDF master. So you can easily update your ESP-IDF by clicking on this command. List of installed tools. We can erase flash, change language, URLs to ESP-IDF programming guide and ESP-IDF Eclipse plugin guide, product information, which gather all basic information from the system, which help us to troubleshooting and provide user solutions to his problems based on his product information log. So now when my Espressif-IDE is configured, I can create a new project. To do it, I should go to the file, new Espressif-IDF project. Type some name, click next, and here we can click on checkbox, create a project using one of the templates. We can type text here to find template which we want. For example, I will use app trace to host example to use application level tracing feature. As you can see, I have already created this project in my workspace, so I will skip this step, and let's take a look on Project Explorer. I have several projects here which are already built to save some time. So let's go to the Hello World project. And speaking about general features of Espressif-IDE, it's important to mention that we are extending features of Eclipse CDT. For example, code assistant feature. I'm typing ESP, and by combination control and dot, Espressif-IDE suggesting me to finishing my typing by providing me different functions name. Also, as you can see, all my code highlighted in different colors, and I can use a function navigation, which will navigate me to the source code. And also important feature, it's a code formatter. To keep code in same format, we can use a formatter. You can use some existing profiles or create a new one, share it with team members, and you will have all same format for code, which will help you to keep the code in this same template. Now let's take a look on the top side of the Espressif-IDE, where we have different buttons for build, flash, stop debugging. We can select different modes for run or debug. We can select different configurations in this bar, edit it, and same for the target, selecting different target, create a new target, open different terminals. Here we have ESP-IDF serial monitor or ESP-IDF terminal, and we can skip all breakpoints, which may be useful in debug mode. And we have toggle button for DFU. So if we click on it, the build and the flash button will be responsible for building and flashing DFU binaries. Now let me edit the Hello World configuration, and we can see here that we have all pre-configured options, and on the end of this page we can see arguments lines which are generating flash command. If we click flash over JTAG, we will see different command, which is for flashing via JTAG. If we select the different target here, for example ESP32S2, Espressif-IDE will notify me that target changed and will suggest me to delete the build folder. It is because my project is already built, and to avoid conflicts and avoid different problems, it's safer to delete the build folder to rebuild the project with a new target. Let me click no, because I'm using ESP rover kit, and you can see that arguments line is changed automatically now to ESP32. I will change it back to rover kit, and the next session we have here is a build settings. So for the build, as a build system, we are using CMake. So in this section we can add additional CMake arguments, provide build command and clean command as well, and we can select different tool chains. As you can see on this list, we have a tool chain specifically for ESP32 target, because ESP32 target is now selected for me. On the next bar, we can provide a different serial port, and we can provide different target, create a different name for it, or even we can delete it if we don't need it. So let's take a look now on the memory analysis feature. And to start memory analysis, we have to build a project first, selecting in Project Explorer, and click on ESP-IDF application size analysis. So we have two sections here. First section provides us general information about static memory footprint in text and in graph formats. It works with the different targets. And the second section is details, which has in-depth details about components and per symbol level memory information. Let's move to the heap tracing features. For it, I will use in sysview tracing heap log project. Let me open it. So for heap tracing, we need to use a debug configuration. I will show you a little bit later how to create a debug configuration step by step. And we also, for heap tracing, we have to create at least 2 breakpoints and attach start and stop heap tracing action to them. To do it, you have to right-click on breakpoint, click breakpoint properties, actions, and you will see here create a new action by providing name, type, and name of the dump file. You will be able to create this action. As you can see, I have already created 2 actions for stop and stop heap tracing, and now I should click on attach to attach this action to the corresponding breakpoint. As you can see here, we can see that the action is already attached, and this action is actually start heap tracing. Same for stop tracing. Now let's take a look on it, and we can see that stop heap tracing action is attached to this breakpoint. Also, breakpoints with attached action looks a little bit different from default ones. So you can notice that we have here a tiny icon, which means that some action is attached for this breakpoint. Now, when we select the sysview tracing heap configuration, click on debug, we'll resume from all breakpoints. The heap tracing dump file will be generated. And to save some time, I already did it. As you can see, I have it here. So to analyze heap, right-click on this file and click ESP-IDF heap dump analysis. So we have here 3 sections. First section shows us heap tracing graph, which shows memory consumption during the time. Also, we can switch to the different context here, update, refresh the graph, and the graph will be updated immediately. And the second section is more interesting. It's details, which shows us different allocation and free memory events and the address where these events happens. If we right-click on some action, we can show colors. Also, we have an interesting option here to view possible memory leaks. So by clicking it, we see allocation events without free memory events. So let's take a look on colors. So as you can see, we have a small table here when we see file name, function name, and line number and address. If we click on it, we will be navigated to the code. As you can see, it's up main, it's the same file and the same number. So very useful feature to track memory related bugs. Now let's take a look on debugging, and we'll start with creating a debug configuration. So to do it, you can click on this bar and create a new launch configuration and select here either GDB hardware debugging or ESP-IDF GDB Open LCD debugging, which is easier to do it. Clicking on next, and as you can see, all fields are pre-configured for me. And the most important tab here is the debugger tab, because we have here config option for starting the debug session, and we need to check if we have the right board here. So it's correct for me. I have ESP32 router kit, but if you will change it to some different target, it will be generated for different target. Also, GDB executable will be changed for different target. As you can see, it's ESP32S2, but let me change it back to the router kit, and GDB executable is also changed to ESP32. The next step is startup. Here we have important feature which allows us to flash binaries every time when we are entering the debug session. So we'll are not forgetting to flash before starting the debug session. And the second option allows us to show more detailed output from OpenOCD. I have already created debug configuration, so I'll click on cancel. And let me start the debug. So we are clicking on this bug icon to start the debugging. It takes a little bit more time if project is not built yet, but project is already built. So here on the bottom side, you can see the status for launching application, and debug is started now. And Espressif-IDE suggested me to switch the perspective to the debug perspective. Let's switch it. And here you can see we have additional options on top, responding for debugging our application. We have attached combination on a keyboard for this section as well. So we have resume, terminate button, step into, step over, and step return, standard debug options. Also on the right side, we can see variable step when you can track in different variables. We have the list of breakpoints. On the bottom side, you can see OpenOCD console and registers. You can move registers to this if you want. And if you step over the debug configuration, you can see that this numbers is changing for the variables. So everything looks as expected. And on the left side, near the Project Explorer tab, we can also see trace for the debug actions. Let me terminate it now. Move back to the C++ perspective. So the next thing is GDB stop. So to be able to use it, I need to switch to the UART connection and switching it, and need to open SDK config and to select the GDB on panning there. So I need to go to ESP system settings, and here panic handler behavior need to be set on GDB step on panic. It is already set for me, so I will close it. Also, we need to have here cert 0, which helps us to enter GDB step mode. And let me also, we have to select the port. It's already set for me, and flash the project by using UART. So as you can see from the console, project is flashed now, and I can open the serial monitor now. As you can see, we have in Hello World project different printing commands, and you can track them in serial monitor. We can use them to debug our application as well. And now I'm entering to GDB stop now, and Eclipse Espressif-IDE suggested me to change the perspective to debug once more. I'm switching to it, and once again we see all the same thing that we were seeing before: registers, variables, debug trace. But the only difference here is that we can only step here only once. By clicking next, the debug will be stopped. So now let's take a look on application level tracing. I will switch back to the GTEC connection. And I will use app-trace to host project. For application level tracing, we need to right-click on the project, click application level tracing, and if you don't have the debug configuration, it will be created for you. And in this configuration, you need to set your target and board as well. I have created it already, so it should start without problem. Yes, in starting OpenOCD, and now I can see application level tracing wizard. Here we have a different field to generate your application level tracing command. So we have output file field for a dump file. Also, we are providing the default log trace procpy script, but it can be the case when user is using his custom script for application level tracing, so he can select it here, and in the last section he will provide the different arguments, so his custom script will be selected for generating the trace log file. I can't parse it yet because it's not yet generated. To generate it, I need to start application level tracing by clicking on this button. And you can see from the log here that application level tracing is started, and I can stop it in any moment. So when I click on stop, I can click on start parse button now. If I click on it, we will see in the log the result of the parsing of trace log. And we can switch to the different consoles here to take a look what was going on OpenOCD side. So yeah, that's all from from my side for today. And on this page, you can see the link for our IDF Eclipse plugin, where you can create issue, suggest us any idea, or provide us information about bugs which you are facing. We will happy to answer to all your questions, and we will happy to provide features which are necessary for you. So that's all from my side. I hope I managed to reveal all advantages of using Espressif-IDE, and with your help, we will make it even better. Thank you for attention, and that's time for your questions.
Let's add Dennis and Kondal. Hello, guys. Can you hear me?
Hi, everyone.
Hey, hi. Hey, guys.
Perfect. So let's just start with the first question. It's from Netko Dimitrov. Is it possible to use Eclipse with ESP-IDF as well? The ESP-IDF means ESP Audio Development Framework.
Yes, so we should be able to configure the ESP-IDF within the Espressif-IDE. So I think it's already well documented as part of the ESP-IDF, where you could just need to clone the repo. So that comes with the compatible ESP-IDF. And once you clone that, all probably you need to do is you need to set the ADF underscore path within the Espressif-IDE, and then the build should go through. So yeah, it's as simple as that. So you could refer, recently we also documented on this in the FAQs. Probably you could refer to the GitHub page in our IDF Eclipse plugin. So we have clearly documented on the how to configure the ADF in the Espressif-IDE. I think that helps.
Okay, thank you. Next question, ESP-IDE is great, I love it, but sometimes we need some light IDE. There are some solution for Vim or terminal editor?
So yeah, I mean, so we have an Eclipse and the VS Code editors. If somebody is looking for something else, probably the lighter one would be to make use of the probably a CLI. So CLI is having an everything. So you could able to create a project, build and flash, serial monitor, everything you could do. But if someone is looking for open OCD kind of debugging features, probably then yeah, they can use Espressif-IDE or the VS Code extension for this.
Okay, next question. Apart from flashing the target, does Espressif-IDE support communication with the chip and getting some info, for instance, reading out fuses summary?
So this is not implemented directly within the Espressif-IDE, but so there is already a Python script from the ESP IDF. So, but this could be achieved within the Espressif-IDE if you could able to open the there's something called ESP-IDF terminal from the Eclipse. So this is already pre-configured with all the components like the ESP core dump or eFuse. So you should be able to access those the script file directly from the terminal, and they should be able to run those commands. But yeah, as such, the view is not implemented for the eFuse for verifying that.
Okay, and we have last two questions. One is from Rodrigo Garcia. Is it possible to debug and monitor several FreeRTOS tasks at the same time?
So this is not implemented yet, but Eclipse CDT is having something on this where you should be able to view the tasks and the threads. Probably, you could expect this feature with the integration of ESP-IDF in the next couple of months. Yeah, but as of now, it's not there.
Okay, and the last question for you guys. How to run a menu config in the IDE before it first time compiled the code and build the SDK config JSON file. Also, how to run summary chip information ESP tool. Thank you.
So yeah, so currently this SDK config file editor is available only after the build. Probably we'll take this as a the feature request. What we could do is maybe the moment we create a project, we will generate the SDK config file with the default settings, and maybe with ESP that we will try to open the editor. So yeah, that's something we will consider. But as of now, this is not implemented. So SDK config editor is only available after the build with the selected target.
Okay. Also, one small note to this, that it's possible to open ESP-IDF terminal inside of ESP-IDE, and we can run IDF by menu config command there directly and change some options if it's necessary. So it is possible to do even now, but like as workaround.
So thank you for answering the questions live. We have a nice feedback. So it was a nice presentation, Dennis.
Thank you.
Bye-bye, guys.
Yeah, thank you, guys.
Bye. Now we will go to the Arduino talk.
Hello, my name is Rodrigo Garcia. I work with Espressif in the Arduino team. So let's start the presentation. Today, we will talk about Arduino and beyond. So as an overview, we'll start talking about Arduino. Then we will talk about how ESP32 Arduino is structured. Later on, we will talk about Lib Builder. And then finally, we will close with the Arduino's component topic. As an overview, I can say that Arduino was created in 2005 in the university in Italy, in the Institute of Design. And this project was made for non-programmer people. So basically people who deal with art, maybe design, and they wanted to use physical computing at the time. But they were not programmers, so they had no idea how to do that, how to deal with hardware, software. And the project was targeted for these people. But it started earlier in 2003 with a master project from Hernando Barragan from Colombia. And he created the Wire project, which is today the same structure used by Arduino. At the time, this project had seen few targets. So it should have an IDE for any operating system, Windows, Linux, or Mac OS. In this integrated environment, should be easy to learn the language, very simple framework. Everything should be integrated to that. So it means that the tool chains should be transparent to the user. The user should not deal with any detail of creating the application, including the bootloader. And it has a monitor, a serial monitor, in order to debug basically the software and help the users to understand what is going on when they're creating their projects. Of course, it has a very high abstraction level. It has a lot of libraries and examples, which is part of the program as well. So the idea is to create a community at the time. And this project was so good and well received by the community that it is very strong today. And a lot of different manufacturers of MCUs decided to support it, creating their own frameworks for Arduino. So what is basically Arduino? Arduino is composed by software and hardware. In our case, the hardware are the ESP32 boards, and the software is basically an API implementation. We can see a lot of details about this language and this API in the website of Arduino, which is the Arduino CC. It is based on C, C++, has a lot of classes and functions, and those are basically used for dealing with characters, strings, bit, bytes, math, random. In the case of the MCU, we can control GPIO with digital reading and writing. For analog ports as well, using PWM, for instance, the tone, which is creating sounds in different frequencies, use PWM, and it is a sort of analog writing. We can measure time. We can also monitor GPIOs if the signal is raising or not, or so we can create ISRs based on GPIOs and have a sort of let's say callbacks, or in the case ISRs for GPIO change of signal. There are also some basic support for keyboard and mouse, and of course it has a lot of APIs to talk to different external hardware sensors. Maybe some TFTs based on SPI or I2C, which is called wire in the case of Arduino, serial ports, and there is an abstraction called Stream API, which connects everything together, meaning that, for instance, if I want to read a string from a UART port, I can use Stream API to make the data coming from the UART going to a string or any kind of other data, reading specific data types. So what is ESP32 Arduino structure regarding the Arduino project? Today, we have two main versions. One is the version 10X. Today, the latest one is 106. It is based on IDF 3.3. And the problem with that, or let's say not the problem, but the way it was done, is that it has a lot of code in the API for Arduino based on register manipulation. So imagine that today we have different SoCs. So we have the ESP32, S2, S3, C3, and we had to support that based on that code. We would need to write a lot of code, a lot of testing, and it would be very time consuming. So in the version 206, which today is the 204, it is based on IDF, which means IDF for form. And everything was, all the Arduino API actually layer was refactored to use IDF drivers. So as IDF moves on and supports more and more SoCs, Arduino does the same in a very easy and fast way using IDF as base. In addition to the regular Arduino API, ESP32 also supports ADC, DAC, LED-C, RMT, Touch, Sigma Delta timers, PSRAM, USB, CDC, and MSC. Also, we have a number of libraries that support in the framework, I2S, SD cards, Ethernet, Wi-Fi, Bluetooth, Classic and BLE, OTA, file systems, different ones, protocols, HTTP, clients and servers, MDNS, DNS servers itself for IP addressing, and RainMaker, which is a project from Arduino, from ESP, from Espressif. Well, we support different SoCs. So today in the version 1.06, we only support ESP32. For the other 2.04, we support ESP32, the S2, C3, and S3 as well. And the layers are like that. So we have the MCU in the lower layer, of course, and then we have FreeRTOS that can be used, and it is used by IDF basically. So, but it can be used any place in the software. We have the ESP-IDF and how talking to the MCU itself, and the Arduino layer is split into two different layers, an upper and lower one. The lower one talks to the hall level and IDF as well, and the upper one is the Arduino API itself, which is used by the Arduino sketches and Arduino libraries as well. So the sketches can use libraries, and the libraries use the Arduino API as well as the sketches in Arduino. So this is basically what it is. Although, for instance, it is possible to create an Arduino sketch, and it might be basically purely written using IDF, which is very interesting, by the way, because IDF is integrated in Arduino, as I said. We will see that later on, how it is done. So we can build an application using Arduino using basically two methods. One is using the IDE, and then we have Arduino IDE and the VS Code with Platform IO. And also we can use Arduino's component in IDF, basically. So in the case of Arduino with an IDE, we can install packages, and one of the boards of the packages is ESP32. So let me show you how it is done. So this is the IDE from Arduino, basically. So we have a basic program. This is the wire, as I said, which has this implementation of a setup, which is run once, and loop is run every time in the loop, of course. And then we have in tools the board manager that allows us to add boards, and we can add ESP Arduino, which is in this case is the one official, the latest release, which is 2.04. And I have here this in a sketchbook Arduino, and this sketchbook is very interesting because I can add a board in my sketchbook, which is a list of sketches and programs from Arduino. And this board actually might be, for instance, the latest version from the GitHub of Arduino for ESP32. This first one is only the officially installed version, in the case 2.04. And I have different boards here. So you can see that we have S3, C3, S2, and the regular ESP32, along with other manufacturers from different places. I can set up everything here in terms of frequencies, modes, and if I want debug messages, PSRAM, and so on. In the case of Platform IO, I use VS Code as base. So I have Platform IO here. I can basically create programs, new projects, and they will be built using VS Code. So it's very similar to the IDE. It's a different way, of course, and it has its own way of setting up and installing. But the idea is the same. I use that to create, compile, build, and then link, and then upload any program done with Arduino to the hardware. So we can use the IDE to test and develop Arduino using the latest master branch from Arduino GitHub, using this board in the sketchbook, as you saw demonstrated in the IDE itself. It's not possible to be done with the platform IO, but only with the Arduino IDE. More information can be found in this URL. Let's see this URL really quickly. So here you see how to install the IDE and everything. There are instructions about it. It uses the IDE in Unix as example. There is also information about platform IO and how to build it and how to install the GitHub version in the board in the sketchbook. Basically here, there is all the information. We need to run this get. We will install the chain chain, basically. And then we can run it in the sketchbook. That's basically it. So any doubt, you can go to this URL and follow the instructions. So let's talk about Arduino Lib Builder. What is the point about Lib Builder? Why we need that? Basically because the GitHub in Arduino, it has many scripts for building the final releases, for running CI, even for updating IDF in the GitHub and creating new releases and versions upon the new releases of IDF itself. So as I said, today everything is based on IDF 4.4. This is a very important point because there is no way to run the Arduino core based on other versions of IDF. Only on the IDF 4.4 we can use 4.40, 4.41, and 4.42 today. Everything is compiled in the, let's say, in the IDE or any other place using the compilers for the framework in the API level. But it has IDF as well. So where the IDF enters in the process, IDF is precompiled into static libraries, and those libraries are part of the package of installation for Arduino. So the installation package has the libraries precompiled, also has all the header files for these IDF interfaces. So when we write any Arduino code and it is compiled, when it calls any IDF function, this IDF will be compiled against the header files and then linked against the static libraries. It means that we cannot change IDF in the Arduino framework. And this is why we have Arduino Lib Builder, which will, of course, build every static library based on a certain version of IDF. So this is why we have it. It builds all the IDF components and also some external libraries for each one of the ESP32 SoCs. So for the S2, S3, and C3. And what are the external libraries in this case? We have RainMaker. We have, for instance, any image recognition, speech recognition. Any kind of IDF project can be built and also added to the process with Lib Builder. So it's not just about IDF component, but also about any project from IDF as well. So basically, it's what I said. It has all the static precompiled libraries. And then we can see that in the GitHub. There is a GitHub for that. And I will show you this GitHub and how it works, basically. So this is the Arduino Lib Builder GitHub. We have here the files and some instruction. It's very basic. We need to pre-install all the tools we need in Linux. It's done with Linux, basically. There is no way to use, or maybe Mac OS as well, of course, but no Windows support at this time. So we clone it. and we run build shell, the script. And this script has some different options. As we can see here in the script, we have these options, and what we do is when we install it, we basically build everything. We build for all the SOCs, we build all the libraries and everything that is needed. Everything is listed in different descriptors that are in this GitHub. And we can do certain phases or pieces of it. For instance, we can just compile, we can build it, we can install it directly in our Arduino space. We can define targets. For instance, we only want to build for the S3 or the C3. We can deploy it directly. We have different options here in this script, and we can do whatever we need. So let me show you how it is done in Windows. In the case, there is a way, and this way is basically using Ubuntu in the WSL of Windows. So here we have the structure in Lib Builder. I just cloned the GitHub here, and I started building some stuff using the build script here. So when the build script runs, it downloads components. So if I go to components and list it, components, we'll see the different components here: RainMaker, speech recognition, camera, LittleFS, graphics, and so on, including Arduino as a component here. So it is a sort of application, by the way. Everything is built, and we see the results in the out folder. So now we have this structure, and this is what has been created by Lib Builder. And if we go to the SDK, we'll see ESP32 because I didn't build it for the other SOCs, but we'll have everything listed here, which is very similar to the structure we have in the Arduino installation itself. So this is replaced directly in the Arduino installation, and we have everything there. You'll see I'll show that in the folder here. So this is the folder installation for Arduino. Basically, what Lib Builder will do, will create this space here for SDK. And we have here all the different chips. And each chip will have its own SDK config, and the libraries will be right here. You see all the precompiled libraries here. This is done by Lib Builder. Everything here, all the components and all the different projects such as speech recognition and so on. Everything here. And then if we go to the include, we'll see everything related to the components of IDF, which is included in the Arduino project itself. It's pretty easy, straightforward. So Lib Builder is used to build Arduino itself, all the project, and the layers for IDF here, which are precompiled, as I said. So as I said, Lib Builder is used to build libraries, static libraries, and create the layer and the package of installation for Arduino, ESP32 Arduino, basically. So who uses that? Us, developers of the project, and also some developers of a specific project, such as RainMaker. They need to test that against Arduino, so they use Lib Builder for that. It is one way of testing and making sure that all the project will be correctly created based on Lib Builder, and will run correctly with the package of installation for ESP32 Arduino. But there is another way, and this way is basically Arduino's component, in the case using IDF44. So one interesting thing about the GitHub for Arduino in ESP32 is that it is already configured to be an IDF component. So it has all the necessary files, such as the CMake list, and also the kconfig file in order to use makeconfig, the config menu, actually. So it is a native IDF component of IDF project it is very easy to be used. So we can find more information how to install it here. But I have created a different way of doing that, and I will describe it and demonstrate it in a few minutes. So let's see this website. So this is the website for installing Arduino's component here. And basically it has some instructions. I will present a different way of doing that, maybe a faster way and with less errors. And when we do that, we can create in the component in our project directly a sketch like that, for instance, which basically just prints loop every second and run it in IDF directly. It's very interesting. I'll show you how to do that. And that's a very good way because I can again change IDF setup here, also modify my application, my version of Arduino. If I want to, I can just go directly to the different layers of Arduino API and change it the way I want. Create literally my own Arduino. It is very, 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 very interesting. Let me show you how. So I will talk about how to create this Arduino's component in a few steps. First, we need to install IDF 4.4, any version of it. The 2.04 version Arduino Core uses IDF 4.4.1, and I will show you which commit is used for that. We then create a project. We can just copy, for instance, IDF example from the get started like hello world to that project and modify it from that version. It's pretty easy to do that. Inside the project, our project, we create a folder called components. And then we go to that folder. We clone GitHub as folder Arduino there. And basically, we will then use it there. Then we will have our project component Arduino from GitHub. Then we go to the Arduino. We check out the desired Arduino Core commit. In the case of 2.04 Arduino Core, we check out the branch C93BF11, and I will show how to see that, how to find that information. And then we can just copy the SDK config from Arduino for our specific target SoC in the project folder, which makes everything easier because with that we can use Wi-Fi, Bluetooth, everything there. We don't need to go in the menu config and configure one by one. We just go directly that and use the default SDK config from Arduino. We also copy the main CPP project from Arduino to the project main folder, which will be executed by IDF. And then we change CMake list in the project to include the files we use in our project. We go to the menu config and turn on auto start Arduino setup and loop boot to make it run directly as an Arduino application. And finally, we build the IDF project using IDF PY. So, and then we will upload it to the hardware and run it and see the monitor most probably see run. Let me demonstrate to you how to do that. Okay, so I have here my IDF applications. So I'll create some folder, and what I have here is Windows. So what I have here is just Arduino. I just have cloned Arduino here to make it faster. So using this command and making it more easy to be used. So I'm gonna create a project. So let's say it is Arduino demo. So I go to that. So we create the project here, and we start with that, and we will copy an IDF example directly here to make it faster. Let me show you how. So I go to the IDF installation, go to examples, I go to get started, as I said. Then we take the hello world, copy that, and then we copy that directly to the IDF applications. Let's get the content of it. So this is the example. It's a pure IDF example. I go to my project and copy that right here. So I have everything done here. You see that we have a main with the program. In this program, basically, is just a basic IDF application that keeps a countdown. Oops. Makes a countdown and restarts ESP. That's what it does. But we will just replace it. So let's show how to do that. So once I'm here, what I'm gonna do, I will copy the Arduino to here. So as I said, I need to create the components folder. And then in the components folder, I will copy the Arduino. I should clone that, but I will just copy that. It will be faster. So I go here, take this, and just move it inside components. Right? So it's like if we move to components, it's like we have Arduino cloned here. We go to Arduino. And then if we see it, it has everything regarding the Arduino project from GitHub. So whatever you do, basically, if I go with git status, I will see that it has already its status there, and I can check out a version. So I'll go and check out, as I said, the version for the Arduino Core 204, which is the one I will paste here. So check out the version. This is the version, the branch, and also the commit for this specific version. It is important sometimes, but in our case for 204, it is important because GitHub for Arduinos is way forward, so we need to use the latest version to make everything sure that everything is rightly done. So I just go and check out that version, which is the 204. And how did I get that version, this number here, this commit? Well, I got it from GitHub itself, from the release GitHub. So let me show you that. So as I said, where do I see which commit I should use for Arduino GitHub? So I go to releases in the GitHub, and then I see the C3BF11 here, and this is the commit that created the version 204. So that's why I check out this specific commit. So I have everything in sync. I have the code for Arduino API layer, and also IDF, and also the right commit here. So everything is correctly set up. So right after that, what I have here is the right component. And what I need to do basically is get the main app done and installed, which will be run by IDF. And also I need the SDK config as well. So what I'm gonna do, I'm gonna copy everything there. So I'm gonna go to tools, then I go to SDK, and I see the different SOCs here, and I will demonstrate how to do that, how to create using ESP32 and ESP32C3. So let's go to ESP32. When I go here, I see SDK config, so I'm gonna copy SDK config to my main project. Oops, I need to use the other bar. So 1, 2, 3, 4, 5. 2, 3, 4, 5. Yes. And I will copy that with the name SDK config.esp32. Then I'll do the same for the C3. And I will call it C3. Then I will copy the main application from IDF, because Arduino is based on IDF and it has the app main there too. So I'll copy that to the project as well. I go to course and I go to ESP32. Here is the Arduino layer itself. So here I will copy the main CPP file from Arduino, the project itself. So go to course, Arduino, components, the project, and then I should have a folder main. So I'm copying basically to the main project path. So if I go back, now I am in the project folder, and I see they have these two SDK configs. So I will start with the ESP32. So I just copy the SDK config, ESP32 as SDK config, which will be used for this project. And another thing I can do, I can just go and change the name of the project. So for that, I change CMake list. And I edit that. Let me show you real quick. I can change the name here and change it maybe for anything, for Arduino test, for instance, or anything like that. So just go ahead and save it. That will be the name of the project and the binary as well, binary file. Then I go to the main source code. If I see it, I will see the hello world, which I will just delete because we will not use it. We will use the main CPP file basically. And then here, what I want to do is to edit the make file. But before that, if we look into the main CPP, as I said, it starts Arduino and runs setup and loop. So we need to create some source code for the sketch itself, which has the setup and loop code. So what we're gonna do, I will just go ahead and create this program, which is basically, for instance, sketch CPP, and I will edit that. Yes, I will create a new one. Then I will just start including Arduino, which is important in this case. Otherwise, it doesn't know how to find all the header files. Then I just go here and do a setup, create the functions for wire, which is used by Arduino. And basically what I do is to start the serial port. Wait that to start. And then I finally do nothing else. I just do that. And I go to the loop, which is very basic loop. And what I will do is just use the serial, the UART in this case, print something. And hold for instance, 2 seconds. So we'll see something that will just write loop, 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 loop every time. That's what this sketch will do. It's very basic. It's just an example. So I just save it, keep it here in case we have any error here. So as we see it here, we have two basically files. So I need to edit CMake to include those two, the main CPP and the sketch CPP. So I go and on and ahead and basically edit the CMake file, CMake list. And here we had hello world. So now we're gonna have the main CPP and also sketch CPP. Build using those two source files. Save it. And then we just close it. So here we are done. We'll go to the main folder. We list it. We have the SDK config. So we can go ahead and we execute IDF menu config. So we can set up it to run Arduino here. And I will just show you how. Take some time. I will display the menu right away. So now we are in the SDK config. We can see that we have the configuration for Arduino here. So if I enter that, what I need to do basically, I need to auto start Arduino setup and loop, which is set up here. I can change different setups for the Arduino itself. I don't used to do that, but this is how we do it. So we need to make sure that the auto start Arduino setup and loop on boot is on. And then if we need to change anything and we want to change anything on the components, we can go here and do everything. We can see that Bluetooth, for instance, is on, Wi-Fi and everything else that Arduino used to have. So I go ahead and save it. And then I quit. And then I go and build it. And flash it to the ESP32. So I'm going to use an ESP32 board here. I will connect it. So I have it right here, as you can see, running. And I will flash it. So I flash. And then I need to set up the port. So the port will be COM3. Flash it and run the monitor to see the results. So we should see loop, 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 loop. It will take a while. So I will come back as soon as it is already compiled and flashed to be faster. Usually it basically, what it does is compile the bootloader first, which is being done right now. We can change all the setup for the bootloader in the IDF menu config if necessary. We'll finish the bootloader. We'll issue a message for that as part of the IDF building process. So we wait a little bit more. Then it will start building basically the IDF components. That's is done also in the process. Then after that, it will start basically, which is now doing all the IDF, we'll start basically creating, building the Arduino layer as well. So we'll compile the Arduino as component here. And when everything is compiled, we should see the final results because they will flash it and we'll we'll run it and display the monitor and serial port results here. We might see some warnings along the process, which is okay. Don't worry about it. There is no big deal. So once we compile it and we change only the sketch itself and we change the Arduino software we have and we are creating, and the build process, it will not compile the bootloader or the IDF layer again. So it will be faster. We'll see that it is possible to be done. And we'll see that it works fine, very fast. So I will show you also how we can do it for the C3 as well. So if we want to use the C3, all we need to do is to change the SDK config file and use the C3 version for that. We need to clean the whole build folder as first, of course, otherwise it will issue some errors there. So as you can see, there are some warnings. Don't worry about it. Again, these warnings are from the IDF components for now. Soon we'll see a lot of warnings from Arduino layer as well. Now it's basically compiling all the libraries from Arduino, ESP32 libraries, Arduino libraries. And then we should very quickly get to the end of the process. Okay, it's uploading the sketch, and we'll see very fast it running. As you can see, every 2 seconds, it prints loop, which is exactly the sketch we created before. So it's running as Arduino as a component in IDF, as you can see. Everything is fine. We can stop it. And then I will demonstrate to you that we can just change it. So if I go to the sketch itself, I can change it here to anything and rebuild it and re-upload it again. So let me show you the Wi-Fi example very real quick here. So where are the examples? The examples are in 2 places, basically. I can go to the here to the in the code. I go to libraries. Then, for instance, for Wi-Fi, I look for the Wi-Fi library here in the GitHub. Inside the library, I have examples. And I can pick any example here. So I'm going to pick the scan example. And I go to the sketch, which is this file. And this is a pure, let's say, Arduino code. And then I just go here and copy it. Then I go to the notepad. And I overwrite it with the example from for Wi-Fi. Save it. Then if I go to the, again, to the project, I can just issue the same command. It will build it again, will be faster because it will build just the Arduino portion of it. So it has already compiled IDF, all the bootloaders, everything is sort of already done. So it should be very fast. At least I hope so. Yes, it is fast. It's already uploading. And we'll run the same sketch, we just change it. You will see that sketch running here and scanning my Wi-Fi, showing the networks around me. SSIDs basically. So those are the SSID around me. So you see that Wi-Fi is working here and scanning Wi-Fi, showing all the networks here in the region. I can just stop it. Let's say I want to change it to the, because I'm running, as I said, on the ESP32, right? So I want to run it in the C3. What I need to do? I just change the chip. I go to the C3. Now connect it. Will be a new COM file. Now it's the C3 here now. So what I need to do is just change the SDK config. So what I do is just go to the and copy the SDK config. So I copy SDK config ESP32 SC3 to SDK config, and we are done. That's all I need to do. It's copied. It's now C3, and I need to run IDF PY and clean it up. So I go for a full clean, because otherwise it will tell me that I'm in the wrong target. So I clean it, and I run it again, of course, in a different port, because we changed the board, so now it's COM4. It will take again some while to compile everything again and upload it, and you'll see that running on C3, and then I will change the sketch and we will finish the demonstration. So I'm gonna cut and we go to the end real quick, because it takes a couple minutes to compile and build it and etc. Okay, so it's uploading the software to the C3, and we'll see that it's scanning Wi-Fi in the C3 now with the same sketch, just changing the SDK config. We changed the target as well, which is really very fast and easy to do. So you see it's running already and displaying the Wi-Fi here. So guys, this is basically it. The last change we're gonna do, I will show you another demonstration for the C3, which will run the RGB LED here, Neo LED LED for the C3, and it will blink. And the target here again will be the C3. So let me show you that. So we go again to the libraries in ESP32. We go to the ESP32. Then we go to examples again, and we go to the RMT example. We have the new pixel example, which basically is an example that suppose that we have a number of new pixels in sequence, a total of 32 new pixels, and that will basically blink one by one, moving the light from the first to the last LED. So in our case, we just have one LED. So the final result will be that that LED will blink. So you will see that, and this is the sketch for Arduino to use RMT. So we have the functions here, RMT write, and the setup, and so on. Here, set clock, init, and so on, to use RMT and ESP32. So we'll copy that and paste it again in the same sketch file. So here we had the Wi-Fi. We'll delete it, and we'll replace it with the RMT sketch. Basically, we save it again, and then we rebuild it and re-upload it using the IDF. So we do the same command for the COM4, which is the C3 port, and you will see that it will be very fast again, because it doesn't need to build IDF again. It just the sketch. So it's already uploaded it, and it will run, and it will see that blinking here. You see? So it blinks the LED, and that was very easy and fast, as you can see. And this is the end of our demonstration. I hope that you have enjoyed the presentation. We should move now to the Q&A session. So guys, if you have any questions, I'm here to help. Please go ahead, make your questions, and I will answer them. Thank you.
Hello, Rodrigo.
Hello.
Perfect. So we can hear you. So we can just start with the first question.
Mm-hmm.
What is the ESP32 Arduino's versioning scheme, semantic versioning, and what is the relation between IDF and Arduino versions? For example, is there an Arduino release for every IDF release?
So starting by the last question, no, there is no Arduino release for every IDF release version. Basically, I said in the presentation, we have two, let's say, families of Arduino cores. One is the 10X, and this one is based on IDF3. And then we have also the current Arduino core, which is 20X. Today is 205 at this time. Different from what I said in the presentation. The presentation was 204, so everything is evolving very fast. And the version 205 is based on IDF 4.4. We're currently working to support also IDF 5. So you can expect maybe something by the beginning of next year for IDF 5. And this new version will be there. And most probably going to move to a new release version for the Arduino core. It might be like 3.0 something, for instance. So there is no relationship between versioning schemes from Arduino to IDF.
Okay, perfect. The next question. Is ESP-IDF environment more fast than Arduino environment at the runtime?
Not actually, because both are compiled. At the end, everything is quite the same. The only difference is that Arduino is just a kind of a layer, let's say a software layer on top of IDF. So it's in the final or the end of the process, an Arduino Sketch is actually an IDF application, let's say somehow. So they're all together and the performance will be exactly the same.
Okay, thank you. Let's jump to another one. If Arduino wants to enable a particular IDF config option, but the underlying IDF is precompiled, what are some of the ways users can enable that config option?
Okay, there are two ways, as I said, to build an Arduino application. One is using the IDE itself, and in the case of IDE or even with Platform I/O, you will rely on a precompiled IDF libraries. So when we think that we are installing Platform I/O or we are installing, for instance, the IDE, and we decide which core we want to use from Arduino, it will upload a package. In this package, will have IDF libraries precompiled. So when using those IDEs, there is no way to change that. But if you use Arduino's component, yes, you can do whatever you want, actually, because you can try to run it, although, as I said, there is this linkage between Arduino version and the IDF that's being used. So you need to keep the same version somehow, but you can change some stuff, for instance, for menu config or anything like that. You can change maybe some IDF configuration on that and build your own, let's say, configuration. So there is no way of changing the IDF, but the configuration of IDF can be changed through the Arduino's component, which is not possible when using IDE, any kind of that, Arduino or Platform I/O.
Following question. Are there any things to do if we use ULP?
No, actually, ULP, if you think about it, IDF can build it. If you use, there are two ways to use ULP. One way is using the macros from IDF. Those macros are used in the Arduino. There are examples in Arduino with those macros, so you can use and do the same. ULP in the macros will be kind of creating a space in the memory and the RTC memory where you're gonna put your program, let's say, and your opcodes will be there to be executed by the ULP. If you use IDF itself for building ULP, you're going to have maybe some assembly, let's say, kind of code. And IDF has already everything in place to build it and link it as a blob, let's say binary blob, to be, again, copied to the RTC memory space and executed by ULP.
I have one more question for you. The last one. What's the proper method to add Arduino library? Now I have to modify CMake list inside Arduino component.
Yeah, well, there are two ways to do that. One way is using, both ways are using make list, CMake list. So if you want to do it maybe simple, you can go to your application folder, which is the main folder. There you just edit the CMake for the application, not from the Arduino library itself. You can add, for instance, include directories and include source files, create your library folder inside your main application folder, and then add that library folder in your CMake inside your application CMake, and that will be included in the process of compilation, and it can have everything just copy all the libraries from that you use in Arduino, the versions you want to, directly to this folder inside the folder for the application itself, and they will be compiled and also included. There are also some questions sometimes about how do I do, for instance, to use PSRAM. So because the IDE, it will set up a symbol, it will define a symbol for all the compiling process. So another way to do that, again, is in the CMake file for the application. You can define that any defines, additional defines there too, it is possible. In particular, for if you want to modify the way, for instance, for PSRAM, you might need to add that actually to the CMake in the Arduino library itself and the component. So you define, for instance, that the chip has PSRAM there. That will be the same that the IDE will do for the building process. So in that particular case, you need to do it most probably in the Arduino library component folder. But for libraries in the Arduino, you can do it both in the Arduino component CMake, or if you want to, in your application side too. In case you need to use the CMake list and modify it, there is no other way, or this is maybe the best way actually to do it.
Thank you, Rodrigo. So I think our time is over. I just see some new questions, of course, in the chat. So I will just gladly ask you to go to the chat and answer them by written form. And I'm sending the greetings to Brazil, and see you.
Thank
Bye-bye.
you. Thank you very much. See you. Bye-bye.
And for all of you viewers, I will just recommend to stay in the streaming, because we are now in front of a very interesting talk from Adafruit, and it's going to be about CircuitPython.
Hey everybody, it's me, Lady Ada, and I'm here at Espressif DevCon. I want to talk a little bit about some of the work that Adafruit and all of its amazing team members have been working on over the last few years using ESP Espressif chips, and also some of the stuff that Adafruit's been selling and how and why we've been doing CircuitPython, which is the topic of today's little chit chat that we've recorded here. What Adafruit's done for the last 15 years is sell a lot of open source hardware. That means that I design circuit boards using Espressif chips, for example, and then we sell the assembled boards, tested, ready to go with documentation. We also release firmware, software, and hardware under open source licenses, usually MIT or BSD license, so people can take that code, that hardware, remix it, and reuse it into their own products or projects. This is great for the engineering and development community because they get a little bit of a head start. They have known working schematic, known working code, and as we'll see, there's actually quite a bit of the pieces and parts that make up CircuitPython that even if you're not using CircuitPython, you might be interested in as a developer of ESP-IDF, or Arduino, or MicroPython. So I thought we'd first start off with just talking a little bit about how we got to CircuitPython, because I think it's an interesting story. A lot of people are like, why do we need interpreted languages? Isn't assembly good enough? Like, why don't we just write everything in Tensilica or ESP-IDF or whatever low-level code? And I think one thing that's interesting to remember is that when the first Espressif chips hit the maker developer market, not just the Wi-Fi chips that were meant to be used in a Linux system, but actually like development boards, the ESP-01 and the ESP-8266 modules, they often came with either AT firmware, which meant that you would control the ESP chip itself as a Wi-Fi coprocessor. You'd send it commands like, AT, Wi-Fi connect, AT, socket open, etc., and you would connect to a Wi-Fi website. You would be able to send and receive data. You could even set up a little server, open up sockets, UDP, TCP, etc. And then, people started with that, and we actually had a couple of guides showing how people could use something like an Arduino Uno, connect over serial to an Espressif chip to the wider world for Wi-Fi. It was extremely affordable. And then what we saw actually, which is a little interesting, is some folks, I'm assuming that they were at Espressif, but to be honest, I should have looked this up before I did this video. They ported the Lua scripting language to the ESP-8266. And this was really interesting because the 8266, it's this Wi-Fi processor. It has the radio built in, but it also had enough RAM and flash, built-in memory, to be able to run a scripting language. Like, yes, you could write code in C or an Arduino E's, but there was some benefit to Lua, which is a scripting language that's often used by game developers to like automate and run within their games engine. But it was, it's a scripting language that allows you to write code quickly. The script is run within the virtual machine that's running on the ESP-8266. And I think that having Lua available was what kind of prompted a lot of people to think about, what if we used interpreted languages instead of just compiled languages like C or Rust or, assembler or C++ or, whatever your favorite compiled language is. So in 2016, we saw a Kickstarter by Damien George, who is the author of MicroPython. And he had been working on MicroPython, a small microcontroller-based Python interpreter for the STM32 series chips. And the STM32 series were, of course, Cortex chips. But he was really interested in this idea of the 8266 being available, has Wi-Fi, and how this could really be a powerful way to introduce interpreted Python on a microcontroller while also bringing in IoT. And for reasons I'll show later, it's a really, really good match. So when he did this Kickstarter, first off, a lot of people got very excited. It got a lot of funding. We chatted with Damien and actually contributed, not just by funding him, but also we wrote a whole bunch of tutorials and guides for MicroPython. And because we thought it was really neat to see, like, okay, you've got this powerful chip. It's so powerful that maybe you have a little bit of extra processing time and speed, and it's interpreted so it's slower, but maybe it's okay. Maybe you're not CPU bound as much or memory bound. Having that run on ESP-8266. So we actually ended up writing a bunch of tutorials and a bunch of guides and a bunch of libraries for MicroPython. People still use them for the 8266. And, that was super cool and great for a very long time. And we still think it's, MicroPython is definitely a really good alternative to CircuitPython. CircuitPython is not meant to replace MicroPython. They live side by side. The goal of CircuitPython is to make things easier for beginners, because we have a lot of customers who are students or they're beginning engineers, or they just want to get started really fast. And so our goal is to make things really, really easy and unified, have the same code run under CPython as CircuitPython. All platforms should have the same API. So a couple of these engineering decisions that we made were incompatible with MicroPython, and this is why we ended up going with CircuitPython. We renamed it because we didn't want to cause any confusion. That said, we still commit code to mainline MicroPython through pull requests, and vice versa. We like to keep up. And we collaborate all the time on stuff. Like async IO is one of the ways to do asynchronous, not threaded, but multiple threads of control type computation on CircuitPython, MicroPython. It's something that we chat with MicroPython to collaborate with. So, one of the questions that we do get a lot, is like, why would you want to have an interpreted language? You're going to be using so much more power. You're going to be using so much more memory. And I guess for us, or at least for me, I've spent a lot of my life in tool chains. I have this Windows computer here, and it's got 8,000 tool chains installed on it, from TI, from STM, from Atmel, Microchip, from Espressif, multiple versions of the IDF, Arduino, multiple versions. And when I think about when I started with electronics, the way you would program, I programmed PIC microcontrollers. And a lot of people watching this probably started with these early microcontrollers. Flash memory wasn't yet affordable, so they were UV-EEPROM programmable. And so whenever you wanted to write code, which was often in assembler or in a very, very low level C, you would have to write your code, you'd compile it into a binary, which didn't take that long, but then to upload the code, you'd have to literally remove the chip from your board. You'd put it in a UV eraser, you'd wait 10 minutes, take it out, and now it's erased, and then you could program it with your code and then you'd test it. So every cycle of compilation and testing took 10, 15 minutes. And if you tried to rush through the UV process, if folks remember, you'd end up not actually erasing the whole chip. You'd have to kind of start over because it wouldn't verify right. So one of the things that was really nice about moving from UV to Flash to bootloader type development, such as with Arduino, is that cycle of coding, compiling, upload, testing, debugging is getting faster and faster and faster. What was 10 minutes, 15 minutes with UV-EEPROMs, once you got to Flash, okay, maybe it's 2 to 3 minutes, and then, and you'd have to physically maybe do some connecting or bootloading. Then with Arduino, with auto reset and auto bootloading, maybe it would be even faster. It would be 30 seconds to a minute. And that really sped up the ability for people to learn and iterate on their designs. However, and I think this is something that people who work with the ESP-IDF know, even with Ninja and really fast makefiles and configurations, it still does take quite a while to compile code and then upload that to Flash. I mean, Flash memory, it actually becomes a little bit of your time bound because you have to erase blocks, and that takes time, and then you have to reprogram the blocks. So unless you have some sort of really cool mapped memory Flash, your code goes into a section and you don't have to erase the whole thing, it still does take quite a bit of time to do a development cycle, even if your compilation is now optimized, which I know people have been working a lot on, and I commend them. It's much faster to compile code for Espressif than many other platforms. But that said, what if instead of 30 seconds, it was 2 seconds? What if it was instant? What if it was something you could do from your web browser? What if it was something you didn't even have to install a tool chain for? And that's kind of the goal of CircuitPython is, yes, you're going to be a little slower. Yes, it's going to take more memory. Yes, if you want optimized, very speedy parts, you have to write that in C, and you have to kind of build it into CircuitPython, which I'll show later. But if you're doing prototyping, development, or you just need a very fast cycle of iteration, especially I've noticed with doing robotics, anything when you have to do heuristics or calibration or customization or user interfaces, that fast iteration cycle in CircuitPython is really joyful compared to the compile, upload, erase Flash, program Flash, open up your terminal, debug. So we're going to go look at that process. I also want to just show really fast some of the hardware. So let's go to the overhead, and I'll just quickly show off some boards just so people know what we're talking about. So this is, Featherboard ESP-8266 and ESP-32. People really like these. And then We've now got boards that have built-in screens on them. This is at ESP S2. This is a board that has built-in battery and ESP S2. And then on the top, there's an e-ink display. This is another ESP32 classic, not the S series. We also have S3 and C3 in addition. So let's now that we've introduced everything, we've just explained what we're going to do, let's actually show what it's like to use CircuitPython on the Feather ESP32 and ESP32 S2. Okay, so everything that you need to play around with CircuitPython is available on circuitpython.org. That is the website that I'm at right now. And we have tutorials linked from here, but most people want to get started immediately by going to the downloads page. And the download page has 340 different boards, not just stuff from Adafruit. We support all sorts of makers. Anyone can submit a PR to add support for their board, and the board definition, you just need to have your own USB VID and PID. The board that we're going to be playing with today is the ESP32 S2 TFT, which is this one. And we have usually a stable release and kind of a cutting edge release. Right now we're working on CircuitPython 8.00, which is like our big Espressif release. We're adding a lot more support for ESP32 boards, including the classic ESP32. You can download either binary, which is, you would burn that directly with ESP tool, or you can download a UF2. So a UF2 is a file format that we really like to use that is compatible with mass storage bootloaders. So if we go to the overhead real fast, I'll show off the mass storage bootloader. Because the ESP32 S2 has native USB, which I think is amazing, and so does the S3, there is the ROM bootloader, and then on top of that we install what we call the UF2 bootloader. And the UF2 bootloader takes advantage of the mass storage interface over native USB to allow you to drag and drop a file. Why? Because there's actually a lot of people for whom installing ESP tool is a bit of a struggle, especially if you have an older Mac and the Python is 2.7 and you got to install Homebrew. Basically, it's like if you can get them to run the TinyUF2 bootloader, it's very easy to upload new code. You just double click the reset button and drag a file on. So if you go to the computer, the Feather now shows up as a disk drive. It contains current UF2, which is the current firmware, index HTML, which if you double click it will take you to the page, and then info UF2, which tells you, what version you're running of the TinyUF2 bootloader. And then I can just take that file. Hold on. I can take that UF2 file. I just drag it on, and then it'll burn the bootloader. It takes some time, it's erasing the flash and reprogramming it. And then when the board comes up, which it will in a moment, it shows up as a disk drive called CircuitPy. So if you look on my computer, there's one disk drive here called CircuitPy, again, taking advantage of native USB. You might be wondering, wow, this native USB stuff is really cool. What if I want to do it? Well, TinyUF2 is a USB low-level stack that is completely open source and runs on a variety of different processors, including Espressif. Espressif uses it in the ESP-IDF. So MIDI, somebody actually just added U2F, mass storage, CDC, HID, host if the chip supports it, all that stuff. There's example code in the TinyUF2 and TinyUSB GitHub repos. TinyUSB is the underlying USB stack. TinyUF2 is the UF2 mass storage bootloader built on top of TinyUSB. And this is developed by TAC, who is an Adafruit developer. So even if you don't use CircuitPython, please do check it out because it's a really awesome USB stack It's one of the only ones I know that is completely open source, freely licensed, and available for multiple processors. Okay, back to our CircuitPy drive. So again, for usability, one of the things that we really like is having the storage for code and files and accessories and everything you need for your development as mass storage. You know why? Because mass storage is the most universal USB interface. Everything supports it, including Android, Chromebooks, old Macs, new Macs, Linux, Windows. Even CDC can sometimes, USB CDC for serial command control. Sometimes you do need a driver on some computers, but mass storage is forever. And so it makes it really a great way to make sure that no matter what platform people are running, they don't need to have any special tool chains, because you can just double click the code.py file and then edit it directly. So I'm going to open this in Atom. So because the ESP chip has native USB, it has multiple endpoints, we actually show up as a composite device. We have mass storage, again, HID and MIDI as optional, and then CDC for the REPL. The REPL is the interface to the Python virtual machine. You can run commands within the REPL. So, I can, common one is you just type in 1 + 1, and it's like 2. Or, you can import a library, and then you can do, what's in that library. And then you can say, oh, what's the OSU name? And it's like, here's info about your board. So you can use the REPL to play around with. I think it's good for just very basic, like, how do you index within an array, and then, you want to try built-in functions within Python, like, oh, what's this, math command for exponentials or whatever. But for the most part, what you're going to do is put your code in the code.py file. And Scott, who's the lead developer for CircuitPython, and so came up with all the API and interface decisions, a lot of which were based on usability, had this idea, which at first I was a little bit shocked by. And he said, oh, I want to make it so whenever you save the code.py file, it will rerun the virtual machine. And I was like, that goes against everything I know as an engineer, but okay, let's try it. And actually, it's kind of cool. So what it means is that I can really quickly do development. So like, I already have this example code ready to go. I have a code.py file with a bunch of code in it, and I'm going to drag and drop all the files, and then, we can go through the details behind them later. So to put your code and your assets, library files, fonts, images, whatever accessories you need for your code, you just copy it on over mass storage, and then later I'll show what you do if you are like, what if I have a chip that doesn't have native USB, like the original ESP32? Don't worry, that's also possible. Okay, so let's replace all the files, and this is using the built-in 4 megabytes of SPI flash. We partition it out so you have, some of it's for firmware, some of it's for over-the-air, and then we have like a megabyte or so available for code. So let's close this and open the code. This is the code I'm running. So, there's all sorts of libraries you want to install, SSL and Wi-Fi and display support. One thing that's kind of neat is, if we go to the overhead real fast, the REPL, if you have a computer, if you have a microcontroller board with a built-in TFT, you can actually, as I'm typing into the REPL, hello, the same output echoes on the TFT. So it can be nice for debugging. You can see like what you're doing. All right, so let's go back to the computer. So in my code, what I'm going to do is I'm going to connect to the GitHub API over HTTPS. Having TLS 1.2 support is really awesome in the ESP32. And it will load up a bitmap, and it will load up a font. This is one of the things that was really powerful about CircuitPython. Things like, I just want to display a bitmap, or I want to parse a PCF standard format font and use it for my UI. It's trivial, and it's built into CircuitPython. We kind of like to have as much stuff built in for these kinds of advanced graphical interfaces. Also have like audio playback built in, stuff like that, with wave playback. It'll connect to the SSID, which is defined in a different file called secrets.py. You know, we like to have the configuration in different files so that people don't commit both files if they're working on it. You know, obviously you don't want to have your SSID, your passwords, or your, you know, GitHub token mixed in with the code. But it's very easy to load as a separate file off of the file system. And then it can open up a socket pool, create an SSL context, and then use requests, which is a very standard Python library that's actually originally was written for CPython on desktops, but we kind of made a very lightweight version that runs on microcontrollers that can use authorization tokens if you want to. It can add in stuff into the request, sort of like curl, to authenticate you or set you know, permissions or, you know, what have you, if you have to send tokens back and forth. And then what's really neat is that JSON parsing is built into CircuitPython, and it's also, you know, stuff like string parsing and error handling and dealing with, you know, binary hex data, and then you have to parse it. All that stuff that's really, really frustrating to do in C and C++. I know it's possible to parse JSON or CSV files, but I just really hate doing it in C. It's always, you know, either you're doing it by hand and you're kind of stumbling around, or you're doing it with a library and it's like this massive thing, and then, you know, even then, you know, one wrong comma or wrong quote, you know, you'll never figure out what the issue is, whereas the built-in JSON parser we have in CircuitPython is really reliable. You get the JSON, and then you just, you know, I'll show after I get this running, you could print out the JSON, and then I can print to the text REPL the output, and then display on the display the string, the text. So this is going to look at the number of stars that we have on the CircuitPython repo. So what's nice is that I just hit Control D in the REPL, and you'll see it's going to connect to the internet. It gets an IP address, it fetches the JSON, it has the display, it shows me the number on the screen, and if I go to the overhead, it'll show the number of stars. So, you know, that's a project I already had ready to go. And so, again, the power is now I want to really quickly iterate. So let's show what it's like to quickly iterate. So let's go to the computer. So first up, you know, I was connecting to the Adafruit repo, but I actually want to do Espressif ESP-IDF instead. And then second, you know, and I can save this, and it immediately starts running. So while it's running, I can also say, well, you know, I have this background image is what I'm displaying, but I actually want to display this background instead, because of course it's no longer displaying the CircuitPython demo. So, you know, the first change ran already, and it says, okay, yeah, the number of stars for this repo is 9,000 something. Cool. Let's change the background. So I'm going to save that. It's going to rerun immediately. And then if we go to the overhead, you'll see the graphics has instantaneously changed. And the reason you're actually not seeing the text is because it's white. So, oops, bug, let's go fix it real fast. On the code over here, where when I make a text label, let's make it red instead. And then let's also change a different font. I've got the impact font. So I'll change the font. And then when we rerun it and go to the overhead, you'll see this time my live demo shows the text. Now, of course, I can, now, you know, the text is in the wrong location. I can tweak the X and Y coordinate. But you see how fast it is. It's like the code, once I've got it, I can make 4 or 5 changes in about 30 seconds and instantly see the output. So that's the goal of CircuitPython, to make that iteration cycle so fast, it's actually enjoyable to code. Okay, finally, we're going to look at what happens if you don't have native USB and you don't have a display. Of course, it's a lot easier to do Wi-Fi development if you've got all that file dragging and dropping. For the CircuitPython 8.00 release, one of the things that we've added is this Wi-Fi web workflow. So this is an ESP32, the classic, does not have native USB, and it doesn't have a display on this feather. So let's go to the computer. So for this board, we do have a download for it, and you'll notice that CircuitPython 7 isn't available because this is new with 8. You download a bin file, because again, there's no TinyUF2 drag and drop bootloader. And then you'll use the ESP web flasher, which is written by Melissa here at Adafruit, which allows you to use web serial to upload code. And it's basically like ESP tool, but in the browser for Chromium browsers. And then once you've uploaded it, you can also configure the Wi-Fi SSID. And what's really neat is you can then go to http://circuitpython.local. And this will show up. This is running on the CircuitPython board itself. It has a little miniature web server that allows you to, first off, get information about the board and what the IP address is. And then there's a built-in, again, very simple serial terminal. So I can type in commands, which you can see now scrolling past my screen. And then there's also a file browser that you can use for, again, very basic, you want to upload files and you want to, say open your code.py and see what code is inside of there. But if you want to do some real development, we also have a web-based full code editor. And the full code editor, it connects to your computer via sockets, web sockets. You can open up your code.py file. It's got hello world here, but let's say I want to have some neopixels going on. I will copy and paste this code, save this as code.py, and it uploads the code to the ESP32 feather, and then let me kick it. When you restart it, when we go to the overhead, you'll see blinking neopixels. So, file management and serial terminal and code running, all that you can still do with the CDC port that you've got. But if you want to not have to muck around with using a special IDE, you can use our web-based Wi-Fi serial interface. So I think this will still make it really easy for people, even if you don't have native USB, which we do like, but there's still thousands of people with the classic ESP32, which we want to support. So that's kind of an introduction to CircuitPython, the ESP32, S2, S3, C3, and the native are supported. I think it's a really great match. The ESP32 is so powerful. IoT, I think, is a great match for CircuitPython. This is a great way to get started with development if you've never done IoT development. And it's a great way to iterate your design before you go into production.
Thanks, Adafruit, for excellent talk and also being able to reply in written form in the chat. So we are now just waiting for the last session of the very first Espressif Developer Conference 2022. This session is called General Q&A, and we will have Amey and Kedar from the India office who will answer some of the questions. I will add you, Amey and Kedar, to the live stream. And hello, guys. Can you hear me?
Hey, folks.
Hi, everyone.
How are you all?
Perfect. So we have you both. The video is working, sound is working. And just to clarify a bit the process, so we were watching the comments all the day long, and we sort some of the questions. Maybe some of them were just frequently asked, or we thought they are important. So we will just answer 8, 10 of questions from the day. We will just now post them from the Espressif account, but they have been answered by you, the audience. And after this is done, we will maybe pick also some questions from the chat. Maybe some interesting one will occur. So let's start with the first one. Can you describe how Matter will work in the real life? What will it change for the end user?
Yeah, I think I'll take this one. So I think what Matter does is that before Matter, the era before Matter, it was really hard to build smart or connected devices because there was, each ecosystem had its own specificities. You had to have iOS app, Android app linking with, different skills and voice assistants and stuff. So just building the products was in itself fairly complicated, which, made the overall cost of the devices on the higher side. And secondly, I think what happens is that because of this fragmentation of ecosystems, it was harder to get real value from ecosystems because the real value really comes when devices can interact with each other and you can create some interesting combinations there. I think that's exactly what Matter supports. Instead of having different ecosystems address these things, this is one standard where everybody has come together and said, hey, as long as devices support this particular standard, we'll make sure that we work with it in a very efficient way and in the best possible way. That is one big part of it. So, everybody's there, it's interoperable. Secondly, from a standard development perspective, they've made sure that some of the interesting use cases around device to device communication, communicating with across different transport protocols like Wi-Fi or 802.15.4 thread-based devices is really smooth. And finally, the focus on security, which will just ensure that there's a very standard way of making sure that everybody builds these apps. So I think those would be some of the top things that I think would definitely make a change as far as end users is concerned. I mean, if you want to add anything, feel free to.
Yeah, just probably one thing. I think Matter also enables higher level innovation in some ways, right? So, for example, Amazon ambient intelligence clusters or Google intelligent clusters, which can provide additional information like if the user is home or away to the devices in the format that Matter devices can understand, right? And that basically unlocks even the higher level innovation by the device manufacturers.
Okay, let's continue with the second question. For consumer product developer, can Matter and ESP RainMaker provide product diagnostics and performance feedback for individual products?
Kedar, you are on mute.
Sorry. Yeah. So this is something that we've been hearing a lot from customers where as developers want to understand more about how their devices are performing the field. Is there any diagnostics that they can get out of it and have some way of acting on it? And this is one of the reasons where we introduced ESP Insights, which acts like a central repository where all the devices in the field can submit certain logs or metrics. And then as a developer, you have a centralized view of the various things that are happening on the devices spread all throughout. You can look at graphs which are time-wise, and you can slice and dice the data to quickly understand what may be going wrong with the devices. And the framework being fairly generic, you can model different components there. So you can include it from a robustness perspective. You can include metrics so that you understand where the performance, how the performance varies, and you can use it for performance optimizations too.
Okay, let's have the next question. And is it, can you please explain the difference between thread border router and Matter bridges?
Yeah, so Matter supports Wi-Fi and 802.15.4. In terms of Matter, what they do is that because 802.15.4 is a separate standard, there is something called a border router, a thread border router, which ensures that IP connectivity is seamlessly achieved between the Wi-Fi side of the network and the 802.15.4 side of the network. And that's the value that a thread border router provides, and that allows us that makes sure that all the devices in the 802.15.4 and Wi-Fi side can communicate with each other properly. So support for thread is inherent within the Matter protocol. Having said that, there could be certain other transports that you could be using. It could be BLE mesh or anything outside which is not really Wi-Fi or 802.15.4. And in those cases, the Matter standard expects to use bridges, Matter bridges, where essentially the bridge is creating you can think of it like a bridge is creating a virtual device for every device that it is trying to bridge, and that's how it it literally bridges between a different transport and brings it onto the IP network that is accessible by Matter.
Okay, the next question, I have seen it, I think, under every talk discussion, so I hope we will just kind of answer it for a lot of viewers. And it's, when will ESP32H2 will be available? And what are going to be like the key differences for this chip?
Sure, I'll take that question. So ESP32H2, it will be available around the end of first quarter, early second quarter of next year for engineering samples. So basically, ESP32H2 being a first 802.15.4 chip with support for both Thread, ZigBee, and also Bluetooth Low Energy. There is a lot of interest in this chip right now. And I think in terms of the key differentiators, this chip is ideally focused for thread-based Matter devices, but also ZigBee use cases. And it has all the good features built into it, like a digital signature peripheral with ECDSA, which can really protect the Matter keys with hardware security. So yes, the key differentiator will be good security and good functionality at quite competitive cost points. I think that's how I would define the key differentiator for this chip.
Okay. So we can just summarize. It's close, guys. So hold on, and you will receive it soon. Next question: can the attributes for the ESP insights be posted over a cellular network?
Basically, what we've done with ESP Insights is that there's multiple different ways with which the insights data can be reported to the cloud. One is the device agents can obviously share the MQTT connection that they have for command and control with the cloud, and send their insights data to the cloud. At the same time, we've also included REST-based APIs. So let's say a device is not using MQTT, they could just use the REST API to post their diagnostics data to the cloud. Since the REST API is available, technically you can, any agent which is outside of the device could also potentially post this diagnostic information to the cloud over a cellular network. This is also a feature request sort of that we have heard from some of our early users, where they're trying to check whether the phone applications near the devices can gather any insights data over the BLE and then use their connectivity to send it to the insights cloud also. So this could help address scenarios where, for example, the device is getting some poor Wi-Fi connectivity. So the device in itself cannot post this data, but the phone app can act on their behalf and get this data out. So yeah, technically it can be done, yes. You'll have to find a way to extract that data from the devices and then send it to the cloud.
Following question is also about ESP Insights, and it's can ESP Insights be connected with AWS CloudWatch?
So connectors for ESP Insights is something that we've been working on, because as you can imagine, essentially we'll end up acquiring a lot of data in terms of metrics and logs from all these devices that are diagnostics data. And it is one of the activities that we are currently working on is to identify how can we easily connect this data to different consumers of this data. So right now this data is processed in our backend and then can be visualized using the insights dashboard, but there are customers who would want this data to be funneled into their own data pipelines where they can do their own slice and dice and other operations. So that is definitely something that we're working on. Specifically about the CloudWatch is it's an interesting idea and definitely worth exploring further. But yeah, it's this is one of the parts that we've been looking at very actively, and it's on the roadmap right now.
Okay, thank you. Next question is about ESP RainMaker, and can it be self-hosted, or is it only Espressif hosted instance?
Probably I'll take that question. So ESP RainMaker, yes, we do have a public instance of ESP RainMaker for all the hobbyists and maker community as well as academia. However, the way customers typically use ESP RainMaker is by hosting the same software in their own AWS account. And with that, customers get complete control over all the data that is getting generated, as well as the business logic that can be implemented on top of ESP RainMaker on the cloud side. So yes, in short, ESP RainMaker is a private cloud offering from Espressif, which can be self-hosted in your own AWS account. And Espressif managed cloud is always available to use for maker community, hobbyists, as well as academia.
Okay, thank you for the answer. Next question. How do we opt for commercial deployment for ESP RainMaker?
Yes, it is quite simple. For the commercial deployment, please get in touch with sales@espressif.com, and they will guide you through the process of doing the commercial deployment.
Okay, guys, so now the question, okay, we have one more we found out during the day, so I will share this one. Hello there, does Espressif offer Salesforce support with dedicated VA? We are a company that is going to buy a lot of chips, and we are currently struggling with the responsiveness of GitHub.
Yes, so I think, again, for all such requests where you need, where you are building a product and you want to go to production, I think the best way is, of course, to work with our forums and on GitHub issues, but sometimes you do need some dedicated support. I request you to use the form available on our website to raise such queries, and our business team will respond to you based on your queries appropriately. So I think that is the best way to get in touch with us, using the technical queries form that is available on our website in case of such type of requests.
Okay, perfect. So now the sorted questions are answered. So I think we have time to take a look on the questions in the chat. I just saw there have been like few questions about how to start projects and what is the best SOC for me. So let me highlight like this question, and I will gladly ask you guys to answer that. So the question is, can you quickly elaborate on what is the best use case for using ESP32 versus ESP32S3 versus ESP32C3, and how can I choose the best chip for the project?
Sure. So I think I would basically like to draw a timeline here, right? So ESP32 was launched in around early 2017, whereas C3 and S3 they were launched in 2021 and 2022 respectively. So ESP32 has seen many interesting use cases built around that, and those use cases can typically be classified into pure connectivity type of use cases versus some applications which require a lot more GPIO and a lot more compute power, which utilizes ESP32's dual core architecture, right? So I think that's where the split is essentially when we look at ESP32 S3 and C3. For any simple connectivity application, ESP32 C3 offers quite good functionality at a reasonable cost. But if you are building an application which requires, say, a higher number of GPIOs or parallel touch interface, parallel display interface, or a PSRAM to have a bigger memory for your applications, or running some neural networks or digital signal processing type of algorithms using AI acceleration available in S3, that's where S3 comes into the picture. Having said that, some of the functionality is unique to ESP32 as well. For example, you want to use Ethernet controller for your projects, ESP32 can still be a good choice of SoC.
Okay, we got also one question about the ESP-32 S3 box, which is like pretty favorite type of board. So let's highlight this one and we can try to answer it. So the question is, I want to start a hobby project with Matter and RainMaker. Can I use ESP-32 S3 box to control everything?
S3 box as a Matter controller, which is a device which can control other device, is a project that we are working on right now, because so far out of the gate what we support today is devices which are Matter endpoints, which can act as bulbs and switches. One of the things that we are working on right now is where the S3 box can act as a controller. Because Matter supports device-to-device automation, anyway one device can control the other device, but with a controller I think a few additional things like having the ability to commission other devices or acting as an OTA provider for other devices comes into picture. And those are certain things that we are working on, and especially with the S3 box, it's a very exciting scenario to be able to support that and have this hub kind of a functionality. So that's something we are definitely working on right now.
Okay, just to add one thing here, if you search for ESP Matter demo, you will see a demo video which includes S3 box acting as a Matter controller in the setup.
So I think we are just like picking up last 3 questions and we will finish. So the first one is, it is possible for Matter application to be customized?
Yes, so in terms of, Matter application could be a phone application, or it could be an application on the firmware. On the firmware side, with the connected home IP repository upstream, or even in the ESP Matter repository, there's a fair number of examples that we support, and we've all the code is available. You're free to customize. You can essentially at the Matter level, you have things like clusters, and then a cluster can have attributes and commands. There are a set of supported clusters, attributes, and commands that you can obviously add to the existing examples. At the same time, you're free to also define your own commands or attributes as extensions to these clusters, and then make them part of your applications as well. On the phone app side, there's, the upstream repository also has source code references for both Android as well as iOS. So you can take those and then start your customization from that side.
Okay. Any ideas about some other questions? Kedar or Amay, you just see in the chat.
Yeah, I do see an interesting question here. Can ESP privilege separation be used with CircuitPython? Kedar, do you want to answer that?
Yeah, so I think I was looking at, listening to the CircuitPython session. It was definitely interesting. That's one of the things that was going through my mind also, because one of the things that we've tried to do with ESP privilege separation is that since most of the parts stay in the kernel space, your user space application becomes fairly lightweight. You can quickly update it, and the speed with which you can do this is much faster. And it's something which is an often overlooked aspect of the whole user kernel separation, because most people are looking at it from a security point of view, but how quickly you can do it, because the size of the application is much smaller, is definitely of interest there. So so that's one of the ways that I was thinking about it as I went through this session, where I think there's definitely some synergies there which can be explored. The other part that the interpreted language sort of does is has this virtual machine, right? So you get some sense of separation between the host and the application that is running on top of that. So there's probably some redundancy there, but beyond that, I think there's definitely some interesting things that you can do with that speed.
Okay, so I think right now we are just a bit over 15 minutes, so we can finish this session. Thank you, Amey and Kedar, for joining. Bye-bye.
Thanks everyone. This was a great day of presentation, and look forward to listening to the sessions tomorrow. Thanks. Bye.
Thank you. So all the viewers, we are at the end of the first day. I will just clarify one question. A lot of you ask if the talks will be available later on YouTube. So don't be afraid. We will upload the talks so you can watch them later. And I hope you enjoyed the first day. Tomorrow there is going to be a small change, and instead of me, Pedro Minatel will be handling the Q&A moderating. And we will now just share the link for the tomorrow session. It's going to start again at 10 a.m. Central European Summer Time. So thanks a lot for joining. We appreciate it, and see you tomorrow. Bye-bye.